Hey, good morning all. For day 2 of Azure Community Conference, I welcome you all attendees from all over the world for sessions on track 9. Today we have Jose with us for kickstarting our sessions on this track. Jose will be taking you through a session on hosting, deploying, and scaling ASP.NET Core Blazor apps with SignalR service. Without any more to do, I'm handing it over to Jose to take you through the session. Thank you.
Thank you, Amar. Let me share my screen and let's get started. Okay. Okay, I think we're ready and let's get started. First things, welcome everyone to the Azure Community Conference 2021, the Indian largest Azure conference. I'm really excited to be here. And pumped. It's the end of my day right here in the United States, in Arizona. It's still October 29, 10 p.m. I'm feeling a little bit under the weather, but I think that there is not better way to end my day than just talking about Azure, about Blazor, about hosting, scalability, and everything else. I think that this is going to be a great hour. We have a lot of content to cover, so basically let's get to it. As always, it's good to acknowledge and to be thankful for all the sponsors that make this type of event happen. This event is an event for the community and by the community when we get together and we share our knowledge and we share our experience and we just pretty much collaborate together. I definitely looking forward to the workshop about blockchain that is happening tomorrow. So I will be there, and there is a lot of other great talks and great workshop. There is another one about Azure Function that is awesome. So please stay tuned. This will be an awesome couple of days. The topic that we're going to be talking today is hosting, deploying, and scaling ASP.NET Core Blazor server with SignalR service, and you will see that I'm going to spend more time talking about making this happening, all the configuration, all the deployment, all the scalability, they're actually doing it. We're going to do a demo and we'll be real quick, and we're going to show how we're going to be able to handle 100,000 concurrent users with just like a slider and a couple of checkboxes. And that will be it. It will be that simple. And the future is promising with the amount of scalability that we're going to be able to handle through the actual SignalR service and the app service plan. So without further ado, my name is Jose Javier Colombier. I'm Dev Express and Microsoft MVP, and I'm really pumped to be here today with you guys. So let's talk about Azure, let's talk about SignalR, and let's talk about Blazor, and how Azure SignalR service kind of become the proxy between all the clients and all the different servers that we're going to be hosting, because we have two choices. Basically, we have a scaling out that is scaling somehow horizontally. So we're going to add a new instance, a new server. We're going to add a new app service, and we have a scale up that is basically adding more resources to our server, adding more memory, adding more CPU. And let's talk about how SignalR that is in Blazor server, in the architecture of Blazor service, somehow a bottleneck, how actual SignalR service come to the rescue on how we're going to be able to not have those issues, on how easy it is to configure Azure SignalR service so our app doesn't get in this type of roadblock and is able to handle those gracefully. So one thing that is important before we talk about actually the part of about hosting, scalability, and everything else is to understand how Blazor server does everything, so we know how do we have to scale it, how do we have to configure everything, how do we have to set up our environment, so when more users get in our app, we're able to handle that. So basically, we have two hosting model in Blazor is WebAssembly and server. Of course, in WebAssembly is not the topic of this talk, but it's good to mention that WebAssembly is running the Blazor code, the .NET code natively. So Microsoft really they did a compile of the .NET runtime to WASM, and right there is able to interpret all our DLLs, all our files, so all our C# code. Blazor server is a different kind of architecture because there is a SignalR connection that is basically getting events from the browser and responding to those events and sending the difference on the HTML on the DOM to the browser again. So this point of the signal connection is one of the bottlenecks when you're trying to scale, because every time, again, there has to be a persistent connection open all the time, and as more user gets connected, so the number of connection, of course, increases. So we're going to be talking how to solve that issue, but it's good to mention how Blazor is doing everything under the hood. And if you think about the first time that you go to a Blazor server application and you just put the URL on the browser, the first thing that happens is that the JavaScript client gets downloaded to the browser. Right there, that JavaScript client open a WebSocket connection and say, hey, tell me what is my first page, and we send the first page. And after that is basically, we don't need to change that page unless it needs to change. Does that make sense? It's basically when the architecture is so smart that it's only going to change the difference on the DOM. So for each user, Blazor server is keeping in memory a copy of the DOM, and when you do any type of event, any type of change, we're going to compare the diff of what it was already in the DOM and what it changed, and we're going to only send back that difference on the model. And let's see it in action. So right here, for example, we have a quick GIF, and that GIF, what it's doing is every time that you click, the counter get incremented, but also the label, the style of the label changed to bold. If you see, the only thing that is refreshing here, the only thing that we're seeing in pink is that style font weight bold. That's the only thing that is being sent through the wire, nothing else. So it's really, really smart and really efficient that you have a copy of your DOM and we compare and say, okay, the only thing that is changing here is the style font weight bold and the number of the current count. So that's the only thing that we're going to send. So the payload is really, really minimum. So kudos to the Microsoft team. This is a really neat implementation. And let's see the payload here. We have the WebSocket tab on our network tools, and we can see the binary message that is going on. Of course, this binary message is not meant to be readable for the user, but you can see that 229 byte, that's by no means a big payload, and you're going to be able to actually even see in the message that, again, it's not supposed to be readable, but you can see that the style font weight ball is being sent here. And let's see it in action. So we have this Blazor help website that I want to say kudos to Michael Washington that there is a lot of good information here about Blazor. This is a Blazor server application. And if we go to the inspect and we go to network, we disable cache. It was already disabled. Let's disable. Let's basically empty cache and hard reload. And you will see in the WebSocket, let's refresh. It's still refreshing. Let's give it a second. You will see right here, we have our WebSocket connection that is actually inside the same app. So if we click on it and we see all the messages that is going on, and let's start scrolling, going down, you can even see here on render completed. So you see that there are some type of events happening, the life cycle or all of Razor components. You can even see it here in the binary message, and then you can think, okay, so if for everything that is happening, I have to be going back and forward to the server, there is a latency happening here. And of course, you will be right there. But in our practical test, we have a lot of Blazor server application happening in production right now. And it's not slow by any means, it's really fast. And also, if you think about low latency networks, it's more even important to have a stateful network. So you know exactly if they get disconnected, that when they get back, they are in the same state that where they live. So this is a really interesting approach, and the solution is really efficiency. And one thing that is also good to mention in this type of architecture that, yeah, you need to be connected, is that the response, because the payload is so slow, is really fast. So this is one really good alternative that you need to realize. And this is a really simple website. This is just a blog. But if we look at a more comprehensive application, if you see here, this is a line of business application, some type of ERP where we have department, task, employee, and a whole crew and a lot of operations here. And we have here the user and pictures, and we have a lot of information happening. It's the same exact thing. It's the same architecture, and it's really performance, really fast. So if we go to network, we go to the WebSocket again, we disable cache, we reload, and then you can see here the WebSocket. And if we click on it, we can go to the binary message, and again, we can be seeing here the same on render completed. We can see here that every event is going back and forward and it's happening, and we're gonna check later how that amount of connection to the SignalR we're gonna be able to handle really fast, really efficient with SignalR service. So let's close this and let's continue. So one thing that is really important also to mention when we're talking about the architecture of Blazor server, because that's the main point, understanding the architecture to understand how can we scale, how can we host it, how can we get a lot of concurrent users, because this is the other important part. Concurrent is an important word. You can have a lot of users, but if they are not using the application at the same time, you're fine. You're good to go. It's about the amount of users that at the same time and clicking and browsing and watching things. So SignalR, I don't want you to get overwhelmed. We're going to cover SignalR real quick. And my goal in this talk is that by the end of the talk, in those 5 minutes that I will be talking about SignalR, you end up happy and thinking all of this is taken care of for me. So I don't have to do it because SignalR is already smart enough to take care of everything for me. I don't have to think about protocol, or I don't have to think what I'm using. Everything is happening under the hood for me. But as always, it's good to know what is happening under the hood. So if we run into any issue, we can fix it. So what is SignalR and how it works? So SignalR is a library for adding real-time functionality to the application. So that means that you can have like a subscriber method, that you can have one-to-many or many-to-many. So everyone that who is subscribed to Hub will get a notification every time that a new event happens. So this is really smart for chat application, for real-time synchronization, for a lot of real life examples where you need that real-time functionality, that when something happens, everything that is subscribed to that hub, to that event, will get a notification and will do something. It will react to that. So the idea here is that the server is pushing code to the client instantly as it becomes available. So as soon as something happens, that information is being pushed to all the clients without the client having to request for that new data. So the server doesn't have to wait for the client to request new data. Why is that important? And let's talk about three main things that is important: HTTP, Ajax, and server code push. So let me try to do a drawing. I'm not that good drawing it, but I think that is important to visualize it. So we have a server, right? And we have a client. And HTTP, how it works. So the client requests data to the server, and the server sends data back to the client. That's it. That's HTTP in a nutshell. But the interesting here is like there is a disconnection. As soon as the server sends data to the client, that's it. The client disconnect. There is not a connection open. There is nothing. So it's completely stateless. So that's why we need to use cookies. We need to use database. We need to use storage to keep a state of our application. That's why we need to use all those methods. But then it came Ajax. Ajax is a way to do asynchronous JavaScript and XML. So that means that you can do some refreshing of your page without having to reload the whole page. And even if you, and let's try to do this again, server, client, even if you request data to the server and you can continue the operation of your application, the server can send the data back, but the server cannot send the data without the client requesting first. That's always a condition. The client needs to request the data. The server cannot push data to the server. So that's why the concept of server code push content come in place. So right here we have several choices. And of course, WebSocket will be the ideal choice because it has better latency, better processing. It has a lot of advantage that we're going to cover here about full duplicate, asynchronous, and so on, so on. But we also have a few more things. We have long polling, we have forever frame, and we have event source. One thing that I want to mention is like if you have Internet Explorer 8 or something like that, long polling is by default. That's the way that things used to be like simulated in real time. So pretty much that's the client telling to the server, hey, you have new data? And the server, I don't have it yet, but ask me in a little bit. And then, hey, do you have new data? Hey, do you have new data? Hey, do you have new data? So there is a lot of more resources taking place. There is a lot of more memory. There is a lot of more delay. Then we have forever frame that basically is like hiding an iframe in your application. And yeah, that makes sure that you can send some JavaScript, you can send some data. But of course, for example, if you have a desktop application, if we have a mobile application that only works for web, it won't be able to use that for every iframe, and also you're using more resources. If you have event source, that is server send event, like you know that when you do a request to a server, you have a response, and that response always have like a type like JSON or application JSON, application text. In this case, would be like a server stream, but it's also more time consuming, more resource consuming. But we have WebSockets, and as we will see, WebSockets have a lot of advantage, and let's see which of them are. So WebSocket is bi-directional, so you have a persistent connection open there that all the time is taking care of like keeping the connection open, but not only that, being multi-user and full duplex. That means that the client can be sending data to the server, and the server can be sending data to the client, and not only that, at the same time. So think about that. This is really efficient, really smart, and really awesome. And of course, it's asynchronous. And if you look all the other choices that we have before, none of them have these 4 choices. There is one that is asynchronous, but it's not full duplex. There is one that is bidirectional. So the WebSocket is actually the way to go here, and that's why Azure SignalR is definitely encouraged to be through WebSockets. If you don't turn on WebSocket in your app service, it will go default to long polling, and it will consume more resources and will be slow. So it's important to understand that, because when we actually are deploying to Azure, we're going to go there and turn WebSockets on. So let's talk about this screenshot that Microsoft is providing to us about how we're going to be analyzing Blazor server as scale. So as they say, they test for an appropriate latency of less than 200 milliseconds with an amount of concurrent users giving a click every second. So in our company, 200 milliseconds we consider slow. So we always test for 100 milliseconds, no more than that. But if you see here, this is really promising. You have only one CPU, 3.5 gigabyte of memory, and you have 5,000 concurrent users. If you do 4 CPU and 14 gigabyte of memory, you have 20,000 concurrent users. So think about this. It's not even about scaling now. We're not adding a new instance. We're not adding a new server. We're not doing a forest of servers, a farm of servers. We're not doing any of that. With just one server, 20,000 concurrent users, I think that this is really promising. And of course, the available memory is the primary bottleneck. Why is that? If you think about this, when you are looking at a Blazor application in your screen, that Razor component that is showing there, because Blazor is based in a component architecture that you have a composition of components. So you have parent component and child component. Everything you are seeing is a component. Actually, the app is a component. So it's really, really like the moving section that you have a drink inside a drink inside a drink. So it's really, really nice, really efficient. And not only that, you can take a component and put it in a NuGet packet, and that NuGet package share it between different applications, between different parts of your own application. So the possibilities there are really reusable. So the component that you are seeing in memory, let's come back to that one, that Razor component that is instantiated, that class that you are seeing in your screen, for all the time that you are seeing on the screen, that's on memory. So if you think about that, even if the payload is not too big, as more concurrent user and more concurrent user get connected, the memory will increase. So this is a test for a file new application, the application that we have seen all the time, the counter, the weather forecast, and we will use that application in a few minutes. But that application, you can get that performance of 20,000 concurrent users with just one server. This is, in my opinion, this is amazing. And of course, it will all depend. If the application that we showed before about a complete ERP, that will take more memory because there are more things happening for that. But of course, in memory will be your Razor component, will be the copy of your DOM, because we talk about that. You need to compare. There are a few things happening there. So of course, memory is the primary bottleneck, and this is important to understand, because one thing that we need to do as soon as we create our app service is to make it 64 bits. We don't want to leave it at 32 bits. That is the default. So few more things that we need to understand. Sticky session. So what is a sticky session and what is important for the scalability part? So a sticky session is the concept that if I connect to a server, only that server knows about me. So let's say that I get a lot of users and I say, okay, I need to create a new instance. I need to create a new server. As soon as I create the second server, all the users that have already connected to my first service, the second server doesn't know about them. So they cannot respond to that user. So that is not even solving any issue yet, because I need to have new users to the new servers to that solve any issue. In this case, the second server doesn't know about all the user, and this is really easy. See in this image, for example, client 1 and client 2, they are connecting to the server 1. If they connect to server 2 doesn't know about them. So they can do nothing about that, because the circuit has been constructed only with server 1. And that's something that Azure Signal Service take care of, and we'll see it later. The other thing is TCP connection. If we know every server has a limit number of TCP connection, and I'm not meaning about only my application, that TCP connection number, the limit is shared about all the others. So if we have other web apps, if we have other applications running on our server, that TCP limit is shared between all of those. That's why sometimes when we're having an application that we know that we want to scale, that we're going to have a lot of users, we try to have it by itself in a server. That way we can at some point say, okay, after this amount of users, after this amount of connections, we need to add a new instance. That's how we can do, because if we share that application with other applications, that TCP connection number will get completed real quick. Everyone, that limit will get filled right away. And the other point is, like, again, we have a scale up and a scale out. A scale up is we're going to add more resource. A scale out, we need to add another instance. And we're going to see, and this is important because, for example, in Azure Signal Service, it's not only about the number of clients that get connected, it's also about the number of meshes. So if the number of meshes doesn't increase, let's say that we have 5,000 users, but the number is really slow, we don't have to scale anything. So if we have 20 concurrent users, but the number of meshes between them, they are not even using the application, doesn't increase, we don't have to scale out. It's smart enough to take care of that for us. So what are our choices to handle all this problem? So our choices, and of course, this is a talk about Azure, and we're going to be talking about Azure Signal Service, but it's good to mention that the choices that we have here is Azure Signal Service and the Redis backplane. So let's talk about the Redis backplane for a second. So basically, the Redis backplane is a key value store. Basically, what it does is the server lets them know about the message that they need to send, and the Redis backplane of Redis, it knows all the clients and all the servers, and knows how to basically handle and how to redirect the message from one to another one. But I have to mention a few things. The Redis backplane is only recommended when you have some type of problem with your connection to the Azure data center, when you need to have everything on premise, when you can, maybe security, maybe low latency, big latency on your network. When those things happen, yeah, when you are hosting everything in your infrastructure, backplane Redis will be the choice. But besides that, it has a drawback that the Redis backplane need to be in the same server that the Signal is happening. So if you definitely are using Azure, the way to go is Azure Signal Service, because take care of everything for you. And we'll see not only that, in the backplane Redis, if more users get connected, you will need more resources. It's not like the Azure Signal Service that is smart enough to know that it's not only about the amount of users, but it's only about the amount of messages that every user is sending. So if you don't have a huge amount of messages, you don't need to scale out. So let's talk about Azure Signal Service now. So if you see here, it's really simple. The client sends a authentication and some type of request to our server. The server sends back that authentication request to the Azure Signal Service, and the Azure Signal Service sends back a token. And with that token, the server sends that token to the client, and from there on, Azure Signal Service take care of everything. So the client send that token to the Azure Signal Service, and the Signal Service from there on know how to redirect, where to send it, which server, how to take care of everything that we need. And you will see how easy and how fast is configured Azure Signal Service. So let's just look at the picture. The Azure Signal Service from here on will be the proxy between all our servers and all our clients. So it will be really smart, and we're going to show how to configure the Azure Signal service, but not only that, how to configure the app service instance so they automatically scale out and scale up, and they can say, we are having a huge number of users, or CPU or memory is getting depleted. We need to instantiate a new server and move on, and we're good to go. So before we move to the demo, it's also important to know that the pricing of this Azure Signal service, because one thing that everyone always asks when they are being somehow demoing a new service on Azure is how much it's going to cost. It's going to impact my budget. How can I handle this? So basically, you have the free tier and the standard tier. The free tier, of course, is only for developer. You have 20 concurrent connections per unit. You have 20,000 messages a day. And for development, that's awesome. Like 20,000 messages, that's for a day. That's a lot of messages. So, but you can only have one unit and only 20 concurrent connection per unit. So it's definitely only for testing. But if you look at the standard, you have 1,000 concurrent connections per unit. You have 1 million messages for free. And then you can have, of course, unlimited, and it's really cheap. And you have the price for unit for date and the maximum of units. So if you think about this, you have for $161, you have 100,000 concurrent users. Think about that. So I think that this is a really interesting solution, and let's get to them. So let's open Visual Studio and let's create a new solution. Let's give it a second. This is the mug that my daughter and myself paint together. So it's a little all over the place, but it's my favorite. So let's give it a second right here. Create a new project. Get in there. And let's do a Blazor server app. Next, we're going to call it AES-Conf Dev 2021. Next, of course, we have here our version of .NET. We're going to use .NET 5 and create. When we don't need authentication, we just want the simple Blazor app that we can get, so we can basically publish to app service and check all the choices that we have in there. It's coming. Okay, here we go. And let me know if you guys can see it well, but basically this is our Blazor application with our startup, our program, and everything, as always. So let's run it and let's see what we have, and then we'll go from there. This will be the Blazor app that we have seen everywhere. Like we have a counter, we have a weather forecast data, and we have our index with a survey component. Build succeed. So now I should be opening the browser. And here we go. Let's give it a couple of seconds. It's loading everything here. Okay, so we have the counter, everything that we've seen, the fetch data and so on. So if we click inspect, I just want to show real quick that in the network, the WebSocket tab, and we will refresh. Let's disable cache. We refresh. We have right here our Blazor. I don't think that we can see it. Our WebSocket or Blazor Signaler service happening there. And one thing that I want to mention, and why we had all the trouble to explain SignalR. It's like everything that SignalR is doing is taking care for you. So you don't even have to know what SignalR is doing, how it's doing. Everything is taken care for you. Right here, you don't see where the SignalR hub is happening. You don't see anything. All of that is so transparent to the developer that is like you don't even, if you don't take the time to understand Blazor server architecture, you don't even see it here. That easy, that transparent to the developer it is. So basically, let's deploy this application. And of course, we can deploy this application to Linux, we can deploy this application to IIS, but there is so much to gain to deploy it to Azure, to the app service. You will see how easy we can scale, how easy we can set things. There is a slider for amount of servers, that instance and servers that we want to do. So definitely just by having in Azure, there is so much to gain there. Okay, let's click next. Let's select Windows. Let's click next again. And right here, we're going to select our subscription, Visual Studio Enterprise, and then we're going to select resource group. And right here, the app service instance. So we're going to create a new one. And let's call it Azure Conf Dev 2021. We're going to create a new resource group, and I always recommend that Azure Dev Conf 2021 RG. I always recommend creating a resource group, because especially when you're doing like a talk or you're doing some type of development, when you are done and you just want to delete all of those resources, you just delete the resource group and you're good to go. So definitely highly encouraged to do a new resource group. And then let's select the hosting plan. Right here, we're going to select a new one as well. And this is the first moment where we can actually scale. Right here, as if we saw in the slide before, with just one core and 1.75 gigabytes of RAM, we can handle 5,000 concurrent users. And if we actually select 4 core and 4 gigabytes of RAM, we can handle 20,000 concurrent users. So because we are just trying to show, and this is just a demo, let's select the 1 core and 1.75 gigabytes of RAM. We're going to select the location, West US, and we're going to try to make sure that all resources are in the same location. Let's click OK, and let's click Create. Right here, it will go to the our Azure portal with our credential, and we'll create and we will instantiate all the resources that we need. The good thing about that is that it will not publish yet, so we need to publish, but this is a good thing because that will give us the time to go there and do some configuration. So let's give it a little bit of seconds so it creates everything that we need, and then we're going to go from there. It's creating the app service, and if you see, it already created app service. So let's just click finish. And right here is still haven't published. This has been created. So let's go to our Azure portal. So right here we have our Azure portal. If we refresh, we should see our new resource group. Okay, let's log in for just a second. So we can take a look at the resource group that we have, and we should have a new one, Azure DevConf resource group. And then right here, we're going to have the Azure plan that we're going to come back to this because this is where we're going to scale out our application, and we have our app service. So let's go to app service. And the first thing that we're going to do is go to configuration, because there are a few settings that I want to emphasize here. One thing is, like, if you see here, there is only one application settings, that is this website node default. There is nothing else here, and you will see when we actually add the Azure SignalR app service how this get taken care by ourselves. So we don't have to do anything. All the settings that we need to add, they get added by us for us. So we go to general settings. Of course, we have the version of .NET, and we have Net Core 3.1, 2.1, we have Net 5, we have Net 6, that early access because that's still on preview. We're gonna get to it in November. There is the fees. I think that there is the first release candidate, but honestly, in all our tests, the version of .NET so far, maybe I think that I have great hope for Net 6 to improve on performance, but it doesn't matter the version of Net 5 of Net right now. It could be Net Core 3.1, Net 5. That has not given us a big advantage in any type of performance. Hopefully Net 6 does, so we can leave it on next 5. But this is the first thing. If you see by default, the platform gets us 32 bits, so we should change this to 64 bits because memory is one of the primary bottlenecks that we have on our application. From there on, we should, of course, turn off WebSockets for all the advantage that we already explained. I always select always on because if we're doing some type of development, of course, we're going to leave always on as off because we want that when we're done with our development, this app service gets turned off or it gets in idle and we don't have to pay for that. So that's an extra some dollars that we save. So we're going to put it on because we are in this type of environment when is scalability a big priority. We need to make sure that our new user doesn't get a bad experience. We need to have it on. And we're going to have AR Affinity on, and that's basically what it means. It's about the sticky sessions that we talk about. We need that to make sure that our client gets redirected to the right server, to the right place. So after setting all of those, we just basically save. Give it a second to update all the web app settings, and then we publish. So one thing that is good to mention, they scroll down, is that even Visual Studio is already telling you, hey, your application is making use of SignalR. So it's really encouraged, it's really recommended that you, for scalability, to send it to Azure SignalR service. So even Visual Studio is already letting us know that Azure SignalR service is the right choice for this type of application. And before, I don't know what's going on with my Visual Studio in the last few weeks, but before, actually, if I didn't turn on the 64 bits and if I didn't turn on WebSockets in the portal, when I published my application, Visual Studio actually was smart enough to let me know, hey, you should turn on WebSockets. This is the recommended approach for your Blazor server app. So not sure why it's not happening, but you can always go and do it manually, so you don't have to worry about that. So right here, it went to the other monitor, but you can see that the application is already published. It's on Azure as confdev 2021 Azure website.net. And if we inspect the application, we go to network, to the WebSocket, and let's disable cache and let's restart the application. You will see that right here, the WebSocket is coming from as ASConfDev 2021 Azure website.net. So it's embedded in the same application. So the SignalR app and the application, they are both in the same server. They are in the same place. They are all in a coherence mode. And Azure SignalR service, besides all the advantages that we already discussed, also will give us the way that it will take load out of our CPU. So all that SignalR part, it will be taken care in another instance, in another server. So let's get that taken care of. So basically, let's click here, SignalR configure, and I will highly recommend to using the wizard that Visual Studio provides because it's, in my opinion, good to know what it's doing, everything that it's doing. And right here, it will let you know it's adding a new web package. It says changing this app setting is in the app setting config and so on, so on. So let's see it. Let's create a new, and of course, if we have more than one Azure SignalR service, that will be shown here. But let's put here as ASConfDev 2021 SignalR service. So we can differentiate really quick. We're going to select the same subscription. We're going to select the same resource group, same location. And of course, we talk about the two SKU, like free, that they only have 20 concurrent user by unit, and this one that I have 1,000 concurrent user by unit, and we have been able to do 100 units, so we're going to be able to do 100 concurrent users. So we'll leave it in the standard and we'll click create. Let's give it a second. Right now I will create the Azure SignalR service, and then we're going to do a redeploy and see it in action. We have 20 more minutes, and there is still a few more things that we want to cover about scaling based on CPU, scaling based on memory. So let's give it a second, and if it takes too long, we're gonna switch to get that part taken care of, and then we're gonna come back to this. Okay, let's jump to that one. Let's not waste any time. So right here, if we go to app service, one thing that we need to make sure, if we want to scale up, even if the scale part of our application is based on our app service plan, we need to turn on application insights. So if we do that, that will show up in our monitor, in our Azure monitor, and that will allow us, yes, and that will allow us to basically do all the configurations that we need. But if you see, we configure Azure Signal service like in 3 clicks. It did everything for us. And now we're gonna configure our app service and our app service plan to scale based on a metric really, really fast. Meanwhile, let's come back to our Visual Studio. And if you see, our Azure Signal service is already created. So we're gonna click next. And this is what I like. It will let you know what it's doing, what are the steps that they're doing. The first thing is like, right here is the connection string of the Azure Signal service, and it will tell us where do you want to save that connection string. We're going to save it in the Azure app settings. We can save it in the Azure Key Vault, or we cannot use any of those choices. And Azure Key Vault is a really, really interesting showing, a really nice choice. By the way, when you save it in the Azure Key Vault, you will have to have some reference in your app settings to that Azure Key Vault. So for now, because the Azure Key Vault will be the more secure choice, but in this case that we're just only showing how that works, let's leave it in the Azure app setting. Let's click next, and right here it will tell you everything else that it's doing. Okay, I'm gonna add the Azure app service settings, what we were discussing. We're gonna add the NuGet package, we're gonna add a new profile, we're gonna put the secret store. So all those things are taken care of for us without us having to do nothing. So let's click finish. Let's give it a second. You see it's doing everything, and we got right here is going to automatically close when you see it, but you can check that and see everything that is happening. And now if you go to your dependencies, you can see that you have the Microsoft Azure Signal service. If you go to your app settings, you will have a new settings about Signal and so on, Azure Signal enabled. So now you see we actually activated the application inside. But one thing that before we move to that part, if we click here in configuration, the thing that we talked about the app settings before, there is a lot of more things happening here about Azure Signal connection string, Azure Signal sticky server mode. There are all the application insights that we all just activated. So all these application settings, we didn't have to do it. The only thing that it was when we start the application with this website node the file, all of those were taken care of us. So again, it's taking more time just for me to talk about this than actually doing. So let's do a quick deploy. Now that we have the Azure Signal service created, configured, and everything that we need, and let's see it in action. Let's see that when we actually run our application, the WebSocket, the Signal part, is actually being handled externally. It's not already anymore in the same instance, and it's really smart. It knows how to redirect all the concurrent users. It knows how to take all that payload from our server. So I don't know you guys, but I'm really, really, really impressed with the possibilities that we have here. So let's give it a second. It's updating everything. If you see here, publish succeed, and it's coming. Perfect. Now, if we go to inspect now, we go to network, and we go to WebSocket, and we again disable cache, and we are going to reload. Let's see this in action. So hopefully, let's see if I'm able to. Okay, hopefully you guys can see it, but if you see here, the URL says Azure Conf Dev 2021 Signal service. So we know that it's already not being in the same instance of our application. So right now it's already being handled for our Azure Signal App Service. It's that simple to take care of this. So if we already took care of the roadblock, that is the amount of Signal connections. if we already took care of all that part, what are we still missing when we get a lot of more concurrent users? Okay, we are still missing memory, we're still using CPU, so our server can get somehow frozen, somehow overwhelmed. So let's see how to fix that. Of course, we went there before and we actually turn on application inside. So after we do that, basically what we have to go is to monitor, to Azure Monitor. And if we go there and we go to the auto scale option, we should see, and let's send the subscription to the right one. We should see our Azure Conf Dev 2021 plan. If we click on there, we can see the first thing that we can do is manual scale. So basically, if you don't want to auto scale based on any metric, my recommendation would be at least to put 2. That way we know that it will always have a second one there ready, and we can be measuring everything, because you know that if you don't measure something, you cannot improve it, you cannot optimize. So that will be my first recommendation, but the actual recommendation will be auto scale. So how will that work? Let's see that I add a scale condition, and right here you can say what is the minimum instance, the maximum instance, depending of your budget and so on. But one thing that I like is this rule thing. If you go and you're gonna put a rule to scale, you can check, okay, what is the, I'm gonna say average, minimum, sum, last. There is a lot of great good tools here, but the thing is, like, I will say CPU percentage, that will be my metric. But look how many metrics do I have here. I have CPU percentage, I have memory percentage, I have CTP established, I have a lot of things. But let's think about the two main ones, CPU and memory. I will say if my CPU percentage is greater than 70% for a duration of 10 minutes, there is a lot of things happening here. And this is great because, especially, for example, for Black Friday, for those type of event where we know that we're going to get a big amount of users, we can say, if that happens, okay, then increase the count of my instance of my server by 1 or by 2 or anything that I decide. And of course, I put a cooldown of 5 minutes, so we cannot instantiate a new server until that actually is stabilized. But we can do that same thing for memory. We can say if memory percentage is the same, 70% for 10 minutes, then we need to do something. Same thing about the scheduling. The scheduling, we can say, I want all the weekends to my application to scale down, because I know that on the weekends, I don't get that much traffic. So think about this. We have Signal service taking care of all the Signal parts, taking care about redirecting everyone to the right server, taking care about sticky sessions, taking care of everything we need. We have this auto scale that will let me know that if my application is getting too much memory, too much CPU, to right away instantiate a new server. I don't know if you guys have done this by manually, but we have. And in the past, back in the day, we need to buy a new server. We need to set up new web server. We need to set up connection to the database. We need to set up load balancer. We need to set up DNS load balancer. So there is so much configuration. And right here is like 3 slides, 2 check boxes, 2 drop downs, and you are good to go. In my opinion, this is amazing. The Azure app service is basically made for Blazor. So before we move forward, let's come back to the slide for a second. And one thing that is, I think, the bonus in the presentation are these 3 words: circuit handler, circuit option, and hub options. That will also give you like they say, the top of the frosting. So when you're thinking about scalability, what do you need to do to make more? Because again, what you don't measure, you don't are able to optimize. So let's take a look at these 3 choices. Let's talk about Blazor circuit handle first. So there is the concept of circuit, and in circuit is some type of analog of user session. And if you see, you have the circuit handler class that it has a lot of overridable events on circuit open a sync, on circuit up a sync, on circuit close. And let's see it. If we go to the definition, all of those are right here. And in this case, we're doing some other implementation, but right here you can say every time that a circuit gets open and I put my custom logs, my custom logic, I can send this to app inside to see it in some type of dashboard. I can send it to Power BI on connection up, on connection close, on connection down. You can do all of those things, and you can have some really neat visualization of how many users are using your application, how many get disconnected, how many get closed, because that's the other thing. If your app, let's say that I close my tab on my Blazor server app, my memory in my server is still there, because if I come back in less than 3 minutes, I'm able to see all my stays. So they actually give you some leeway, so you can actually take care of like network outage or any other type of things that happen, and you can come back to your application and be in the same state. So that's what the concept, and let's go to the next one. That's why the concept of circuit options. If you see here, you have circuit option when you add the server-side Blazor. If you have a normal application, and let's see actually the one that we just did, and we go to the startup, we have this add server-side Blazor. But if you want a more control about that, you can put these options. That is actually a secret options. And right here, you can see detail errors. And we can tell them, hey, I don't want you to show any detail errors on the browser for security. Right here, you can say, what is the maximum amount of circuits that you can retain? And 100, and you can make this bigger or slow. What is the amount of retention period for the circuit? And this is what we're talking about, that if you close your tab and you come back in less than 3 minutes, you will have is still in memory your information, and you have a lot of other information. Not only that, you have hop options. So the signaler hop that is there, that you don't even see it, that is taking care for you. You can add some options like what is the client timeout interval, because I want to make sure what is again the detail errors, what is the handshake timeout, what is the keep alive. So if you think about the signaler connection, they need some type of a message back and forward just to keep that connection alive. Hey, I'm here, I'm here. You don't have to take care of that every 15 seconds. If you say I want to do it every second just to make sure, no, that's taking care for you. Maximum parallel invocation by client, so maximum message size, all of those is taken care for you. So the amount of flexibility and the amount of somehow I say so we can intersect at any layer and change anything is amazing. So think about this. We have signaler service that take care of all the signaler connections, no hard redirected. We have auto scale. We have these options. So the future is really brilliant about scalability, hosting, and deploying Blazor server apps. So let's come back to the slide. And with that, I want to thank all the partners for making this a reality. This is an amazing event. So thank you for inviting me. And this is the best way to end my day. And all the communities that are involved on making this happening, I always like really excited to see that many people somehow in a, like for me it's 10 p.m. but in a Saturday, in a Thursday, talking about technology. So if you have any questions, this is my Twitter handle, JJ Colombier, and thank you for being here today.
Hey, Jose, that was a very wonderful session. So as we wait for comments from our viewers, I have one for you. So how it is different from Azure Web PubSub and Signaler? What is the differences there?
Say that again.
Yeah. So what is the difference between Azure Web PubSub and Azure Signaler? What is the difference between these two services?
Yeah, so the difference is different. Azure Signaler Service and Azure Web, they are both based on WebSockets. The difference is like Azure WebSocket, and there is a really great talk that Facu from Argentina, Facundo La Roca, will be giving about Azure WebSocket. But Azure WebSocket is more focused on real-time communication in this type of collaborative application. Let's say chat, let's say games, let's say Azure Signaler Service is focused on this amount of like message that Blazor server is sending back and forward. So Blazor server is a complete all the time communication that is happening, saving all the Razor components on memory, saving all the DOM components that you need to keep on memory to do the diff. So Azure Signaler Service was actually made to keep all the Signaler connection in place. Does that make sense?
Yes, Jose. So Another thing is that if using Signal, or if my client is using browser and I'm connected to that using a WebSocket connection, right? If something happens to my network in my browser or in my site, and when the connection is lost, will it get automatically reconnected, or do I need to refresh the page to get it connected?
No, you do have to refresh the page. So you can add a little bit of JavaScript to your application so it knows when you get disconnected. Because if you have seen the Blazor server apps, they have a reload component that it gets showed on the top that is say you lost your connection, please reload, and you click reload. It doesn't do it for you. You have to do it. But you can definitely add a small JavaScript that actually is checking for that component and saying if this component is showing there, we're going to reload for you, and we can take care of that. But that's an extra steps that you have to do. It's not getting done automatically, if that makes sense.
Yeah. Okay, so we have one question from one of our viewers. It's like, can you change the reconnect timeout?
Absolutely. Absolutely. If you see there, we have control over everything. We have control about the hop options. We have control about the circuit options. So if you're there, for example, you can say, I don't want them to save my information for 3 minutes. You can save it for 5 minutes. You can save it for, so it doesn't, you have all those control completely. And the reconnect timeout is one of those choices. You can tell them, hey, I want to be able to reconnect faster. And one thing that I like is that that reconnect automatically. And this is really interesting, especially when you're handling updates of your Blazor server apps. When you do a new update, your application, if you don't refresh manually, it will go to that can you reconnect mode. And you can actually make sure that your client goes to your latest update by doing that little bit of JavaScript, letting them know, hey, there is a new update, reload by itself. And the application take care of everything. So it's really, really interesting.
Okay, Jose. So that's pretty much with the questions. I think we have no more questions as of now. So it was our pleasure hosting you in the second edition of Azure Community Conference. That was a wonderful session on Signal and real-time communication using Blazor. And we look forward to your participation in next year's event also. Again,
No, absolutely. I'm really excited to be here, really pumped. I really appreciate you guys inviting me. You are accepting my session. So happy to discuss it. This is the best way. I told that at the beginning of the session. I actually was feeling a little bit of under the weather, and this is the best way to. I'm feeling better and ready to end my day. So thanks for everyone to make this a reality.
all right. Thank you. So as we move on to the next session, we will start in 2 minutes. We will be back. Hey, welcome you all back. So, moving on to our next session is by Renu. Renu is going to talk about Spark job lineage using Azure Purview. So, without wasting too much time, I am handing that over to Renu. Please, stage is all yours.
Thank you, Amal. Hello, everyone. Good morning, and I hope you are enjoying this conference since yesterday. And there are so many lineup good sessions that you can go through. So, about myself, I'm Renu Saluja. I'm part of Microsoft, working as senior software engineering working as senior software engineer in commercial software engineering group. So, today's session, uh, I will talk about how. You know my session is all about how you can track the lineage of a Spark job using Azure Purview. So let me quickly share my screen. One second. Sorry for the background noise if you have. Okay, can you see? Amal, can you please confirm if my screen is visible?
It's refreshing. It's going. Can you
It's
want to
blinking, I
stop?
think.
Yeah,
Shall I stop and start again?
yeah, yeah.
I hope it's fine
Oh,
now.
it's fine.
Okay, sounds good. So, today's session is all about Spark Job Lineage with Azure Purview. So, let's quickly go through the agenda. So, uh, there may be few audience who are not aware what is Azure Purview. So first we will go around with the data governance. What is data governance all about? And then we will have a look at very high level about Azure Purview. And then we'll straight jump into demonstration in which I will talk about how data Purview is capable handle of doing all the data governance even on the Spark job as well, because Spark job is quite complicated these days. So now let's start with the data governance part. So what is data governance? That's a critical thing. So someone who is new to data, they must be wondering, like, there are so many type of governance, why the specific data we are talking about? And as you know, data is the key asset these days. It's all, this is the actual money that is in the market. It's not the currency, but it's the actual information that is being used by all organizations in their own different ways, and that's how they're running their business. So this is the key, this is the center of all the businesses. So if we talk about the governance part of this, so when we say governance of the data, then we mean to say, okay, is how is it easy to identify from where my data is coming? What is the origin of this data? Can I trust this? So as company is going to grow, there are so many applications that will be built, there are so many external integration that we need to do. And when someone at higher management, they want to have a look, like how what's the stats of this data, for that, as a compliance need, any kind of chief data officer, they must be aware of few things, like as I said, from where data is coming, can I trust this data, whether this is authentic or not, and which kind of data do I have. So this is a kind of discovery of the data. So from all about the origin. So once we know from where data is coming, I can trust it. Then another thing is, does this data comply with all the compliance framework that we do have these days? So is there any risk if I'm going to use it? Will it comply to my industry specific regulations? So like, if we talk about telecom, this could be IRDA. If we talk about healthcare, then HIPAA. So many compliance. So another critical factor is, does my data comply to those all those regulation, and can I control this? Can I apply some kind of rules or security access just to see, okay, the person who need access of certain field can only view that, or can I apply some kind of PII information so that it's not visible to everyone, or based on the role they can see. So at high level, can I cover both part? Like, can I cover the compliance part as well as can I cover the discovery part? That's the critical for chief data officer. So at high level, I would say again, this is data governance that we can define as exercise of authority and control. So authority and control, you mean to say how we can plan, monitor, and enforce the policies. And this is overall over the management of the all the data asset. And this data governance, this compresses of all the three pillars that is critical. One is people, process, as well as the technology. And this is required for overall consistency and proper handling of the data across all the enterprise groups that any enterprise is going to lead. So this is all about the at high level what is data governance all about. Now let's have a look what are the key element for a successful data governance. We know what is data governance, but what are the key pillar that we say, okay, if we have control over those, then we can say, okay, my data governance is full fledged, I can run this successfully. So one is the key one is how we are going to manage the growing landscape. So you know every day when a company is or an enterprise is going to grow, they are going to integrate their solution with some third party applications or their vendors, their partners. And apart from this, as part of acquisition, acquisition of some other small entities or startup, they are going to grow. So if they are going to grow, then it's not all about the acquisition, it's all about the data. So for all the new integration with external partners or customers, and also with the new acquisition of the startups, they are going to grow their data landscape. So if we are going to have this, then how we can manage that? So how we can manage that load? Another critical part is every data, there are multiple segregation that we generally do. What is transactional data, my archival data, my operational data? So can I so all the application is going to have their own set of operational data. Can I have a mechanism to overcome those operational silos? Can I handle that? Another is, when data is going to grow, there are separate silos of operational data that I need to handle. At the same time, I want to handle the data agility. Data format is going to keep changing. Sometimes data field will change, and one the system which is integrated to the second systems, so lots of dependency. How we can have that agility so that if one thing is going to change in one specific area or one specific application, it should not impact the another. And overall, for a data governance point of view, it should not impact the end-to-end lineage that we are going to track. So it should adhere all the compliance requirement that we are looking for. And after that, the topmost priority is whether we so it's good to grow, it's good to have other application in place, it's good to have implement all the agility, but still we need to comply with the industry regulation, as I talk about HIPAA and IRDA. So each industry with their own regulation. So now if we talk about the data governance, with this we need to ensure that the any application or the SaaS solution that we are going to have for our data governance, it should not get impacted with these elements. So if we can handle those, then it's a successful data governance for us. So let's have a look how with the Azure purview we can handle all these four pillars. So that's the key requirement. So but before going to that, let me give you an overview what is data purview all about. So as you know, what is data governance? So it's a if we talk about the Azure purview, then this is a unique unified platform, or you can see is a map of data asset across the organization data states. So multiple application, you do have enterprise grade application, you have application with your partners. So it will give you a unique map with all the connection with the data maps. And I'll show you in the demonstration as well how does it look like. And also it helps you to track all the description of all the data, which kind of classification is there, and actual where data is stored, from where it is coming, who is actual owner of that data. So end to end lineage you can get it from there. On top of that, there are a few other features, those are like key for that, like it you can automatically or you can fully manage the data scanning part and classification. So you just need to configure your data source one, it will automatically pick all the metadata information, it will scan the data, as well as on other side it will also handle the data classification part, like applying the PI policies or your data security classification, whether this is confidential, high confidential, or the general information. So those kind of data handling or data classification will be done by Azure Purview. And on top of that, so once you have implemented all those, then how you can integrate this with other modern data states like Synapse, or in Azure we do have data storage, our blob storage, and we do have data pipelines. So how seamless it can integrate, so that's very easy to get integrated with any of these platform, even to third party. The demonstration which I will show you, this is on the Spark job. So I will just talk about, I will be building my app on the Databrick, my basically notebook on the Databrick, then we can see how it's easy to integrate. So key is how seamless we can integrate to the other modern data state and still keeping all the data protection and governance requirement for the analytics and experimental data operationals. So that's all about Azure Data Purview. So now you can see it's the same four pillar that we are trying to map. One is with Azure Data Purview, as I said, this is a unified data governance framework. And there you can reimagine how you can have that data governance requirement keeping in the cloud, and at the same time you need not to manage anything. It's a kind of SaaS solution you can think of. Your data governance framework is on the cloud, but you need not to manage it. And another is your foundation, the data which is there currently in your business, in your app, that is going to be as is. So data foundation is going to be same, but you will be getting maximum business value uh, for your data consumer, because you are going to have end-to-end data tracking. On top of that, you will get the data insight. If you want to have the Power BI reports or any kind of report, your custom reports, you can easily pull those data. On top of that, as I said, multiple application, multiple data states that you can use in this, and at very broad level you can get very strategic insight of that. You can easily decide, and on other side you need not to worry about the compliance and data governance requirement around the data. So let's reimagine first pillar that we were talking about, data governance in the cloud. So the key part of this is you need to manage your operational transactional analytics data, and that's in fully serverless and PaaS services manner. So you just configure it once, and then you need not to handle all the downtime, or we have really good SLAs around that. On top of that, as far as your homegrown solution will grow based on the data model or data source you have defined, it should automatically be called the data metadata information. You need not to worry about adding all the solution one by one in it. It's intelligent enough if you have provided right connections or the asset information prior to that. So that's all about how you can have your governance in the cloud. Now let's jump to the second point that we were discussing. This is how you can establish this most effective way. So as I said, automatically discovery of on-prem data, and you can also connect to the multi-cloud on-prem. And for the SaaS sources, as I was saying, for the blob or data pipelines or Synapse or SQL or any kind of sources that you can look for. And if you do have your data on-prem, still you can get it connected. Another side is it will automatically classify your data at the scale. It will specify, okay, based on some specific rule, set of rule you have defined, it will say this is sensitive data, or some industry specific tag you want to provide, or you can provide your own custom tag. So those will fall in place by default. And then as part of lineage information, you will get to know what is the origin of this data. with all these requirement, how you can drive the maximum business value. So these are the key points that you can see. One is, as we can see all the end-to-end lineage. So based on the priority or the PI information we have provided, all the roles that we have defined, whether this is data engineer, data scientist, or data analytics, based on their roles, they will see the only information that is required for their specific role. It's not visible to everyone. And it's also applicable for the lineage information. And also it helps user to quickly find data, and also to lineage is kind of end-to-end tracking that you can see. On top of that, if you see the business terms or the definitions or the rules that is defined in purview is not sufficient for your business requirement, you can create few more rules in that, so that you are is totally customizable, so that you can adhere that all the business values that is required for the data, it's it's there, and you have full control on those business rules and terms. So once you have defined all the classification, now how you can gain insight. So gain insight is all about, if you need to publish a report tomorrow, to see, okay, which kind of highly sensitive data I do have in my environment, and what is the origin of that, and who are the other roles who do have access of this data. Can I get that ground level of detail? Yes, it's feasible, and you need to just create few reports around that, and you can get that insight. And apart from this, if you want to get some insight based on some business rules that you want to define, or based on the data asset or the glossary, you can easily pull those information. So that's how we are going to cover all these four pillars of the data governance. uh, Now, so there you can see, this is the high level investment that Microsoft is doing to implement the end-to-end data governance with Purview. So on left side, you can see we do have multi-cloud strategy, we do have hybrid, on-prem, and SaaS for this. And this solution, our data Purview, this is on Azure. So you can integrate any kind of these data sources, first time configuration, and data is going to be pulled from there. So it's a kind of free scanning services, if you are going to opt for this for your on-prem SQL server specifically. And after you have scanned your data Purview is able to create all the lineage information, and for your operational analytics data, you can directly integrate with the Power BI tenant. So their M365 and Microsoft Power Platform comes into picture, and all the labeling that is required for the data sensitive information, that you will get free of cost from Microsoft 365 as part of E5 customer. So you can see, as Microsoft is majorly at high level, so many clouds, but top part three. One is Azure, and then Power Platform, and third is Microsoft 365. So it's a combine of three. That's how it's so strong. So it is picking all the strong areas of all these Microsoft cloud platforms. So once this is the high level component, or underlying services that we are using. So when we say Azure Purview, this is unified data governance, then what are the key things that make it unique, or the underlying layers that helps to get it implemented? So let's these are the top three layers. These are the three layers that is actually responsible for that. One is data catalog, data insight, and another, the key is the data map, because this is the heart. So data map is basically when we say, okay, configure this data source, and for lineage, at least I need to have that information that this data source is having so many tables, and each table is this data type, fields that it is having, what is the length of string or integer type. So all this metadata information, where it is getting managed in Purview. So this is the data map which is actually responsible for handling all that information. So there you can see it is integrated to on-prem, multi-cloud, and SaaS. So once it is having all the metadata information, so it's not the actual data, it's the metadata information at the scale. Now what about the actual data, where it is being handled effortless? That is in the data catalog. So data catalog, this is basically the actual layer who is going to pull the data, classify it, and apply all the required PI information or the that data classification or the business rule that you have provided. And but this is again mapped to the data map, because it is pulling information which is relevant to your business only. It will omit all rest of the data. So once data map has metadata defined, it has pulled the catalog information. Based on the catalog information, it can generate the full lineage. So once you have the lineage, now the third part is data insight. You can get more data insight from there. So that is about how your data is being used across multiple units or your sub departments, like HR, operation, or the finance. So this will give you more detailed insight. Okay, this information is coming from these many data sources, and who were the user, and you have full flexibility to customize all these three layers. So I will show you how you can modify the data map for the Spark job. So this is high level the layers of Azure Purview. So once you know the data purview, then one is, let's talk about the data map, because this is the critical part. So data map, as I said, this is more about how the metadata is being defined into the system. This is a very high level screenshot. There you can see we have defined the multiple collection. So collection, you can think of one data source. In this, I would say we do have SQL, we do have Teradata, Hive. So in this way, you can define your multiple data center as a data source in which we need to pull the data. So here we are not talking about the actual data. This is only about the metadata. So out of box, we do have 100 plus built-in these sources and customer classifier, and we do have multiple sensitive label. Those are out of box, and you can define. But thing is how you can programmatically publish your own metadata. So for example, you can't see any specific metadata or your own custom data sources which is not part of like SQL or Teradata. So how you can define those in your own ways? So there is a REST API that you can use. So those are basically syntax wise, or the ground rule wise, those are Apache Atlas open APIs that you can use to publish your metadata. And once you have published your metadata, same APIs can be extended for your lineage information to pull data from various open source environments. So once you have that, so now thing is for the data catalog. So once you have defined your metadata part, now my system or Purview is able to scan all the data. So now second stage is all about data, not metadata. We have defined the metadata information. Let's search and browse the data. So here business glossary and workflow picture will come. Based on the information that is in the field, it will trigger the various workflow, and also it will generate the data lineage from the source and owner, who what is the life cycle of this data. So that will be part of data catalog. So once this is done, then this is a sample about getting the insight. As I was saying, you can easily get insight about how data will look. So if you need to pull information about, for example, which data is from the Amazon S3, SQL, blob storage, Azure files, you can get this kind of dashboard and you can create your own as per your requirement. So let's quickly jump to a demo, and there I will show you how you can have those. So let's so as this session is all about the Spark, so first of all, Spark definition is not by default. If they are in Purview, then how you can get those uploaded, and it's also applicable for your own customized data sources as well. So first, as part of this, first you need to have Azure Purview instance created. So I do have one instance created. So this is sorry. So this is my Purview instance created, and there you can see all setup is done. And behind the screen, when you spin up this environment, so there are few other resources which got created. So there you can see my resource group name is Azure Dev Conf, and then I do have another resource that is going to be part of Azure DevConf, manage RG Azure DevConf, it will be automatically created with two resources in it. One is Event Hub, another is the storage. So Event Hub is actually, it will be responsible for scanning your data and pulling this information and pushing this information to Purview. And by default, it is going to have two entities. One is Atlas entity, and another is Hook. These are the basically queue you can think of in which actual data is going and filing getting pushed into the Purview. So these two additional resources will be there. Now coming back to my Purview. So uh, as part of Purview, and for this demonstration, I need to have some basic information like what is my data Purview string and what is Event Hub string, because that I need to use in my Databrick notebook. So once I have set up my environment, I have those two set of information with me. You can get it from the properties. I'll not show the properties, the key that will be getting exposed. So once I have those, then what I will do, I need to configure my service principal, because programmatically I need to handle those things. So for that, I need to have a service principal, and that service principal, first, once it is created, I will get it published to my Azure Purview. So let me quickly show you. In Azure Purview, there is, once you open this in Studio, there are multiple sections that you see here. So one section that is of the management part. So if you have created, you will be having full access of that. There you need to go to security and credentials, and there you also have flexibility to add more users. So this is the central piece where you need to demonstrate, or you need to configure all the security principles. Once you have configured that, so your service principal is going to access of your data Purview. Now instead of using your own credential, you can directly hit the service principal to push the data, or using the REST APIs. So let me talk about the REST API that I will use to publish the metadata information related to the Spark job. So this is the REST API that I will use, and this is already as part of the documentation you can go through. But this REST API is all about how you are going to update the type def. Type def is a kind of metadata information that I need to update for the Spark job. So this is the endpoint that I'm going to use. I just need to have provide my endpoint information there. So let me show you this is my Postman, in which you can see I have used the same API endpoint to update my metadata information. And this is my Purview instance, and authorization, I have provided my service principal bearer token. And once I hit the get information, it will return me all the type defs that I do have. So these are the type def which is already part of my data Purview, based on which it can we can configure data sources and all. There you can see one is Azure Blob Storage, and apart from this, if you will scroll down, you can see a few more, like this is Cosmos DB, and you can see many, and so many type of that you can get it from here. So once you have tested, like my service principal is working fine and I'm able to get all the type def, but you are not sure what are the type def that I need to have for my Spark job, because you may not be sure about the structure that is being provided. So those are already published as part of Atlas framework. Let me also show you, those are part of GitHub repository. So if you go to Spline, because underlying to integrate Azure Purview with the Spark, I'm going to leverage the Spline libraries. And Spline libraries, they have already provided the metadata model that you can directly push to data Purview for that integration. So these are the metadata information that you need to see there. You can see one is entity definition that you see here, that is Spark entity. And this Spark entity is going to have some attribute with name, like name. And then for Spark attribute, it will have some, what is the type reference of this. And for what is the data set attributes, what the Spark data set, inverse reference. So those things will be part of, as these are part of basic my Spark entities. Apart from this, you can see a few more entities that is like Spark job. So that will be also part of data purview once you push this. And this is like, you can go through in detail like what does it mean to be a process and what does it mean to be entity. So both have different syntax in terms of how data will be pushed or to map this. You, for no brainer, for now you just need to copy it and paste into Postman. In Postman, I have just replaced that get command to the post command. Rest my URL is same. In body, I have just copy pasted the same information that I have copied from the GitHub. And as an output there, you can see my information has been pushed to the data purview. And there you see, I can see Spark entities that is now part of this. In similar way, it will also specify the other entities that we were looking for, like Spark dataset attributes and few more. So as a first step, I have defined my metadata information related to the Spark in data purview. So my data purview is ready to take any kind of data which is aligned as a Spark job or the Spark entities that I can directly push there. So now my first step is done. Now switching back to now switching back to purview. So in purview, once you have defined a tile, you can't see any asset right now. Reason being because you don't have data, so it's only the definition that you have currently loaded. So what you will do now, you need to start pushing data to purview to track the full lineage. For that, as I'm speaking about the Spark job and spline library that I'm going to use, so I have spin up one Databricks instance. In Databricks instance, I have one cluster. In cluster, as a first step, I need to make my cluster aware that I'm going to use spline library, and this spline library is capable enough to create a connection string with an event hub and then start pushing data to data purview. So first most step as a part of Databricks, I need to install those library. So there are three libraries. These you can see here. These you need to configure as part of your Databricks instance to pull data from your notebook and push to data purview. So let me show description of one of these. So this is the library, and one for important thing is you need to have this exclusion information. So if you are going to miss it, it's random behavior which I have observed is, if these will be getting missed, you will be getting log4j errors. So some conflict may occur. So be aware, you need to add all these three libraries and you need to apply the exclusion information for those Spark libraries. So once you have installed those library, your cluster configuration is done. It is ready to use libraries of spline, and once you are going to write your Jupyter notebook, you can push data. So let me show you Jupyter notebook as well, which I have created. So I will go to workspace. So this is my notebook. So it's a kind of the basic information that the basic set of activities you need to do. So if you have your own notebook, you need to do some previous configuration like this section and this section that is required for tracking of your lineage information. So let's talk about one on one. So first of all, the event hub that has been created, this is the Kafka enable event hub, and underlying we are following the same pattern which is being used by the native Atlas. So that's why you can see my Atlas server, or even the server which has been created, or event hub that has been created as part of data purview, is still named the same. So I need to first provide information about my bootstrap server, then the JS configuration I need to provide, And another is there when this event hub will be created, there will be so many IDs that will be, maybe few other queues that has been created for that. For that, I need to specify which kind of group ID I would be using for the spline lineage part, and that is always being an atlas for now. So once you have been defined this, and next step is you need to say, okay, basic information, my the Kafka enable event hub information I have provided. Now start tracking the lineage, and that is being done by with these two statements. So these are the critical. You need to first import the library for the Spark lineage initializer, and once you have imported, you can start tracking with this command spark.enable lineage tracking. So once you have done these basic information, now you are free to write your own code. So it's your business as usual. You just write your business logic, whatever you want to be. For now, as a simplicity, what I have done is I have just you know uh, exported a dummy employee files from the internet, and I have uploaded that in my Databricks cluster, Databricks. And after that, I'm just reading that file and saving this into two different with two different name. After reading this, one is employee 112 and employee 11 and 12. So these two separate copies I'm going to create with a single file. So this is very simple job. You can have as complex as required. So once you have done is, once you will start there, let me run this command. So so first it will configure the system properties. Once it is done, it will import the statement, and now it will run the job. It might fail because I have already created a file with name 11 and 12. So let's see. So then I will move to data purview. Yeah, this you can see this has it is saying it is already have a file with name this. Then what I will do, let me change. I will say, and let me run this again. So now it will again create two more files with name employee 13 and employee 14. So sorry, let me try. So once it is it will be able to run. Let me quickly go to purview. There I will show you how this lineage information should look like at high level. If you see my job, this is very simple. It is reading a CSV file, and it is after my this Spark job, it is going to write this into two different pieces. One is employee 2 and employee 10 and employee 15. So if I will go to my data purview, first let me show you a few more things. So in my data purview, if I will go to browse assets, so this is my root collection. There, in the screenshot you could see there were multiple. So this is the collection. There you can see all the attributes based on which data has been already pulled from the CSV file. You can see it here. So this information, and let me also show you the CSV file which I have tried to read. So this is the CSV file which I have uploaded in Databricks, and which I'm just trying to create multiple copies of this. So this is the file. There you can see the multiple, the header, employee ID, first name, last name, email. And if I will switch back to here, the information that you see here, 5650, and for example, if I pick specifically this, I'll click on this, and this is the actual data information, and from where it is coming, it is the Spark data attribute. And if I need to get more detail, there you can see this is a string type. And if I will search for this information in my Excel file, so there you can see this is the data. So so once I have defined the metadata, now as my Spark job is going to run, it will automatically pull the actual data, and it will pull all the information, which kind of data it is having. Since I don't have defined any set rule for PI information, otherwise all the data classification will come into picture. And for all the data that it is going to pull, it is going to provide a unique fully qualified name. So in case in future if you need to refer this data, this is the actual qualified name that is being used for any kind of data processing. So this is all about the asset that it has pulled. And I have I was talking about how it is pulling. First is it's reading the file, then Databricks cell is behind the screen processing it and creating multiple copies. So if you will click on the Spark job, this is the actual Databricks cell information that it has captured. And if I'll go to properties, there you can see from where it was getting connected. So it is basically working on two things. It is writing it is basically doing a write command and logical relation that is going to create. And as a input file, this was my input file that was being used, and as part of output is this was created. And if I want to have a little bit more information about this, like click on this is again an asset. There you can see this file was as part of my HDFC folder, and this is the actual location of the file, and further details are like the same. And what if I need to capture the lineage? So what if I need to see, okay, from where this employee2.csv has been generated? I just need to click on the lineage. There it will show. Okay, so this is the file as an output. This was being processed by this particular Databricks shell, and this is the data source. And if I'll switch back to this asset, and if I need to have a complete end-to-end look of this employee.csv, like which kind of processing has been done on this particular file till now, there you can see this file was being taken to Spark job run, and they had created two different files. So one file name was employee2, one file name was employee1, and with employee1 I had created two more files. So one file name is employee11 and another is 12. So this is the way it is, end to end. It is giving me the holistic picture about what happened to this file and where data is coming. And for more detail, you can also if there is another a way to get the full insight about how the data structure or even the table structure that looks like. So if you go back to the collection, one second, let me see if I do have, okay, this logical okay, let me go to the same way. I will browse the assets and I will select my collection and I will go back to my Databricks cell, and in properties I see this is my input. So this input is a data input classification type. There I can see what are the property of that data set. So employee ID, first name, last name, email, manager, department, and if you will have a look in the Excel file, all these parameters are same. So that's how it is automatically able to classify which are the header and which is the actual information part. So that's the beauty. And end-to-end lineage you have already seen. So this was very basic and very simple demo about how you can integrate your own data sources of which already metadata information is not defined in data purview. So this was a very simple example with a Spark in which I had used the Spline libraries. In this way you can create your own metadata information, and you can create your own libraries that with which you can pull and push data to data purview. So this is all about the demonstration, and I think we are good for any kind of question if we do have so any questions for me?
Hey, Reno, so far we haven't got any questions here. So can you tell more about the pricing model and or how it will incur my budget? What are these different options I can choose for if you are going with Purview?
So for purview again, there are different tiers that you can opt for. but for bare minimum is one is, as I have shown you, it is going to store the metadata information, and it need to have a Kafka enable event hub. So those two extra resources will be getting built apart from the Purview. And actual cost of the data Purview is not much high, and based on the tier and number of out of box, there are 100 connectors that has been defined. So how much data you want to get it scan, how many data sources you are going to define, based on that pricing may get impact. So totally depend on the business scenario that you are looking for, but it's very minimal being a SaaS service. So it's, as compared to other solutions, it's very minimal.
Okay. So when these big enterprise companies, right, when they normally go for these SaaS services, they are particularly worried about the data, about the compliance sort side of things, right? So what are the offerings on that particular?
Uh, so data purview, although it was launched last year, but we are gradually increasing the regions in which it will get deployed, and although the certification and Microsoft Azure, this is having highest number of certification in terms of compliance, and on top of that, because this specific service is all about the data governance and compliance. So that's why you need not to be much worried about how these will be taken care. And the data, as I said, this is your storage account that will be getting attached. So based on your geography or your industry requirement, you can select which in specific region you want to have it. And on top of that, based on the data classification, let me also show you. So you can also define various type of classification. So these are the classification. uh, One second, for date asset I have not. So these are the classification, which where it went. One second. So in this, you can define your own classification set. Yeah, these are the classification that has been defined. In similar way, you can define your own classification. So for now, we have tried to touch upon various industries like government, you can see, and based on the region. So these are the basic that we have tried to capture, but you can define your own custom classification and classification rules. So this is all about the actual data, but if you talk about the overall as a SaaS solution, that we have so many certification, you need not to worry about those. And most of the industries, geographies, we have already covered.
Okay. Thank you, Renu, for answering those. I haven't got any questions so far. So once again, it was our pleasure hosting you here in the second edition of this year's conference, and hoping you to come back. You will come back next year also.
Thank you so much. Thank you so much for having me in, and I hope everyone is enjoying this 2 day of conference. Very fruitful. At least I have found a few sessions very interesting. So yeah, keep enjoying, keep learning, keep growing. Thank you so
And
much for having
yeah,
me.
and to all the viewers, we will be uploading these recorded sessions in YouTube. So you can always come back to our channel and watch these sessions if you have missed it. Okay. Thanks again, Renu, for your time.
Thank you so much.
And as we have some time left, we will take a break and we will be starting our next session by 12 o'clock. See you soon. Hey friends, welcome back to the next session we have on track 10. We have Ambrish Ganguly here who will be talking about creating a recommendation engine using text data, cosine similarity, and word encoding techniques using Azure ML. So without wasting any much time more, I am handing it over to Ambrish. Ambrish, the stage is all yours.
Thank you so much, Amal. Let's start. So, first of all, you can find me everywhere in LinkedIn, YouTube, GitHub, and Twitter. So, these are my coordinates. Hope you're able to see my screen, right?
Uh, no, you're not sharing.
Okay. I'm not sharing, right? Okay. Okay. Now you're able to see my screen, right?
Yes, we can.
Yes. So this is what I was speaking about. So I am everywhere in LinkedIn, YouTube, GitHub, and in Twitter. The What we are going to do is that we will build a recommendation engine using text data, cosine similarity, and word embeddings. You need not take any screenshot or anything. The code is there in GitHub. There is a detailed write up also in the blog. So just enjoy, and let's also learn this thing. And I'll also learn if you have any questions. So what we have done is that we have taken a case study. So this is about Career Village. So what is Career Village? It is a community where students can get free personalized career advice from real life professionals. So what they do is that they'll do something like this. They will put across a question, and then this community will route the question to the appropriate volunteer who is proficient in this subject. So this is a computer science question. So it will be routed to somebody who knows computer science. This is a music question, so I'm not a music person, so it will not be routed to me, it would be routed to a music person. So what I have done is that this data is from Kaggle. There was a competition which was done. I participated in it. I did not win any prizes, but I learned a lot. So what I have done is that I have modified it a little bit. So let's learn a little bit about this, a little bit more context. So what I've said is that this is an US based agency. So US has almost 500 students for every guidance counselor. So I don't know in India how many guidance counselors would be there. So 25,000 volunteers have created profiles and opted in to receive mails when a career question is fit for them. Careervillage.org needs to be able to send the right questions to the right volunteers. So, what was the objective of the competition? Is to develop a method to recommend relevant questions to the professionals who are most likely to answer them. So it's kind of like, if you see, it's like a Flipkart or an Amazon where you are coming in. If you have bought something, a similar item is being recommended to you. It's something like that. If you've answered a question or it's matching with your profile, a similar thing is being recommended to you. But I have changed for this discussion a little bit differently. What I've done is that I've got the questions, I've got the answers, all of it is there. The professionals are also there. What I would do is that I have a question answer bank, right? So what I'll do is that given a question, I'll find a similar question and then I'll find a corresponding answer. So a little bit of modification to the actual problem statement, but a generic one in which you can use it in any ways. And we'll see of how that is going to help us. Okay. So how am I going to do it? You give a question, I'll find similar questions. So it's not like a tag matching or text matching. I would just try to match a similar question, and then we'll get the top and similar questions. We'll find the corresponding answer and display the answers. So it is something like this. So I want to be a data scientist. What should I study? And then you press on recommendations. You will see something like that. It would give you some recommendations out here. So what I'll do instead, um, before we get on to all these stuff, let's step back and explore certain concepts. Now, what is there is a set of questions. A question is text data. Now, I have to convert it into numerics so that it would help us to compare and to find similarity. Now, one thing that is very common is that you can do something called a one hot encoding. What it is that this sentence out here, it is like the is there, so it is a one in the, and the cat is zero, and all these things. The problem with this is that the matrix that you create is huge, so it might not be a great idea to do this sort of thing. So another technique where I convert a sentence into a value is something like giving some numerals, like the is one, cat is one, sat is three. But problem here is that there is no relationship among the words, that some words are similar. We are not placing the words together. So that is a drawback of this method. What happens is that there is another technique known as the word embedding. So, word embedding is a technique in which what they do is that they convert each word into a vector, and it can be, in this case, it is a 300 dimensional vector. And the beauty of it is that these vectors, what happens is that the word which is similar, the closer the vector is to it. So let's explore this vector concept. I'll start from scratch, so no need to worry actually. So, so what is a vector? So if it is a two-dimensional point, it will have 2 points, right? So that is a two-dimensional vector. If it is a three-dimensional vector, it will have 3 points. Now I have a 300 dimensional vector. So we cannot visualize it. So it is going to have 300 points in a 300 dimension. Now, how do I measure that the vectors that I was saying, they are similar to each other? So a very basic high school concept is that a cosine of the angle between the two vectors. So if you remember, cos 0 is 1. That means this vector is just lying on top of that. And cos 90 is 0. So cos 90 is 0. That means they are orthogonal and they are not similar to each other. And if you are very math oriented, uh, this is the formula for that. It is sigma of ai bi, and then you take the norm of a and b, which is actually, if you write in Python, it's a very simple thing. It is just if you have two vectors like this, 1 0 0 1 and 1 1 1 1, a dot b is 1 star 1 0 star 1 0 star 1 1 star 1, and al2 norm is very simple. It is 1 star 1 plus 0 star 0 plus 0 star 0 plus 1 star 0, and then you take the square root, and then it is the same. And this a dot b by al2 norm star bl2 norm is this. So this is, I just wanted to show you, if suppose you want to do it from scratch, if you want to write in your own favorite language, you can do it. But in most cases you don't require this, because there are libraries which would do it for us. So the takeaway from this part that I was saying is that we have two vectors and how they're similar to each other. Now let's jump in and let's have some fun actually of these word embeddings. So what I'll do is that I'll go to notebook here, and in this notebook what we have seen in theory, we'll see it by doing an example, several examples. So this is a very fun type of thing before we jump into the recommendation engine. So what we are using is that we are using a library known as Spacey, which is a very nice library. It abstracts a lot of things. So this library, I load it, and it is a very large model, and it is having around 684,000 words in it, and each vector length is 300. So let's see. So what is a vector look like? So if I do an NLP of a queen, so what we'll do is that we'll do a comparison between queen, king, mother, and princess. Okay. So NLP of queen, and so this is a value that we are getting. It's a 300 dimensional vector. And then what we do is that what is the similarity between a queen and a king? So it is a cosine similarity, and you see the value is coming to 0.72. The queen and a mother, you see it is dropping here. It is a little less similar. And a queen and a princess, it is a little more similar than the mother, but less similar than a king. So this is one fun. The another fun which I tried is that if suppose I have a sentence, right? I have three sentences. I'm a software consultant. Hey me, data guy. Hey me, plumber. So these, if you do an X1, X2, which is a software consultant and a data guy, it's 0.73, and a software consultant and a plumber is 0.64. So you understand the intuition of how the motivation of using this technique is so very useful in identifying the vector similarity. Let's do another fun example. So here I just chose some junk food thing. It's not good for health, but let's see. Pepsi. Oh my God. Mhm. Pepsi, Coke, Sprite, chips, potato chips, and teacher. So I do a Pepsi and a Coke. It comes to 0.65. Pepsi and a Sprite 0.39. See, Pepsi and Coke is greater than a Pepsi and a Sprite. Pepsi and chips is 0.24. Pepsi and teacher, absolutely no match, minus 0.009. And a Pepsi and potato chips, it increases. So the concept is that we are using this concept of word embeddings to get the similarity vector. Now, what we'll do is that we will use this concept in our career village recommendation system. So let's jump in. I have done it in Python, this thing. So what we have done is that, as I was showing, so don't worry, all the code is here. It's in this place. Maybe I'll just go and put it in the chat, and maybe later on we can share it to others. So this, I put it in the private chat, so you can use it later. So don't worry about the code. It's already there in GitHub. So this career village, what we are doing is that there are these data sets. There's a questions data set, there is a professionals data set, and an answers data set. So the questions data set is something like this. It has a questions ID, questions author ID, questions date added, questions title, and a questions body. So this is a question, this is a questions body. There is a professionals thing out here. I will not use the professionals much. We also have the answers also. So the answers is also here. So what we have done is that we have merged all the data sets together, and now we have the professional answers questions together. So the answers are there and the questions are there. So you have the questions body, the answers body is also there. Now, what I do is that I just take, I just filter out where the title is not there and the questions body is not there. And then what I do is how many question answers are there? It's around 50,106 questions are there. And then what I do is that I make a questions title and a questions body. I combine them together so that I can form a text. So our intention is that, so I'll find the questions vector and then I clean the text. So what is cleaning the text is doing is that it is just stripping off the punctuation, making it lowercase, all standard stuff. You can do more things, but that is what it is doing. And then what I do is a very simple thing that I was showing in the previous word embeddings. I load spacey, and then for each question out here, I create the questions vector. So what is happening here, just like the queen thing that we had, just like this sentence we had, what we are doing is that for every question we are having a 300 dimensional vector. So you see, this is a 300 dimensional vector for each question we are having. So each question is now converted into a 300 dimensional vector. So think of it is questions, which is a text, is being converted into a 300 dimensional vector. Now, what is happening is that uh, we are getting the shape, and this is the shape that we are getting, which is a 300. And then what we are doing is dumping it into a pickle file so that we can use it. So what is happening down here is that all the questions, so the 50, uh, 50,000 questions are being converted into 50,000 into 300 dimensional vector. Okay, now what we are doing is that we are asking a question. I want to be a data scientist. What should I study? This is a question. Now we are converting this question also into a 300 dimensional vector. And then what we are doing is that we are doing the cosine similarity. So if it was a two-dimensional vector, you can imagine these two vectors are, for that we are doing the cosine similarity just like this guy over here. But since it is a 300 dimensional vector, we cannot show you the visualization. So this is how we can do the cosine similarity. And then what we do is that it would give a result, and we are sorting the result so that we can get the highest value. So the higher is the value of the cosine similarity, the more similar is a question. And therefore, we can use this question to get the answer for that. So this is what is happening in the rest, all these things that is happening. What I am doing is that I am taking the best question, the best question out here, and I am getting the answer for that. And you are seeing that I asked, like, I want to be a data scientist, what should I study? So after that, it is saying that it is saying that the best one is -1. So you should search for algorithm videos. Usually when studying data, you should also know about database structures and all these type of things. Next one is that it is saying that you require analytics capabilities. You should study SQL, Excel, and all these things. And then it is showing that you can do, you can learn software coding and you can become a software engineer. So this is what is happening in this case, that we are using this to the vectors which we are using, and we are finding the relevant questions answers by using the cosine similarity. I will take a pause here and see if there are any questions before I move to Azure ML. let's see if there are any questions. Okay.
There are no questions.
Okay, there are no questions. That's fine. So till this point, what we have done is that we have used this cosine similarity concept to get the best question answers for that. So what should I learn to be a data scientist? So this is what the answers are looking, and this is how we can find it. Now, this is all in my Jupyter notebook, and if I want to convert it into Azure ML, let's see of how we can do it. So I'll just now shift gears and show of how I can do it in Azure ML. So Azure ML, before I go into Azure ML, a little bit of background about Azure ML. What is Azure ML? It is a platform for operating machine learning workloads in the cloud. So it has all these things. You have all these various things which are there. It is giving you the compute, it is giving you the data storage and connectivity, it is giving you workflow and orchestration, it is giving you model registration, deployment, and metrics and monitoring and model deployment. See, it is in one place you can monitor and you can scale up your systems very easily. Now, what we would be using in Azure ML in this case is that we would be using a workspace, the compute, notebooks, pipelines, data, experiments, model storage account, application insights, and key vault. So I will go step by step through it. So usually in Azure ML project, you have these three very high level things. You have a model train, you have a model inference, and then you have a model deployment. Okay. So how we will build the model in Azure ML? One thing is that we will go through these 8 steps, and I will show you of how we do it. And let's jump in and show it. This takes a lot of time to execute, so I have executed before, but I will walk through each and every step and show you of how it is done. So I have my Azure ML um, notebook ready. What I have done is that first is that I'm using the Azure ML workspace. So I'm creating the workspace. It is the house of everything. So here I'm creating the workspace. And when the workspace is created, what happens is that, so this is a workspace. I'll just go and portal. So when I'm creating the workspace, this is RG Azure ML, this is a resource group. And what is happening once I create this workspace, a lot of other things are being created. Storage account, a key vault, application insights, and this is a workspace name. We'll come to the AKS cluster later on. Okay. And the container registry later on. This is not created when the workspace is created. So this is a workspace which is created. So this workspace is created when I run this command. This workspace is being created. And you see that these are the things which are being created with the workspace. Now, if I go and see what is in the workspace, so this is a workspace. So this workspace, you can consider it as a house of everything. We'll conduct experiments here. We'll do a lot of things over here. Why am I doing all this stuff? Is that we have done the heart of the building in the Jupyter notebook, and now I am going to productionize it and show you of how you can do it in Azure ML, and you can scale it and you can deploy it to thousands and millions of users. It was previously in my machine. Now it will be deployed to anybody you want in the whole world. So first is I'm creating the workspace. Then what I do is that we upload the data, that is those files which are there, the professional CSV, the question CSV, and the answer CSV from my machine to the workspace. So where it is going in the workspace, when I'm uploading it here what is happening, it has got the workspace as a data store. If you go here to the data store, you go here to the workspace blob storage, account name, containers. This is the data in which it is all being stored. All the data is now stored. Now I'm pushing all the data which I require into this blob store out there. Now next what I do is that I create the training folder. That is fine. This is where my training script would be there. So that is nothing much. Now what I do is that, now you imagine the compute was going on in my machine, in my own machine. Now I want to do the whole compute not only in my machine, but I don't want to do it in my machine, but I have to do it in Azure. So I create a compute cluster, and you can choose your compute cluster. I was used a standard D2V2 in it, and I have created the compute cluster. Note that my whole thing, that my whole these clusters are in my total house. And what is my house? The workspace. So I go to the workspace again, and then I go to compute. After we execute it, this compute cluster is being created. This takes quite a lot of time. So I have created it before. It is a compute cluster. It is allocated. It is a standard V2, 7 GB RAM. It is all done. And then what I do, so what I have done till now is that I have uploaded the data, I have created the compute cluster. And then what I'll do is that I'll create the model. So here I'm creating the training script. So the training script is something that I had written in my Jupyter notebook. I'm using that same code and I am pasting it here. Only difference is that I have to load this spacey and all those things. And you see this whole code that I ran through, all that is there now in my training script. This is a training script. So basically what I have done is all the code that I have written down here while training it, till this point, I have all of it is now in my training script out here. Okay. And then what I do is that I create the environment. Why is the environment required? Because this script requires certain libraries. Just as you would write any program, you would require libraries. But this is a base metal machine that I have done. I have to install those libraries. And so what I do is that I have created an environment, and here the libraries, that the packages that I've used is scikit-learn, spaCy, and pandas. And all that is there in the environment. Then I register the environment in the workspace. And then this is the most important thing. What I have done till now is that I have created the training script, I have created the environment, I have got the data. Now we need something which will combine everything together. So this combination is done by the estimator. So this estimator is combining all these things together, and this estimator is being done. And then what we do, once the estimator is done, we create the experiment, and we create this experiment. So this also takes some time. So I've already done it. So again, I come back, repeat once again. The workspace is my home. The experiments are within the workspace. So, and even the environments are also there. So the environment which I have done here, so this is my environment that I have done. This is a custom environment which I have done. I could have used a very curated environment. So here is the environment which I have created. You see, scikit-learn, spaCy, pandas. It's all there. Now I have created the experiment also. So one workspace can have many experiments. So this is the experiment that I have done. This is the experiment that I have created, and I have submitted the experiment here. So this is the experiment which I submitted, and it is going to run in the machine, in that machine that I have created. So this experiment, if you see, it is completed. So it has completed, and this is the one important thing I want to show you, the outputs and the logs. If you find that there is some mistake, you can find all these things in the logs here. So this is an experiment which is there. So once the experiment is done, what I do next is that I register the model that I have found. I register it in the workspace. So now the model is now in the workspace. It is registered in the workspace and it is there. So what has happened now is that I have run the whole thing. I have created a model, and the model is now in the workspace. Now you imagine that you have done all the hard work. Now the model is there, and now this is an excellent thing that you have done. Now you want to expose it as a service to millions and millions of users, because your recommendation engine by something, it has become very popular and you want to deploy it. So the best way to deploy it into a scalable infrastructure. And what is the scalable infrastructure that we are going to use? We are going to use Azure Kubernetes service. Now, the beauty of Azure ML is that everything is integrated. We can easily now use this model and deploy it in as a service in Azure Kubernetes using the Azure ML SDK. So, how are we doing it? So, first of all, we create the inference script. The inference script here is that it has got two parts, the init and the run. So the init has, in which we are loading the model, and in which we are loading the specie also here. And the run is the one where we are doing the cosine similarity. Remember the cosine similarity that we have shown in the previous lecture. So in the previous part of the lecture that we have shown. So this is a cosine similarity which we are doing, and here we'll pass on the recommendations. So to recap, what we are doing is that in the init we are loading the model, and in the run we are doing the predictions. Next is that we are creating the dependencies for the inference script, the scikit-learn, spacey, and the pandas that is also in the environment file. Then what we are doing is that we are creating an inference configuration. And then what we are doing is that we are creating an inference cluster. Here the inference cluster, as I was saying, now the inference cluster is a Kubernetes cluster. Now, the beauty of it is that the Azure ML gives us the ability to create the inference cluster from here as well. So, what we'll see here is that if you go to compute, the inference cluster is already created by through this line of code here. Don't worry, the code is in GitHub. You can find it and again walk through the code. And now this inference cluster, the AKS cluster, is being created here. So this is a Kubernetes service that is created, and this Kubernetes service, we can also see, if I go to this guy over here, if I go here, this AKS cluster is being created. So if you're familiar with AKS clusters, so what would happen is that you require an endpoint, a service endpoint. So what we'll do is that we'll deploy this model as a service. This is deployed as an AKS web service, and this we are deploying it with the inference config, the deploy config, and the production cluster. And we are getting the endpoint, which is the service out here. So couple of steps here. Inference cluster, we are creating a deployment config, and we are deploying the model to the inference cluster. Now, this inference cluster that is there, it has a service. Now, this service is what we are going to use. So this service, you can find it here. The Echo service out here. So it is this is the Echo service, and this one is one that we have deployed. So let's go back and see that this is a Echo service, and this is the endpoint for it. And then we get the keys of the service. And then what we do is that now what has happened is now your model is now deployed as a service, and you can call it from any application. You can develop a Streamlit UI, you can develop a React.js UI, you can do whatever, a console app or anything. I have not done it here, but you can do it. So here I am calling it from the Jupyter notebook itself, that I am passing in, I want to be a data scientist, what should I study? I am passing it as an application JSON, and I am posting it. And what is happening is that we are also getting the same answers out here. Same answers, hello Chong, and all these things that you can study, these relational database concepts and all these things. You can study about database structures, you can do a software engineer, and so on and so forth. So basically, what is happening through this whole uh, thing is that we have from a text data, we have used concepts, very simple concepts like word embeddings, and with now industrial strength NLP tools like Spacey, it is very easy to create vectors, and we are using a very simple mathematical technique which you have studied in your class 9-10, cosine similarity. And we are how this is how we are doing recommendation engine. It is a very simple recommendation engine, but most likely it works in a lot of cases. So I used it in a competition, not in this competition, but in a different competition, something like that, cosine, and it won a prize. So um, not bad to start. Maybe there are other more advanced techniques which are there to use in recommendation techniques. Another thing that I would like to tell you is that this lecture is quite dense. I understand. I've introduced recommendation engines, I've introduced Azure ML, thousands of concepts, may be difficult to grasp in a single lecture. So I have got a YouTube channel which you would like to see maybe. So this is a YouTube channel which is there. It has got a complete playlist of Azure ML, the DP100 Azure Data Scientist exam. If you want to give it, you can have a look at it. If you don't want to give it but learn about Azure ML, you can just walk through all the concepts which I have explained in this lecture. Is made into bite-sized videos, workspace, experiments, data sets, and all data-driven AutoML, real-time prediction, all of it is here, and Kubernetes service, and all these things are also here. And I'm also doing lectures on statistics, on so and so forth. So if you find that you are interested, please do subscribe to this channel and follow me out here. And I am actively engaging with the community and doing all these videos. So I'll just take a pause here and see if there are any questions. Okay. Not many, there are no questions. Uh, that's fine.
If you are done with the session, I
That's
have a
fine.
couple of questions.
Yes, I am done with the session. Thank you, Amal.
Okay. All
Yes.
right. So when you deal with machine learning and analyzing text and sentiments, right? So
Hmm.
how are you identifying false positives or false negatives from this word embedded text or doing sentiment analysis and all, right?
Mm. This one is more of a recommendation engine.
Mhm.
So we are not going into a supervised learning over here. We are not doing any sentiment analysis. But if we were to do, then we would apply, meaning in that case, what we would do is that we would have a supervised learning algorithm. So what would happen is that this vector, this text vector that we are having, it would have a classification, right? Whether it's a positive sentiment or a negative sentiment. And then you would do a classification problem, and then you can do the false positives and the false negatives. But this one is a much more simpler thing. We are taking the vectors and we are just measuring the cosine similarity between them. So this is how it is done.
Okay. And so you showed us Azure Machine Learning Studio for
Yes.
training your models and all, right? Can you
Yes.
little bit elaborate on the cost implication side of it?
Yes. So what is happening is that I have done the whole thing in the notebook. Then what I have done is that I have used this model. The training of the model is now in Azure, right? In this part that I was showing, this part that I was showing, this whole model, that whole model training is now in Azure. Okay. And then what you do is that previously, if you are doing it in your own machine, if you are changing the hyperparameters and all these things, it can become very cumbersome for you to keep track of the results. So in this way, you can have all your results in this Azure ML workspace. Everything is encapsulated here. All your models are here. So what is happening is that mm, the models are all stored in this registry. So everything is here. And the best thing is that now you want to scale up. Suddenly you find that this model is very effective. So you want to scale it. So you deploy it in Azure Kubernetes service, and you can deploy it, and it becomes very easy to expose to the outside world. So this way, it gives a whole managed environment in which you can do all these things. Otherwise, what would happen, if I may relate, you are doing models, you will forget about models, where you are storing them. Your metrics you do not know. You can store the metrics here in Azure ML, a very managed environment you are doing. And this is a great thing that you can do with Azure ML. And this is especially true of the question that you asked. Like, if it is a supervised algorithm, then what would happen is that you would choose all your metrics in Azure ML, and you can change the hyperparameters, you can store them, and it would be very easy to compare all those models.
Okay. So I'm not seeing any questions so far from our viewers.
Yes,
And maybe I will share the link you shared for the
yes,
repository.
yes. I will also share that the repository is also there. So please have a look. And this one is for the YouTube also. If somebody is very much interested in Azure ML, there is this playlist in Azure ML is there, and it appeared also in the Microsoft newsletter. So, and I've been receiving some very good comments about that. So please have a look. It's more of sharing in the community, so that you can the YouTube channel is also there. You can share it. So that's all.
All right. So it was a great session, great learning for me also. I'm a pretty new voice in machine learning, so it was a great session, and I thought
Not
it
a
was
problem.
also.
Yes. So the intention is that we are using Azure machine learning, and one thing that I am trying to do is that also doing some statistics also in my YouTube channel. So that is one of the fundamentals of machine learning. And also I'll do some basics of machine learning. So if you're interested, please join me, and it's all in the community, and I'll do some mistakes. You'll find out those mistakes and I learn from them. So that's a whole good thing about this community. I'm learning a lot from the community, and it's a way of giving back to the community.
That's very true. So
Hmm.
it was our pleasure hosting you here in the second
Yes.
edition of Azure Community Conference.
Hmm, hmm.
Hope you will have much more associations in the future
Yes.
also.
Thank you so much. Appreciate your time as well as everybody's time who had come in and join on a Saturday morning or afternoon, as you may call it, in India time, and others who are, if anybody is watching around the world, please thank you for listening to me.
Thanks again. So we'll take a break and we'll back with 1 o'clock with the next session. Thanks again, Abhiraj.
Thank you so much. Bye.
Hey, good afternoon, everyone, and welcome back for our post lunch sessions. The first is by Dushyant. Dushyant is going to speak about how we can deploy and maintain our financial estate in Azure. And without taking any more time, I am going to pass it over to Dushyant. The stage is all yours now.
Thank you, Amal. I've shared my screen. Can you, or you can see it, can you?
Yeah, yeah.
Yeah.
I'll
Okay.
share it
Okay,
up.
good. Thank you. Sure, thank you. Let's quickly go through. Hello, everyone. My name is Dushyant Priyadarshi, and I'm here to talk about how to deploy and maintain financial software estate on Azure. Uh, I hope all of you are enjoying the conference. There are lots of things to go through, and I'm really excited about things that we have in line today. And I think the upcoming talks are really nice. So the improved monitoring observability. I'm looking forward to it. Uh, but yeah, let's carry on about this topic at hand: how to deploy and maintain. Um, the one second there you go. The objective of this talk is I recently joined a finance software company, and by recently I mean 1.5 years ago, and I have learned quite a lot. So I would like to share my learnings and learnings of the team I work in. And as well as I would like to gather some feedback. If you have any questions, something you do not understand, or something you are doing and in a different way, and you think we should discuss, then yeah. In case we do not have enough time, and then feel free to tweet later on or come back to me later on or ask questions at the end of this talk. Um, To begin with, I think I'll let you know what is the company I work for. So New Day is a credit card company I work for. So we have um, many brands. By own brands, it's our credit card offering straight to the customers. So like Aqua, BIP, Fluid Marbles, Opus. So these are credit cards offered by the company itself. We do also have retail partners like Amazon, Burton, Debenhams, and a few others. So we issue credit cards on their behalf, and this whole market, whole business is in the UK. Our manifesto is helping people move forward with credit, and that's central to whatever we do as a company. The main points in our manifesto are welcoming, which is responsibly saying yes to people who apply for credit, make sure they can pay back, help them understand what the risks, and then say yes. Understanding, we have always provided supported solutions to help people build credit. If you think during the pandemic, we did provide lots of support to anyone who was struggling with payments. The next point in our manifesto is knowing, to know the customer and use our expertise in credit analytics software and help customers build credit and make their life better. Rewarding in this case, so rewarding is when we see our customers are good at managing credit, we try to reward them by lowering APRs, loyalty benefits, and all those. Like I said, the manifesto is helping people move forward and get credit, and all these points are around that. This slide has lots of numbers. This is just to highlight the continuous growth of this company, of New Day, over the years. So we have been seeing about 20% growth year after year. And if you see down here on the lower left corner, it's a recognized company in businesses in the UK, and it has won quite a few awards. And the recent numbers, if you see on 2020, 19% of the UK credit cards were issued by New Day, which is a big market. And 19% of that, so if you see the numbers up here, 19% of that is a big market. And there are a few numbers in the middle here we're proud of. It's amount we have donated to charity. The anti-bribery and accidents in our organization is 0. And the tons of carbon dioxide we emit, which we're trying to bring down day in and day out. So also the numbers down here, which is roughly showing that we have almost 5.5 million customers, so up to 6 million customers in the UK whom we have issued credit cards. So all these numbers are out here just to show you the scale at which this company is operating. So as a financial company, do we have challenges? And this is what I wanted to highlight, like operating at that scale, having so many good numbers, thankfully, we do have challenges. And because it's technical talk, we'll focus on the technical challenges. The first is security. We have to stay on top of security issues, meet compliance, and like make sure our systems are hardened. It's difficult for attackers to get in or exploit any vulnerabilities. Along with that, maintain a healthy development productivity. It is quite difficult and it's a good challenge to have as well. The next is cultural shift. Years ago, maybe 1950s, 60s, it was okay for finance, the software industry, or banks to have lockdown systems and maybe isolated systems. But now we need to meet the market demands, meaning we need to adopt technology first, have automation in our systems, adopt DevOps and DevSecOps. So that cultural shift is a challenge because we have to continuously improve on what we have been doing. This third challenge is regulatory compliance. So there is a compliance called PCI DSS. It's Payment Card Industry Data Security Standard. As a financial software organization, New Day has to comply with this PCI DSS standards. If we are found to have not been compliant with the standards, obviously the software will not be up to the mark. That's a major letdown. But on top of that, the Financial Conduct Authority can fine us around $100,000 a month, which is a big loss if you are a financial software company and you would be very unwilling to take that kind of hit. The other point of technical challenge is continuous innovation. Like I said, in cultural shift, we have to continuously improve on the products we provide. We have to innovate, create new products, use mobile apps, chatbots, artificial intelligence, and data science to provide services to our customers. On that point, I would like to point out the product BIP that I showed in my previous slide is first of its kind in the UK, where we are providing a mobile app, which is essentially a credit card. So you don't necessarily get a hard credit card. Instead, you get an app, and as soon as app gets accepted, you have credit to spend, and it's first of its kind. So I'm really happy that we were the first in the UK to develop that. So where does all this fit in with Azure? So up until now, I'm trying to show where New Day is in terms of a company and challenges. And from now on, let's discuss how Azure has helped us to do this. So a few years ago, that was before I joined New Day, Azure was chosen as our choice of cloud, and all our products and services are on Azure. Today, we have 30 plus Azure services into one single virtual environment. All of these services, the system as a whole and individual services as well, are PCI DSS compliant. This is the bit, if you remember, I was saying PCI DSS compliance is very important because not only non-compliance will make our software not good enough, we might be charged $100,000 a month as a fine by FCA if we did not comply. So for that reason, we put in a lot of effort to make sure all the systems and resources are compliant. And we are moving towards automation. And the reasoning behind this is, I'm saying moving, most of our systems are already automated. We still have some manual changes here and there, but majority of them are already automated, which is what we'll go through in further slides. But the scale at which you operate is massive. If you think we have roughly 8,000 resources in total, and 3,000 of them are running actively in production. And any point in time, we are managing 20 plus Azure subscriptions. So, and all our systems and services are disaster ready, meaning they will have two deployments or a replication. So at the point, working at that scale, at that massive scale of cloud services, we need to make sure that we can automate and reduce human interaction and reduce human errors while working at that scale. So how do we do this? You probably have already guessed. The answer is simple: CI/CD. which is we use JetBrains for our CI, build and test, and Octopus Deploy for our deployments to Azure. But is that enough? And I think there is quite a bit to it after that. We will go into CI/CD, but the bit that I wanted to highlight here is the team I work in. So I work in the platform engineering team, and we work as a consultancy or a service provider for the rest of the organization, especially a pool of development teams out here. So we liaise with security, networking, incident management, business, and many other teams, design solutions for the pool of development and testing teams so that they can deliver value to our customers. The team itself is quite diverse, and it's my honor and privilege to work with a team with such diverse and highly skilled individuals, where we have SREs, we have ops engineers, DBAs, devs, network engineers. It's a great place to be because you're continuously learning, but it does get difficult if we are to work as a cross-functional Scrum team. So there are challenges, but it's still a good place to be. So from now on, I'm going to explain how the platform engineering team is helping build and deploy Azure services for PCI DSS compliant estate, financial software estate. How do we build? So this is quite simple, and we build and test our software, our code using TeamCity. The platform engineering team owns and maintains the TeamCity infrastructure. So our TeamCity infrastructure is hosted as infrastructure as service on Azure, that is Azure VMs, and we maintain it, patch it, update it, and everything. So that was decided a few years ago that we want to keep it in-house on our Azure cloud itself. So we are constantly looking at alternatives, finding better solutions. But at present, we design, build templates and test templates, security testing templates. So what happens, any development team, if you think we have roughly 30-year development team, so whenever there's a new team added, new joiners come in, all they need to do is clone or copy one of the build templates or test templates, and they will already be able to deploy or build software meeting new day standards. And new day standards are PCI DSS, GDPR, ISO 2001, all those standards. They'll be meeting straight away by building and testing using TeamCity templates. But the point of today's talk is how do we deploy and maintain. So we will not go deep into how do we build and test. Rather, we'll focus more on how do we deploy and maintain our financial software on Azure. I had quickly touched on this, that we do use Octopus Deploy to deploy our software, but there's a bit more to it. So platform engineering team owns and maintains the Octopus infrastructure, which is the same idea as TeamCity. We use Azure VMs to host our Octopus Deploy server as well as tentacles, and we use that to deploy our resources. And we, as platform engineering team, again, we design deployment templates. These templates are steps in Octopus together to deploy certain resources. And one of the ideas behind us, like the platform engineering team, to design the template is because of these set or a subset of the features that we can add to those templates. If you remember, the platform engineering team liaises with many other teams like security team, networking team, business, incident management, even the development teams and testing teams. So we are at this position of privilege to know what requirements are there from multiple teams for our resources, which are finally hosted in Azure. So we would design templates so that when you deploy through it, it is already been integrated, or it is following the right naming convention for the organization. It is PCI compliant, and it's using Microsoft private backbone, or it's resilient, it is just ready. So all those features we add to our deployment templates. So this World Cloud is a subset of all the features we add. And the advantage of this is whenever there is a new team or an existing team, there's a greenfield product or an existing product, if they are using one of these templates, they get all these features for free from day one. So we won't have to go through security approval, this, that, as long as somebody is using these templates. And onboarding also becomes slightly easier, because when we say hire new people, it's easy to just say, go ahead, use these templates. And as long as you can successfully deploy, you are getting all the features. So that's deploy templates. Let's go into our general architecture. In general, at New Day, we are heavily using serverless architecture or Azure Functions. The idea being we wanted to avoid operational support to maintain scalability. So if we had chosen Kubernetes, for example, and if you know about Atlassian had to develop Escalator to help with scaling of Kubernetes. So we wanted to pass this responsibility to Azure, and we are more focused on the code that we run on the Azure Functions, which makes our life easier, but we still need to know like features of Azure Functions, and we have Microsoft support for that. General architecture. In general, like I said before, all our resources are disaster ready. So in this example, if you see, we have, say, web app. In general, any web app we have will be deployed to two regions, the same deployment, and they will have a front door in the front. So what will happen is users' requests will come to the front door, and it will be, because it's active, so it will go to either region 1 or region 2. If for some reason region 1 goes down, region 2 will keep servicing requests, but obviously we will have alerts and incident management step in to fix any issues there. We use Cosmos DB as well, which is globally distributed, again, across the same two regions, meaning the latency of read is less, or read and write, as well as we make sure that it is disaster ready. Proceeding with the same general architecture, any public facing API, we do provide, say, open banking APIs. Any public facing APIs we provide via APIM or Azure API management. And the same idea remains: disaster ready and PCI DSS compliant. The following on with the general architecture, we use Cosmos DB and Azure SQL Server as our data storage services. So Cosmos DB, we have replication enabled. So we will be replicating Cosmos DB across multiple regions, and we can fail over in case of a disaster, or in case if we are doing any kind of breaking change deployments to try out. So we can do that. And SQL Server as well, we have failover groups across multiple regions. So the overall theme, if you notice, is that we are very focused on disaster recovery and resiliency. Any service, we are aiming for 99.99% availability. We are still not there yet. We are working hard to get there, but we are 99% available already in most of our services, maybe a bit more actually. So that's roughly about our general architecture. Our infrastructure as code. So Terraform is currently our main infrastructure as code tool. The way we operate the Terraform is that the Terraform code on the left here is owned, maintained, like modules designed and maintained by the platform engineering team. So it's in the platform engineering team's repository, the Git repository. We have all the Terraform code. What we do is we put them all together into a NuGet package and we deploy onto Octopus. And what Octopus can do is users or developers or testers, whoever, can set values in Octopus deploy pipeline. And those values will control what resources are being deployed onto Azure. We will go a little bit into that after this slide, but mainly the idea here is that Terraform code stays with one team. We maintain, generate the package, pass it for other teams to use. And then finally, Octopus deploy, Octopus deploy will be able to deploy the resources needed onto Microsoft Azure. The pros and cons of Terraform. It's a good, Terraform has very good documentation. It's really easy to follow what needs to be done. And Microsoft does support the Azure RM provider, so those are good things. We can unit test Terraform using TerraTest, as well as security test using TFSec. And security testing is quite important in our field. Recently, SNCC is also bringing out new Terraform security testing features. So those are all good things about Terraform. The other good thing about Terraform, which I have not listed here, is that because the desired state, so we have a state file, it's a desired state, so we can effectively switch off features or destroy resources if we wanted to by making sure it's not in the state file, which can be a pro, but also can be a con. And that's why we have listed that in cons as well. Uh, if say, for example, we are deploying a VNet integration and we want VNet integration removed, then the next deployment, all we need to do is make sure that bit of Terraform code is not there. So it will get removed. So this thing is quite difficult to do in other non-state file-based IAC. But in the same time, because of state files, it is quite difficult to, say, rename a module. If you rename a module, and Terraform thinks that that module name is in the state file and why is it not there anymore in your code, it will assume that resource needs destruction. So if you have, say, a module saying my storage account and you rename it to a good storage account, that my storage account will get destroyed, which is a major problem we have, essentially, because we never want our resources destroyed, at least in production. Even in development, UAT, and other testing environments would prefer no destruction without deliberate destruction. The other con is delay in getting Azure features. Sometimes at New Day, we try to pick up every new feature in Azure, experiment with it, create POCs, proof of concepts, and try to design solutions around it, and hopefully go to production as soon as possible. But there is always a delay in getting latest Azure features on Terraform. So that's another con that we have been dealing with Terraform. The other thing to note with our ISC is, if you understood what I was saying here, that we control the resources being deployed from Octopus, not Terraform code. What that means is ISC abstraction, meaning we are abstracting out the Terraform code from rest of the development and testing teams. So what happens is the platform engineering team is creating a NuGet package with all the modules needed and the Terraform main.tf file, for example. So once we have done that, all the other teams need to do is provide set of values, which in this case is like this JSON here, to the NuGet package. So NuGet package has an entry point. You provide these packages, these values via JSON, and then you get the right set of resources. So in this example, if you think, let's say this is the code in our NuGet package. And Octopus, you're setting these values here, like storage account, instance count 1, name is my storage, resource group name is my resource group, and location is West Europe. So what will happen is our code in the NuGet package, it will say, okay, I need to count is 1. So I have to create one instance of storage account. And the name of the storage account should be my storage. And resource group name is my RG, location is West Europe. And if you had set it to 2, it will deploy 2 resources, and so on and so forth. So what's happening here is development teams do not necessarily need to know or understand Terraform. So the learning curve reduces a bit for any teams that depend on the platform engineering team. All they need to know is what they need, not how. And also, internally in our Terraform code, we could set something like this, like public access is false by default. Unless they set public access true in the variables, it will be false by default, meaning they will be getting a more secured storage account by default. Let's quickly go into the pros and cons of this. First is the ease of onboarding. Because we have abstracted out Terraform, if there are any senior managers or hiring managers in the audience, you will probably relate to this. It's already quite difficult to find the right set of skill sets for your development team. On top of that, if you look for ISC like Terraform, Pulumi, and a few others, it might get difficult. So it becomes easier to hire and onboard members when all they need to know is what they need, not how they need. So we try to reduce the ease of onboarding on any new teams and existing teams as well. And the ownership of the whole Terraform module or Terraform code remains with one team, meaning any issues with our deployments can be fixed and maintained by the platform engineering team. The cons are, again, state files. So state files are integral to Terraform. We discussed this before and we're discussing again. So because of state files, we are very stuck with the module names, for example. If you change the name of the module, many development teams will lose their resources. So it's quite difficult to change a module name. Rigidity. So once we have designed the modules, it's quite rigid. It's difficult for teams to do bespoke changes. And for that reason, we are considering a possible future of ISC. We are investigating, we're creating proof of concepts around this. So we're investigating both Azure Bicep, which is non-state file-based ISC, and Pulumi. So the plan is platform engineering team can generate packages or modules, and those can be consumed by product teams or development teams in their Git repos. And they can design and deploy the resources they need from straight their Git repo, obviously like via Octopus, but in development, they can deploy from their Git repo itself. This hopefully will reduce the friction that we have when we need bespoke software architecture, bespoke resource architecture on Azure. Sometimes Terraform also lacks features, which is what we touched on, and that's where we use Octopus step templates. So Octopus step templates are like steps in an Octopus deployment project. And of those steps, some of them we write using PowerShell, and these are shared across the organization. So let's say a feature is not there on Terraform, then we make sure we provide that feature via Azure CLI or Azure PowerShell using a step template. And all these step templates are PowerShell scripts living in platform engineering team's repo, Git repo, and we create NuGet packets, share it with everybody in the organization, and we maintain it, unit test it, tester test it, and share it with everyone. So the advantage is one team maintains it, other teams can get the benefit. So this is all about how we deploy. We also want to discuss how do we maintain. To maintain the estate, our financial software estate on Azure, we use many Azure services as well as services that we have designed on ourselves. So let's just go through them. The first is Azure policies. So from Terraform templates or modules, if you remember, we could set default values for security and compliance. So we already enforce our policies via Terraform. On top of that, we use Azure policies to enforce our tagging, which is already enforced by Terraform as well. But if somebody deploys outside of Terraform, maybe Azure CLI, maybe an ARM template or Pulumi, something else. So we also enforce tagging, regions where you can deploy, where you cannot deploy, and any other security policies via Azure policies. That maintains the sanity of our infrastructure and Azure estate. With all this, or the scale at which they operate, if you remember 8,000 odd resources, our costs keep on mounting. So it's very important to keep on top of our costs. For cost reporting, we heavily depend on resource tagging. When somebody deploys something by Terraform, or the policies block you from deploying without the right tagging, but we ensure that every resource has the right set of tags. The tags will be which team is deploying it, what product does it belong to, maybe the person who was deployed as well, what date it was deployed. So many other things around it are tagged on the resource. And on the basis of those tags, we classify those resources, put them into groups, get the cost reporting, and generate Power BI reports. So we can see a trend of which team is deploying maybe efficiently, or then we learn from them. If some team is not doing efficiently, we try to help them to reduce their cost. And we always see a trend of what is the cost in multiple teams and multiple resources. And we can also somehow forecast expenses or cost of resources for upcoming projects as well. The next service is Wreck-It Ralph. Wreck-It Ralph, we call it Wreck-It Ralph. It's actually a PowerShell script in Azure Automation. So this automation job, its task is to go ahead and destroy non-production resources. So every few days, it goes and finds resources that it thinks are expired and destroys them. And how does it do that? It again heavily depends on the tagging. If you remember at the point of deployment, we are setting when a resource was deployed, like on the day it was deployed, by what team, and all those tags. So Wreck-It Ralph can read those tags and say, okay, if it is deployed today, maybe it expires 2 days later. In dev, maybe it destroyed in 2 days. Maybe in certain testing environments, it lets it live for a week or 2 weeks. So at some point, Wreck-It will tag it saying, okay, I think it's expired, and I'll tag it with a demolition date saying I'll destroy it on that date. And it will send, with Teams integration, it will send that team a message saying, okay, I'm going to destroy your resource. This is the date and this is the tag. Or maybe you have not followed the right naming convention. Then also it can go ahead and destroy it. So it will inform you that, okay, I'm going to destroy it. So it not only brings the cost down of our overall Azure deployments, it also is an enforcer of good CD practices. So if you have team members who have a habit of, say, manually changing certain resources just to get it to work, but the next time you deploy, the manual setting is lost. So that kind of behavior we try to discourage. And for that, Wreck-It will destroy resources, meaning you need to make sure your CI/CD process always deploys the right set of resources with the right settings and configuration, and you get the same result every time. So that's why it becomes an enforcer of good CD practices. DAL, the next service, is actually dynamic allow listing. So we have something, if you have Azure function, you probably already know about the network restrictions. So in this example, this function app can be accessed by only these IPs. And this is a security requirement as well as a compliance requirement that we need to meet at New Day. So if you, so what will happen here is only those IPs or requests from those IPs can trigger this function. But it gets quite complex when we have thousands of resources, and many of them as function apps, web apps. So we could do this for function apps, web apps, key vaults, storage accounts. So all of them can restrict what IPs can request them or connect to them. So what dynamic allow listing does is, if, say, in our environment we have a function A and only these internal systems are allowed in, and function B comes in, then dynamic allow listing system will make sure that automatically gets the IPs of other systems in our environment. And the same thing can happen with another function coming in. So dynamic allow listing system will go ahead and add IPs of function A on function C, also function B and function C, as well as internal systems. The overall architecture of how it works. So dynamic allow listing system is a function app. It's a function app working in our subscription or in multiple subscriptions. And it takes a config here, which says what resources should be in, what resources should be outbound, keeps them in a Cosmos DB, and then goes ahead and applies those resources on Azure. So applies those rules on Azure. So it makes sure that if you have said function A needs access to function B, it makes sure function B has the right IPs of function A. So if function A is VNet integrated, then it needs to add the VNet subnet ID, not the IP address. We also have some static rules, which are like New Day's internal resource IPs. They also need to be added. And dynamic allow listing system can handle changes to the internal static rules. Like if we change our internal firewall IPs, the dynamic allow listing system can know about it and go ahead and update the resources those need those changes. Two special cases we have where like a resource has been scaled. So if you have a function app which has been scaled from, let's say, standard to premium, or say P1, P2 to P1, P3, all those scale up cases, it's likely that those IPs will get reset or changed to different IPs of the outbound IPs, I mean. So when the outbound IPs change, any functions that these functions need to depend on, they know these IPs have changed. So that's when we have event grid integration. Event grid tells us whenever scaling has happened, and our function triggers, and it goes and updates the resources that need the update. The same in case of resource deleted. Whenever resource deleted, the set of outbound IPs for that resource need to be removed for security and compliance. We do not want any IP that should not have access to a resource to have access to the resource. So again, event grid can trigger saying, okay, a resource has been deleted from our subscription, go ahead and remove the IPs of that resource. This subject can be a bit complex to explain quickly, but here's a link to the talk I did last year at Azure Conference. Azure Community Conference, and feel free to have a look and definitely tweet if you think, if you have any questions, ask me on Twitter. My DMs are open as well. The next service we have is CAT. So CAT is a certificate automation tool. In at the scale at which we operate, again, just to point it out again, is that if you remember, we have thousands of resources, roughly 8,000 odd resources. Sorry. So we roughly have 8,000 odd resources. And at that scale, we are managing 300 odd certificates. It could be the app service binding. It could be how we are communicating with our third parties. So all these certificates are very important. So with 300 resources certificates, it gets quite difficult to keep track of what is going on where. So CAT is an app service. It runs in our subscription, and it can read cross-subscription resources and find out details about certificates. And it will have a view similar to this, where it can give us a list of certificates, what subscription they belong to, what resources they're bound to. So it could be in an app service, a front door, or whatever resource these certificates are bound to, or in case it's not bound to a search resource, it'll find that out as well. And when do they expire? That's the most important thing, because when they expire, we will have downtime. We need to plan and mitigate that. It can quickly highlight these kind of issues, like whenever it knows these certificates are going to expire, certificate automation tool can tell us beforehand that, okay, your certificates are going to expire. As well as it also gives us an information about how many certificates are managed by Azure. So, on front door, we can get Azure managed or front door managed certificate, meaning our responsibility is less in such case. So certificate automation tool encourages us to try improve this number, saying, go ahead, make sure we manage less and less number of certificates. This is a work in progress as well. We are continuously adding features, and we are hoping to someday add a feature where we can upload the certificate into the tool. It will go ahead and update those resources, or maybe some point generate the certificate, update the resources without us having to do anything about it. So that's the also part of maintenance, our monitoring and alerting. We use App Insights. All our resources, all our app service, web apps, and many other resources, function apps, we have App Insights enabled on them, meaning we are constantly looking at telemetry data. And we have to be very careful with it, because we don't want personal identifiable information shown in App Insights. So we have to follow all those rules, make sure it's GDPR compliant, PCI DSS compliant. But in the same time, we need to be aware that whenever things go wrong, we need to know about it. So we use Azure dashboards and Grafana to see a trend of things going on in our environments, like request to Fondo, what is the latency, what is the request, what is the uptime, what is the downtime. So all those we have Grafana and dashboards, Azure dashboards, so we can see a trend of how things are changing across over time. Along with that, we use Azure alerting. So we constantly create alerts based on logs from App Insights and log analytics, saying if, say, latency has increased in our front door request servicing, or say a certain resource is getting lots of errors in its dependencies. So we gather all those, create queries, and make sure that we get alerts. And once we have got alerts on our phone, on our apps, that leads us to incident management. So incident management is when we get an alert of something going wrong, when something has broken down, maybe a resource has gone down, or a region has gone down. So then incident management steps in, or we step in as the incident management team. The platform engineering team, by we I mean platform engineering team, we have historically managed the incidents for development teams, but currently we are looking at shifting left, making teams own or help teams own the incident management part of the product. We have another incident management team as well, who liaise directly with third parties whenever, say, our dependencies get errors and issues. we have to liaise with multiple parties to make sure that resources can come back up as soon as possible. Let's go into learnings. So this is mostly my learning as well as learning as platform engineering team over the last 1.5 years. ISC abstraction may not always work. So this is here I'm talking about, if you remember, when Terraform code, we were abstracting Terraform from the development teams and testing teams. It's a good idea because it helps reduce the learning curve or reduce the onboarding effort from for multiple teams. But in the same time, it's quite rigid. So when a team wants to bespoke changes to the infrastructure or wants to, say, try out a new proof of concept, it gets quite difficult to carry on with ISC abstraction. So like discussed, we are looking at Pulumi as well as Azure Bicep. Maybe Azure Bicep is the way we're thinking because we already have Microsoft support in place because we are an Azure house. So we're thinking to support hopefully both ISC abstraction as well as using custom resources with Bicep. But that's a work in progress, and we are investigating more into it. The other learning, that's probably more a personal learning, is that I have found resource tagging is very, very useful. If you're an Azure house and you are using, or not even Azure, any cloud, if you're using Google Cloud, Amazon Cloud, any cloud, resource tagging is very useful. Please tag your resources. It will make your life much, much easier. So we have discussed this before as well. So with resource tagging, we use resource tagging heavily for our cost reporting, our resource management, to know who deployed the resource, when was it deployed, and say also our services depend on it, like Wreck-It Ralph knows how to destroy a resource, when to destroy a resource, all of these based on tagging. Our cost reporting, like Power BI, that depends on resource tagging. So if you are using cloud resources, please tag your resources. It will make your life easier. Resilience is an ongoing process. I touched on this before, that we are aiming for 99.99% availability. All our resources are disaster ready. We are using App Insights for telemetry. We are continuously monitoring and alerting. Along with that, do we have issues? Yes, we do. We have we're not necessarily downtimes, but we have had issues where we have to jump in and try to fix. We have had some downtime as well. So for that reason, we are not at 99.99% availability yet, but we are working towards it. It's like I said, it's an ongoing process. We have to continuously improve on things because, say, we make a deployment and we break something, or let's say there's a breaking change from Azure, or maybe one of our third parties has done a breaking change. So all these will happen. So we need to cater for those kind of instances and make sure our resources and services are disaster ready. Automate more. So this automate more is again about reducing human interaction, reduce human errors, and enforce good CI/CD practices. Especially when we are operating at a scale of 3,000 to 8,000 resources, it's really, really difficult to manually keep track of and keep fixes up to date across so many Azure subscriptions. Collaboration is the key. So this is a very, very important learning for us, that as a platform engineering team or as an individual, it's close to, not impossible, but very, very difficult. I don't know if one of you can do it, but it's very, very difficult to do it without help from other teams. So multiple teams need to share the burden. So the development teams, the testing teams, they help the platform engineering team understand what's needed by the customer. And the other teams like security, compliance, networking, and business, many other teams help us understand and produce solutions for other teams. And for that reason, I'm saying collaboration is very important. We need to collaborate across multiple teams, prepare solutions for our customers. And the final learning is the cultural challenges. If I were to find out the most difficult challenge in the last 1.5 years, I think it is the cultural challenge. It's when getting people on board with the idea of this whole system in place, because The system is PCI DSS compliant, is GDPR compliant, many other compliance are in place, meaning the system is very complex as well as restrictive. So the cultural challenge here is when you have a new joiner, we have to explain, do lots of show and tell, and show people that why these things are in place. Otherwise, it gets very difficult for anyone joining new to the system to accept this level of restriction and complexity. So that I think is a cultural challenge, and I'm sure any medical device industry and other industries will have similar challenges as well to get teams on board. We need to constantly educate and show and tell and discuss as well, because there will be things we're not doing right, so we need to improve on this. What's next? So there are a few things that we are doing next. First is better cost management. We are trying to reduce the cost of our overall infrastructure, like using multiple functions on a single premium app service. The other bit is pipeline as code. Teams, it does support pipeline as code, but we haven't started using it yet because we are now looking at GitHub Enterprise. Maybe that's the answer. So we're creating proof of concept around it, and hopefully start using YAML-based pipelines soon and reduce issues of, say, pipelines being changed outside of our Git repo. So we want PRs to be changing our pipelines. Azure Bicep. So like I said, we already have a Microsoft support plan in place. We already liaise with Microsoft regularly. So it logically makes sense to use Azure Bicep. Also due to the fact that Azure Bicep is like the next version of ARM templates. Next one is shift left. So this one also we touched on shortly before this slide. So ownership of resources, security, certificate, maintenance, everything. We are trying to shift left towards development team. So what that means is teams can own end-to-end product, say requirements gathering to delivery maintenance to the customer. That's because whenever, say, there is an incident or a certificate expires, product teams are more well placed to know what has changed, especially when we have 30 odd development teams. Only one team may not always be able to know and find out quickly what's wrong where. So as, like I said, platform engineering team operates in a consultancy or service provider mode. So we are going to help the development teams try to fix things, but because of the ownership being with development teams, it will make more sense in the long run. So in conclusion, deploying and maintaining financial software on cloud is a complex affair. Although I must say it is really, really exciting. The challenges keep us on our toes, and we are continuously learning and improving things. And for that reason, I would say it's complex but very exciting. That's all from me. We'll just quickly go through the partners and question and answer. Do we have any questions?
Hey, Dushin. So as of now, I haven't got any questions so far. So
Okay.
let me ask a couple of things, right?
Sure.
So when you work with these enterprise customers, right, one of the main concern they will raise is about data or source code, right? So most of these people are, during earlier days, they are not comfortable with maintaining the code in cloud or building the code in cloud, right? They wanted to do that in an on-prem server, the build operation, the build process, they do that, and the artifacts were shipped into the cloud environment, right? So how are you, or in your organization, how are you managing these kind of conflicts? Is it there? The first thing I want to know is there any concerns like that, or you were easily adopting cloud from the beginning?
I think it was there, but last few years it has reduced substantially. I believe this is due to probably Microsoft's constant showing off of the certificates that they are already compliant. And on top of that, because we have a good compliance and we're open to auditing as well, so we are able to explain to our clients and third parties that we are meeting this compliance and there is nothing to worry about. And obviously, any product we use are already compliant. But it does need constantly making sure that if there is an audit, we are ready with the compliance requirements.
And the other is about around compliance. You see, we have these geographical limitations, right? How we can store the data and where we can store data, particularly if you are in Europe or US, they have strict rules around it, right? So, so how are you managing those kind of scenarios?
So that's the bit I touched on where like all our resources are automated through Terraform, especially all data storage ones like storage accounts and Cosmos SQL. So all of them are either Terraform or Azure CLI. And all of them are deployed to our subscriptions. And before we create subscriptions, we make sure that our policies are in place. So even if, say, somebody tries it manually or ARM template or anything other than the tools we support, they won't be able to deploy to any other. That's a very good point because we wanted to use a service, the name I can't remember, but they did not support storage in the UK. So we had to stop using it because they would only support US. And yes, with GDPR compliance, we need to keep our data in Europe or UK for now. But Azure policies is the answer for now.
And you touched around automating certificate expiry and all, right? There are other scenarios like rotating your keys, especially for a storage account or app registrations and all that. So those all are also handled like the certificate expiry automation, or
These are currently we have pipelines for them, but they're not automatically done. We still have to, like, development team has to deploy it, saying we are triggering a rotation of keys. I think we have lots going on, but that's one of the things back in our backlog. At some point, we'll think about, like the way you said, the certificates, we have way too many certificates to manage. So we're hoping to do like certification creation and deployment. Once we automate that, we'll start looking at automation of rotation of keys. But it is on our backlog though.
so I'm not seeing any more questions here. So,
Okay.
so I
But
want to.
here is my
Yeah.
Twitter, and Twitter in case anyone wants to ask questions outside of the event, they can as well.
Yeah.
So yeah, thank you very much.
All right. So thank you, Dushan. It was a very informative session and gave some insights into how these enterprise customers work, how they integrate their environments, how the operation or the process that they are following, and all those stuff. Right? Really informative. And thanks once again for being a part of a second edition of Azure Community Conference. And we really hope you come back next time and do a session for us. Thanks again,
Yeah,
Dushan.
thank you, Amal. Thank you for the opportunity. It's really good to be here.
All right. So that was Dushin. Now we have around 10 minutes for next session. We will take a short break and we will restart our sessions by 2 o'clock India time. And till then, bye and see you all back at 2 o'clock for the next session. Hey, welcome back, friends, for the second session post lunch. So, we have here Nilesh Gule, who is going to talk about improving monitoring and observability for Kubernetes using some of Voices tools. And without taking much time on introduction, I'm handing it over to Nilesh, who will take you forward. The stage is all yours, Nilesh.
Hi, Amol. Thanks. Let me share my screen.
Yeah,
Please help me confirm that you can see it.
yeah, he'll do that.
Are you able to see the screen?
It's not yet available in Backstage. Are you sharing with StreamYard? There's an
Yes.
option. Okay, very good. It's coming up. Okay, your screen is now on, English.
Okay. So let me go into the presentation first. While switching, is it normal?
Uh, so it's a little bit delayed. Okay, I can. So the PowerPoint window selected.
Okay.
Uh, all right.
I hope you can see my presentation.
Yes, we can see. Sorry for the delay. The speaker got dropped. Please wait till it comes back. Hey, welcome back, everyone. So now we have Sriram with us for taking a session on chaos engineering in Azure. So I would like to welcome Sriram for this session, and I'm handing over it to the stage to him
Thank,
for taking it through.
thank you, Amal. So I hope everyone is able to see my screen.
Yes, it's visible.
Okay, so let me get started uh, showing my appreciation to the Azure Community Conference 2021, the organizers and the people who have supported them. Great work, kudos and a round of applause. And thank you for the opportunity. My name is Sriram. I'm an Azure Solutions Architect. My primary work involves designing and architecting solutions that are pretty much deployed in Azure. Okay, I try to uh, you know write blogs about all the technical findings along the way, and you can read my technical blogs if you're interested at ramsaztechbytes.in. And all the Azure experiments that I do, be it on networking and security, these are two major areas that I pretty much spend most of my time in. um, I save my solutions to GitHub, so you can find me on GitHub as well, and LinkedIn at Sriram Ganesan. Okay. So today's topic is going to be about chaos engineering in Azure. Chaos engineering is not a new topic. It has been there in the field for a while. Today's session is going to be about what chaos engineering is, um, how is that a discipline that is adopted in the SRE world, and what purpose does chaos engineering serve, and then how to implement chaos engineering in Azure. So this is going to be a concept-heavy session, so please do ride along and stick closely with me. So I've divided the whole session into three sections. Like I said, the first section is going to be about what chaos engineering is and is not. And we're going to talk about putting chaos in practice in a generic term, if I'm not talking about any specific cloud vendor or any specific technology using which we're going to perform chaos. If we need to put chaos in practice, then what are the things that we need to be familiar with? And of course, so any technical concept for that matter, it wouldn't make sense, or it wouldn't. I wouldn't be doing justice if I had not talked about the principles and best practices of that specific discipline. And we'll be touching upon chaos engineering for better reliability and observability. So, chaos engineering as a discipline, as a part of SRE, how does it help you in enhancing your reliability and also observability? The section B talks about FMEA practices. So, if you have not heard about FMEA, then this can serve as a good starter. Uh, we'll also see how FMEA can supplement chaos and how these two technologies or techniques can supplement each other and then serve the whole purpose of making the system reliable to the maximum possible extent. And then we'll go through a few demonstrations, out of which one is going to be an actual demo, another one is going to be a code walkthrough, and the third is going to be a conceptual explanation of what happens if something happens in the system. um, in the case of Azure hosted services, then what would be the reaction to that specific chaos and the corresponding takeaways. And the last section is going to talk about Microsoft and open source progress in the space. So we will be trying to see what kind of progress has been made by Microsoft and the open source community in the space, so that depending upon your solution, be it a completely open source system or a mix and match, wherein you have a set of services that use Azure and a remaining set of things that use open source. If that's your scenario, then what are the possible options if you want to adopt chaos engineering in your system? Of course, I would encourage everyone to start learning about chaos engineering, because if you can either be a developer, or it can be an architect, or it can be an SRE, or it can be a DevOps person. In any of these cases, chaos engineering is going to come in handy, and you might have to start practicing chaos to understand the system better. So chaos engineering does not stop with enhancing the reliability of the system. It also helps you in understanding the system better, and also helps you in learning uh, the behavior of your system in production, even before the system goes to production and you have one-off cases. I'll wind up the session with some references or reviews for this presentation. So once I complete this session, you can go back and check the deck. So let's start with introduction to chaos engineering. Before we actually talk about what chaos engineering is, I would like to quickly touch upon a couple of important concepts. Okay. When I say, I've been repeating this term on and on again. If you have attended my previous session at 1 p.m., which talked about the reliability health model, we talk about systems. So systems can be any system for that matter that is deployed either to the cloud or running in your own premises, or it can be a combination of both, wherein you have a hybrid architecture. And system is built using multiple moving parts, and in this case, we name each part as a component. Okay, so any system that runs in the cloud, if it is going to be distributed, I'm doing a categorization, a broad categorization. If it's going to be distributed, then of course the components that make up the system, or the components that interact with each other within the system's context, will not be present within the same system. I mean, not be present inside the same machine, but would be present or hosted in different services. And of course, that would introduce some amount of communication mechanisms, be it network or layers above that. So before talking about chaos, we would want to categorize systems as simple and complex. When do you call a system simple, and when do you call a system complex? Okay, it depends upon the characteristics of the system. I wouldn't go into the details of all these terms, but you can go back and read the chaos engineering book by. I've added the reference, so you can check that. Nora and Rosenthal. Okay, any system um, that is non-linear and produces a non-predictable output can be categorized as a complex system. So when I said a system is ultimately made up of multiple moving parts and consists of so many components, if these components talk with each other in a specific way, wherein the flow starts from A and then moves on to component B and C and then goes back to A and so on, or it can be multiple combinations wherein these flows are going to vary with the user-based scenarios. But with any amount of change in one of these components, if the system's output cannot be predicted, if the system behaves in a manner wherein you do not know how the system would behave, then of course the system is called a complex system. So if you have trouble visualizing it, you can try to equate this to a complex chemical equation wherein multiple components, multiple parts get added to produce a compound. And if you know that a change in A produces a specific output, and the output is going to change in a specific way, then the system is predictable. And similarly, when you have A and B changing at the same time, but you still know the system's output, then the system is still predictable. But even in either of these scenarios, if the change happens in A, but the change can be in so many different ways, which you do not possibly know. And also the output of the system is going to be varying in each and every scenario, right? So in that case, the system is completely unpredictable. It's considered to be a complex system. Okay. And what are systemic weaknesses? In majority of the cases, the companies that start out to build huge systems in the cloud, or be it huge products in the cloud, we try to build the system using all the available tools that are present in the public cloud, and then we get on with it. We deploy our application, we scale it, and then we get on to the actual business of selling the product, or actually making sales. But there is very less time spent in understanding the actual weaknesses in the system. So what do you mean by systemic weakness? Given an inherent chaotic behavior, which means that you would have to pay more attention to the term inherent. I'm not introducing an external factor, but there are scenarios, that there are weaknesses that are present within the system, which will cause chaos, which can cause the system to go totally down, or it can make the system react in a way that is not predictable, like we mentioned at the previous point, or we can consider the case wherein the system produces error. So inability of the system to handle the inherent chaotic behavior that can lead to any amount of cascading failures. So these things are called systemic weaknesses. Okay. So definition. This is taken from the Principles of Chaos. There is a site for Principles of Chaos. You can go and take a look at some of the principles of chaos and what are the modern principles that have been dictated with the evolution of chaos engineering in the distributed systems world. And that is a reason why the people who have founded and who have been practicing chaos right from the beginning of its birth, they call it an experimentation rather than a testing. So it makes more sense to say that chaos is an experimentation rather than a testing. So the discipline of experimenting on a system to build confidence in system's capability of how it would react under turbulent conditions. So that's chaos engineering for you, in simple terms. Okay. And what chaos engineering is, like I mentioned, is an experimentation rather than a testing. So chaos engineering favors verification over validation. Again, this is a fact that is taken from the chaos engineering book that I mentioned earlier. So chaos engineering does not focus on how a particular weakness happened. It focuses more about a weakness is discovered and what is going to be done about that. So it favors verification over validation. Okay. Now that we have seen what chaos engineering is, we'll also quickly touch upon some points to talk about what chaos engineering is not, and some of the related questions that people usually have when people get introduced to chaos engineering, and some of the people who have been practicing related concepts in testing. Okay. You would have seen plenty of sessions online about chaos engineering. If you have seen those, if you come across those, you would have seen this particular term saying that chaos engineering is about breaking systems in production. Well, it is not. Chaos engineering is about strengthening your system, improving the reliability of your system, so that your system becomes reliable even before going to production. So it is not breaking systems in production. Anti-fragility is going to be a fairly new concept to many of the people because it is not taken purely from the IT terms, but an equivalent thing. So chaos engineering is not similar to anti-fragility concept, meaning that we wouldn't be introducing external conditions that manipulate the behavior of the system. We are trying to tap into the weaknesses that are present inherent in the system. Okay. Chaos engineering is different from the disaster recovery drills. So this is a screen capture from one of the presentations from Adrian Cockcroft. He's the vice president of architecture in AWS. So disaster recovery is a thing of the past. Doesn't mean that you will have to stop doing disaster recovery, but today's technology focuses more on the chaos engineering, and the future is going to focus more on continuous resilience, wherein you would, on an ongoing basis, evaluate and understand and make sure that the system is resilient. And all the learnings that you have done in the past from your disaster recovery experiments, all the failovers and understanding the things about your system from chaos engineering will be used to build a continuous resilience technology. And majority of the examples that have been put up on the sites today use chaos engineering and use Kubernetes systems to demonstrate chaos. So chaos need not apply only to Kubernetes. Chaos can be used in normal systems, monolithic systems as well. Okay, chaos engineering is a discipline, like I mentioned. Its complexity should not be dictated by the tool used. There can be plenty of tools used to perform chaos, and the complexity of the tool actually should not dictate the complexity of the whole process. So it actually makes sense to use a particular tool that your SRE team or your DevOps team is familiar with. And some of the teams actually build the chaos engineering tools themselves, in-house built tools, and Okta does it. And some of the one common misconception and one common concern is that you're trying to break a system, you're trying to find the weaknesses of a system, and of course would this practice or would this whole process cost money and consume error budgets. Error budgets is again a term that is taken out from the SRE. It depends upon the SLO. 100 minus your SLO gives you error budgets, but I'm not going to go deep into that. We'll quickly touch upon the last point wherein there is a justification fact which says that chaos engineering, even if it costs money and consumes red budgets, it's going to be a mandatory thing, or it is a need of the hour. So if you're putting chaos engineering in practice and what needs to be done, okay, the sequence of steps is taken from the principles of chaos. So these are not my own sequence of steps. So every single company or every single organization that practices chaos will use these principles to actually design their chaos experiments. Okay, a chaos experiment starts with defining a steady state. Okay, and when you say steady state, it actually tells about the state of the system wherein the system doesn't have any errors or issues or failures, and it is able to take the expected or anticipated traffic without issues. So in addition to defining a steady state, if you want to actually capture details about the configuration of the system, which help in maintaining the steady state, there can be total number of instances, the CPU configuration, the virtual machines, and the cache, and so on and so forth. That is also okay. The second step is about creating a hypothesis. So the hypothesis is a statement which should pretty much, according to the standards, talk about how the a change in the system impacts the end user's experience, or how a particular change, if introduced in the system, will cause a problem in the system, or will the system be able to handle it. So it is a comparison between the control group versus the experimental group. And then we'll talk about variables that represent real world events. So since we are trying to test the ability of a system to handle the turbulent conditions, the chaotic conditions, we'll talk about variables that actually introduce that. So again, I'm going to stress on the point that I'm not introducing something externally, which is not present inside the system, but we're trying to uncover the weaknesses. So we're going to use variables that are present inside the system and then enhance the state of, or enhance the, the level of that variable, depending upon what that variable is. The variable can simply be a metric you're trying to shoot, or the variable can be the absence of a particular component altogether. So it can be anything. And at the end of the chaos experiment, you will see if the hypothesis still holds good. And if that's the case, then it confirms your design choice, saying that if your application is able to handle this particular chaos scenario, and the design decisions that you've taken are in fact good. Okay, so this is a template for conducting chaos experiments. We are going to come back and see a template that is filled with information when we get to a point where I'll demo you a particular chaos scenario. But the things that we've discussed in steps in creating a chaos experiment have been captured here. The current state, the experimentation state, the hypothesis, and the hypothesis is proven right or wrong. Another key information here is that to be able to understand the behavior of the system under chaotic conditions, it is very, very important to monitor the system. So it's critical to instrument your system in all possible ways, and make sure that the system is emitting the required matrices, logs, and traces, and then you collect it in an appropriate monitoring system. In Azure, this can be in Azure Monitor Application Insights. If you're using an open source system, then there are equivalents to it. All the captured logs and matrices should be able to give some information about the system components. Okay. Again, then after the matrices and logs, you should have alerts that actually indicate if the hypothesis is proven wrong and if the system is not behaving right, then there should be an alert to notify people. We'll talk about experiment nature later, but the blast radius, a quick or a brief information about the blast radius is that every chaos experiment, even before it starts, should talk about the blast radius of it. So when you are doing an experiment that causes chaos, what are the components that are impacted by it? So taking the generic example again, if a system contains A to A, B, and C and D. In a particular chaos experiment, if only components A and B are going to be modified, I'm going to introduce a variable that impacts A and B. Then in that case, the blast radius should be only till B. So just A and B getting affected. It shouldn't be the case wherein there is a slip over and then automatically B getting affected, and because of B, C getting affected. You shouldn't let that happen. So chaos engineering principles and best practices: start small and expand. Um, from failure injection testing with minimal impact to ones that can cause a region failover. Of course, again, all the presentations talk about chaos engineering in production, but ultimately, you will have to start doing chaos experiments in development and test environments for your team to get familiar and also to understand your system better. Wherein your dev and test environments provide you a better error budget to perform the chaos experiments rather than production. So it is not a good practice to start chaos in production. Controlled environment, we spoke about blast radius. Appropriate observability setup, we spoke about that. So make sure that your system is observable. Okay, every experiment should be documented. The template that we saw in the previous slide shows you all the necessary information for a chaos experiment. But some of the teams, some of the companies that are forerunners of chaos have been, going beyond just documenting it. Some people take videos. Slack does disaster piece theater. So you can read more about it in the same chaos engineering book about how Microsoft, Google, and Slack, they practice chaos and how do they capture it, how do they play it back and understand. Okay. So principles and best practices continued. Automate the chaos and experiments whenever possible. So the variables that get introduced in the system can be either manual, but the manual process wouldn't scale. So for that reason, for every major change that happens to your system, be it an introduction of a new component, wherein you take out one cache and then introduce another cache into the system for better performance. You take out one Azure service and then introduce another. In this case, you're disturbing the state of the system wherein the whole system's behavior can change. So in each of these major change scenarios, you will have to execute all the chaos experiments, and I've listed all the, some of the major changes that your automation pipeline should include a chaos experiment at the end of deployment. Okay, improvement cycle. With each chaos experiment, you get to understand the weakness of a system because with that scenario, you will understand the system is working fine or not. In the latter case, you can understand the weakness and how you're going to address it. So that should be used to improve the system before you go on with your next development cycle. So pitfalls to avoid: systemic weakness is treated with less priority. So I already touched upon this. Just 1 minute. So with the urgency in getting the business up and running and getting the product to production as quick as possible, the ultimate focus is going to be on the product development and the features. So systemic weaknesses usually get a lesser priority when compared to that. So that shouldn't be the case. Early detection and early addressing are what are going to help you in making the system completely reliable, rather than spending so much money in fixing a system that breaks in production. Tickets that are specific target date. So if you have a DevOps ticket or DevOps issue raised from these, those should be addressed and treated like any other bug in your system. Okay. Okay. Chaos engineering practice improves reliability and observability. So we're going to talk about how chaos engineering helps in improving reliability and observability, not just being a standalone thing. In addition to uncovering the systemic weaknesses, whatever weaknesses present in the system, how do they help in getting your system perform better? So shift left, again we spoke about this. So instead of keeping the chaos engineering for the very end, when your system is deployed and you are ready to roll out your system or your product to production, it is not the case wherein you will have to wait till that point to experiment using chaos. Shift it left to the development cycle, and with every change you will have to introduce the experiments to make sure that you are not broken anything by the addition or by the changes that you've introduced. Okay. Improvement cycle, we'll talk about it, and we talk about a quadrant that Gremlin has introduced. This is the quadrant. Okay, you can go back to Gremlin documentation and read about this quadrant, wherein any behavior of the system can be categorized into one of these quadrants. So it can be a combination of a known and an unknown, known, unknown, and things of that sort. So I'm not going to go into the depth of these, but it is a very interesting read. So I would encourage everyone to read about this. But the fact of the matter is that if you have a particular case which is in the unknown quadrant or unknown known quadrant, which means that there is a complexity in the system that you know, but you have not dealt with it, or there is a complexity in the system that you were informed after the chaos experiment. In either of these cases, you will have to address it and try to bring these to the known quadrant. So that's about the improvement cycle. Okay. Then we're going to talk about a very interesting piece of technology called FMEA. For people who have been practicing FMEA, just ride along. It's still going to be interesting because we're going to try to relate FMEA with chaos. But for people who have not heard about FMEA, this is a practice that has been in existence for so many decades. And not just IT, but people in mechanical engineering and other areas of work also use FMEA, wherein a specific output has to be measured, and the ways in which a failure can impact the quality of your work. So, framework for performing qualitative analysis of systems. Okay, so potential failures, you will have, of course, potential failures in the system. In the very first attempt, it is practically impossible to design a system that does not have any failure points or reasons for failure. So after we identify failures, we'll analyze the consequences of those failures, and then we'll assess the risks. So what is the difference between the second and third parts? Is that a failure has happened. You understand the consequence of that failure, but if the failure continues to exist in the system, then what are the risks that you foresee? Okay. The engineering team will have thought through all the reliability issues in depth and be better equipped to ensure when the failures affect the system, then how would it impact the end users? So the table that we see here is an example of an FMEA experiment. This is an extract from a very big sheet that we have prepared for a reference system. I'll be showing the reference system architecture in a while. At this point, the things that you will have to pay attention to, or you will have to get familiar with, are the column names. For any FMEA practice, you will have to start analyzing the system, and then you will have to think about all the failure points, the failure modes, and the impact or effect it has on the system. And if the impact or the effect on the system had been anticipated, then how does the system respond? What is the system's response to it? And if the system had not responded in a way that we wanted it to, or the system's response was insufficient to affect any kind of impact to the end user experience, then what is the possible remediation? Okay. So the failure point and failure modes are going to be important. Like I said, talking about the chemical equation, if A and B are going to be present in the equation, if A is one component in the system, and A can be considered a failure point, then the failure modes will tell you all the different ways in which A can fail. So A can fail in more than one way. You will have to be mindful of that, and this is an exercise that needs to be done with all the teams getting together, doing a war room session, and then identifying all the ways in which the whole system can fail with all the failure points identified. I'm going to show you a sheet later, but for now, we are quickly going to jump on the topic of how FMEA and CE are different. And when I say CE, I'm referring to chaos engineering. Since it's a bit lengthy, I'm using an abbreviated form. Okay. On one hand, FMEA is a practice which depends upon the understanding of the system that the team has. So any team that is designing the system would have a fair amount of understanding the system, because the team that designs the system would have made conscious decisions of what components should be chosen, and how the components would react, and what configuration should be used, and so on. So that's the existing knowledge of the system. Okay, but the chaos experiments are beyond that. So it doesn't stop with whatever we know about the system already. It extends to the fact that chaos engineering helps you in understanding the weaknesses that are present in the system, but you did not know about it. So using the chaos experiment template that we talked about, the hypothesis statements, the chaos engineering hypothesis statements can be made from the FMEA scenarios. But in some other cases, one chaos experiment scenario that is taken out of the FMEA, if implemented in real time in your cloud system, can result in more than one observation. So the effect and impact column that you saw in the previous table can be more than one. In that case, it very quickly concludes the fact that FMEA is not sufficient because FMEA captures the data that the person or the team that does the FMEA practice know about the system. Okay, we'll see an example about that. Another information is that every disproven hypothesis is a new learning. Okay, so if your system fails, it is actually a very good thing. If your system fails, you know something about the system which you had not known already. In this case, it's an opportunity for you to address that particular issue with respect to reliability and then improve the resiliency of the system. Okay. If okay, an FMEA has been practiced by Microsoft. So if you think that FMEA is a one-off practice, I mean you're wrong. FMEA is practiced by Microsoft and the teams inside Microsoft as well. In this case, if you're extending FMEA using chaos engineering and you get to discover more things, then there should be a feedback loop. So any failed hypothesis statement can be taken back to your FMEA sheet and that can be added either as a failure mode to an already known failure point, or it can be added as a new failure point itself. So I've given an example. You can when you go through the deck, you can read about it. This particular example talks about the case wherein the hypothesis, the technical version, talks about what the system should do or how the system should behave when a chaos is introduced. The unanticipated behavior statement talks about what has happened when the chaos is introduced in the system. If you recollect the point wherein I was talking about the blast radius, I was talking about component B getting affected and component C shouldn't. But in the real case, if it is not a chaos experiment, when A and B are affected, and because of that, if C is also affected, when the component that relies on B also gets affected, then that is not going to be an anticipated behavior unless you actually face that scenario. Chaos experiment helps you in understanding these kind of scenarios. Okay, with the empty template provided in the previous thing, we're going to talk about a scenario. Okay, and the environment setup has got Gremlin. You can use any kind of tool to perform chaos. Like I mentioned, the tool shouldn't dictate the complexity of the process. And if you are a person who believes in open source and you want to use any open source, there are plenty of tools in the open source world as well. But the environment setup now has got a Gremlin tool that does a black hole of all the traffic from my web service to my SQL always on availability group. Okay, the system steady state. So what is like I said, the configuration of the system when or before the chaos is introduced in the system. The system has no dependency failures, but the total number of requests is less than 1 million an hour. So this can be extended with additional information about the configuration of the components, but maybe appendix or supplement to the sheet. But you might want to keep information in every experiment to whatever is actually required, strictly to what is required. And then the chaos hypothesis says that when the application loses connection to the backend DB, it would still be able to serve the customer read request at the least. So according to the principles, the hypothesis statement should be worded in such a way that it talks about the end user's experience when a chaos is introduced. But you can go ahead and improve it or extend it with some additional technical information as well. So that is what I have marked with a couple of stars. So you can either have it or remove it. Depends on the maturity of your team. So when a network partition happens between the web service and the database cluster, this is quite common in cloud. So the web service is working fine and the database cluster is also working fine. As such, these components in the cloud do not have any health issues. But the network that is connecting them, for whatever reason it is, breaks. Then how should the application behave? Should the application continue to serve the read request, or should the application show a degraded message to the user? So the components of the experiment and the blast radius are going to be same. So the components in the experiment are VM scale set and always on availability group, and that is going to be the same thing as a blast radius. Okay, system state of the experimentation group. Okay, this needs to be filled after the experiment is run. So experimentation says that the application should be able to handle the remaining, even if the database connection drops. System should be able to handle the read request using a connection to the cache. But in this case, I've taken an example wherein the hypothesis is proven wrong, and you have a learning to go back and implement. Application fails because of failure of the fallback mechanism, and the network partition wasn't transient. So this can be perceived in a way that either the cache wasn't available at the time, or the cache was also impacted. The network partition wasn't transient as well, meaning the network partition created a drop in the connection between the web server and the database cluster, but the drop in the connection persisted in the system beyond a point wherein the web server would retry. If the web server was coded to retry for say, um, 1 minute, and if the network partition exists beyond that, then that is where we say that the partition wasn't transient. So if the hypothesis is proven right, then you would say you have a proof of system resiliency, and what design choice helped you in achieving that. Duration of experiment and termination condition is important. So if there is a scenario that you're running in production and it is causing some unforeseen behavior, and you do not want to bring the entire system down just for running chaos experiments, because you might be running on a very low chaos budget. The error budget, which means that if your system uptime is going to be 99.9%, then you have just 0.1% error budget to conduct your chaos experiments. So if you see that the experiment is causing issues in your system that you had not anticipated, and there is a potential possibility of shooting beyond the error budget, then you will have to manually stop the chaos experiment. So we'll quickly jump on to the demo. So before jumping on to the demo, I'm going to show you information about, I'm going to explain the reference system architecture. So if you attended my previous session at 1 p.m., we use the same thing. So this is an entire highly available system. I've just expanded it using additional information, and this is a reference architecture available from Microsoft's reference architecture library. We got n number of components, and all these components are in the critical line of path, flow. The design decisions would make sure that none of these components are single points of failure. That is a different discussion. It's going to be about how you make sure that the individual component is not a single point of failure. I'm not going to go into the depth of all these things, but one quick example is going to be where the application gateway needs to be designed in a standards queue with auto scaling enabled to handle more traffic. Otherwise, there's just one example, and there are other ways to make it more resilient by distributing the instances among the availability zones as shown in this architecture. With all these components in place, this particular scenario has all the observability setup done. I've instrumented my web application with connection to application insights, so it is going to pump data to it, and all the infrastructure resources and the the Azure components, be it application gateway or load balancer, and then the remaining things have been enabled for diagnostic settings, so that they send their diagnostic logs to Azure Monitor. Okay, so the application that I've deployed in the web server is a sample application that you can download from Azure's GitHub repo. This is called e-commerce on eShop and web, and there is an equivalent for containers as well. That is called eShop and containers. So if you want to practice this whole thing on a Kubernetes cluster, wherein you want to understand how chaos experiments can be run in a microservices architecture using containers, then that application would be more applicable. So this is running on a virtual machine using the same architecture that I showed you. I've just simplified a few things for now. Okay, so like I mentioned, the observability work has been done. I've set up Microsoft monitoring agent on the virtual machines, and also the log analytics agent. I one of those two, and then the application insights in the web application. Okay, and then the other requirement, as I showed you in the chaos experiment template, is to have an alert that can tell you what should happen when a chaos experiment is completed and it creates an alert, which means that the system did not work in a way that you wanted it to, or the hypothesis actually proved wrong. It is going to be a fairly decent practice or an acceptable practice to create an alert for severity 2 or severity 1 kind of alerts. So creating an alert for severity 4, where it is just informational, that is not going to be necessary. Otherwise, you would be receiving alerts for every single experiment that you run. That is actually not required. So quickly going into the configuration, not taking much time. Just for the sake of the experiment, what I've done is that the dependency of the virtual machine according to the previous architecture is the SQL server. So in this case, the alert also is configured based upon that condition. So any dependency failure, if it is more than 0 in this time span, just go ahead and create an alert. And what action group you need to configure to process that alert. It can be simply an email or an Azure function to handle the remediation steps. Okay, so that said, I'll be using the Gremlin tool to run it. Okay, for people who are new to chaos and who haven't practiced chaos or new to Gremlin, Gremlin provides you a free tier. So you can go ahead and try out Gremlin with whatever system that is running on cloud with a limited set of features, of course. Then you can decide to either switch to an open source tool or any other SKU. But for now, the process here is that Gremlin would give you an MSI. You can go ahead and install that MSI in the virtual machine. So in this case, I've gone ahead and installed the Gremlin MSI in my virtual machine. So which pretty much tells that this is one of the several hosts that are under the control plane of Gremlin. So when we want to initiate an attack, we know that this is going to be one of the several hosts which can be attacked. So the control plane of Gremlin makes a connection to this agent through the setup. So once the agent has been installed, you will have to do an initialization process. This is going to be fairly simple. You will have to feed in your team ID and your secret, after which the host would show up in the Gremlin's dashboard. Okay. With that said, Gremlin provides you an option to do multiple kinds of chaos. So the resource chaos, state, network, and so on. In this case, we're going to talk about only the black hole experiment, which is equivalent to creating a network partition. Okay, so the length of the chaos is going to be for say 90 seconds. I'm going to read an existing one, so not to type the IP addresses. So this is the IP address of the machine, the SQL server, and of course I'm blocking all the traffic targeted on port 1433. Okay. If you take a deeper look, you will be able to make, or you will be able to correlate with all the necessities of an experiment template of what is a blast radius and when you need to stop, and do you need a facility to manually stop the thing. So halt all attacks and halt an attack if you want to halt an attack before it completes. Okay, I didn't expect this. Okay, now that the experiment is running, it is going to be quite straightforward to perform the operations that you need to. Since my web application has lost the connection to SQL server, then I'll not be able to perform or complete any of the transactions. Since it's an application that I used directly from the GitHub repo, did not modify any piece of it. I did not code it to handle the retries or the duration of time that the request should fail before being marked as a failed request. So this simulates the case wherein your system or your website has lost connection to the SQL DB, but your users, end user experience is also impacted. And at the end of the experiment, we would look at the application insights to see how the information is captured. Okay. So it would take some time because when application insights, even if it is running on the virtual machine, does some kind of sampling, and also there is an initial aggregation time or percentage, so that it will aggregate the logs from the virtual machine before pushing it to the application insights dashboard. I mean the collection log collection store and the dashboard. So okay, now the experiment is done. It will take some time for us to actually see it here. But this pretty much explains the concept wherein you have a network partition between two components, the web server and the SQL server. And that network partition could happen in real time, but in this case, we've introduced a network partition using a chaos engineering tool and an appropriate experiment that imitates a network partition. So if in this case, the system had been designed in a way that uh, at least the read requests should be handled by your caching. So in that case, your system should be able to handle the read request from the caches. So if your system had not been designed to handle the customer read request beyond the failure of the SQL DB, then at least show a degraded message of some sort. Okay. Okay, let's come back to it. In the meantime, let me quickly go ahead and explain the other scenario. So the other part is where we talk about application level chaos. The previous experiment was about introducing chaos at the infrastructure level, the network partition. So if you want to understand my system is going to behave, how my system is going to behave if an application level issue is experienced. So in that case, you need to be having a facility to do chaos experiments within your application. So one tool that comes in handy, I'm going to give a reference to that tool. It is called SIMI. Okay, so it is an extension to the Poly library. So people who have been coding ASP.NET applications using Poly to handle the retry and the circuit breaker conditions along with your calls to the external systems, be it your database, a cache, or any other system for that matter. If you want your application to stop at a particular number of retries, or there needs to be a circuit breaker so not to overwhelm the system that is not reacting already. In these scenarios, you would be using Poly. So this particular library gives an option to extend your Poly framework using a chaos chaos facility. So this is totally from the Poly framework, I mean the Poly library. You can create a number of execution policies, timeout policy, circuit breaker policy, and so on. But in this case, we are focused more, or we are interested only on the chaos policy. Okay, and it is called a monkey policy because it has been named after the chaos monkey. It was invented by Netflix. So if you want to read more about it, there are multiple articles talking about it. So in this case, you are injecting a chaos, injecting exception, and the injected exception says that the Cosmos DB is not going to respond. The Cosmos DB says that it is unavailable, the 500 error. And the injection rate says that every single call, 100% of the time, is going to fault. So if in this case, this kind of a chaos policy is used, and then you try to create a connection to your Cosmos DB from your application. In this case, you've taken the example of a Cosmos DB. Excuse me. All the outbound calls from your web application to the Cosmos DB would ultimately fail. Okay. Okay, so this is a code. The whatever code that I'm showing you is from a caching strategy solution that I've written. It is available in my repo. I'll make sure that it is public at this point. But out of the so many strategies possible, this is a write-through strategy that we're talking about. Not going into the details of it, but still relating to how to make the system reliable. So if the Cosmos update fails, will you be able to commit the Redis transaction at least? I mean, write to Redis. Or if the Cosmos update fails, then the write to Redis also fails. The read scenario is also going to be similar, wherein read from Cosmos fails, will an automatic fallback happen to read the data from Redis. Okay. So if you want to try it, go ahead and use the Simi library. Try to integrate Poly into your code. Poly blends well with any kind of system that uses Azure services. And then you will have to use a monkey policy and then inject exceptions with it. You can play around. This is not the only thing. The HTTP response procedure, the 500 is not the only scenario that you can possibly do. There are plenty of things that the Simi library lets you do. It also gives you an ability to introduce latency into the system. If you are building a system that cannot tolerate latency, the end user's experience would be affected if the system's calls are going to take a longer time. Something like a share market information. So in that case, you can introduce some latency into the system using the monkey policy to see how the system is behaving. So should the system take an alternate route, or should the system degrade that feature and then show a message to the user? Depends on your design. Okay. So I've shared or I've referenced this library in the last part of the deck. Okay. And the third scenario that I want to talk about, it's more of a conceptual thing. I did not prepare due to constraints in time. So the first experiment talked about a virtual machine handling the chaos, and the second was about an application wherein we were able to introduce chaos using a library. But there, of course, would be a question wherein there can be components, the platform as services which Azure manages. You cannot install a Gremlin agent or any other open source chaos tool into these systems, be it a storage account or Cosmos DB or your load balancer. So if that's the case, then how do you handle the problems? So there are two things that you need to take care of. Azure gives a way to subscribe to these kind of failures. The service global failures and regional failures, you will have to subscribe to those. If you had not watched my previous session at 1 p.m., the health model, that actually proposes a solution wherein you will be processing the alerts that Azure provides you. So in that case, you would be notified when something happens in the Azure managed services, be it Active Directory or Azure storage accounts or Cosmos DB. The one possible scenario that I've mentioned here is that when a storage account goes down in East West 2 and you have your storage accounts deployed in East West 2, and the storage account as a service is unavailable in East West 2 on the whole, then you can process those alerts using the architecture that we have proposed. And then if it is not a transient case, then you can create a condition of a storage account failover. So this can be a function app that runs a PowerShell script, and that PowerShell script can do a storage account failover. And you should be mindful of the fact that you should have designed your storage account to be globally redundant, GRS or RAGRS. So this remediation step can ultimately do the switchover or failover to the other region. So this is how you react to the failures. But there is one other way which I haven't really tried, but there is one thing that is possible. Any outbound calls from your application, the application makes to the storage account. If it is making to the storage account's fully qualified domain name. If it is from a virtual machine, then there are ways to do DNS failures from Gremlin, and there should be equivalent mechanisms in other tools as well. So any outbound calls to Azure DNS, the 168.IP, if you're able to fail all those calls, which means that we'll not be able to do a domain name resolution of any of the Azure services or a selected set of services. If you introduce that kind of a fault, then how would your system react? Would your system wait for that storage account to recover, or would you do a storage account failover and automatically your application would be coded in such a way that you read from the secondary storage account, which is now the primary one, and so on. So I'll leave that to the creativity of the adopters. We've got very less time, so I'm going to quickly rush through the last slide, which is really important. So, what advancements have been made in the Microsoft world? So, if you are a multi-cloud person, which I am not, but ultimately I came across one service at Microsoft, AWS has introduced called fault injection testing tool. I might be wrong completely. Microsoft is working to create a tool that can help the customers perform chaos experiments. So that's going to be an Azure native tool. So this is from one of their blog posts dated July 27, 2020. I was not able to follow along and see if any more improvements have been made in the space, but you can subscribe to Microsoft's reliability RSS feeds, and you should be notified of any improvement in the space. But till that point, you can go ahead and use all the open source tools. This slide gives you information about all the books, the chaos is a culture, the forums that you can participate, the podcasts and seminars you can listen to, the blogs and newsletters, and so on. So I've referenced all those. Yeah, the book, the chaos engineering resources. Awesome chaos engineering is one library or one repository in GitHub that has got links to everything that I mentioned in the previous slide. Then we talked about FMEA. Microsoft has got a white paper that talks about how to practice FMEA. Modified version of it is called Resiliency Modeling Analysis, or RMA. And if you want to practice RMA like Microsoft does, but for your distributed systems in the cloud, even before going to chaos, then this white paper can help you get started. This can be a very good starter of understanding the failure modes and failure points, and how to picture that in an architecture diagram. Okay, so it shows just one failure. Maybe I think it's quite slow, but this is how you will have to configure the monitoring to capture all the dependency failures, and then of course handle the remediation point of it. So it clearly says that the SQL database has failed, and the connection to SQL database has failed. Okay, so that was my presentation. Thank you to all the sponsors, Microsoft, EY, and Elastic, and the learning partners in the communities for spreading love. Thank you.
Yeah. Thank you, Sriram, for that great session. So we have a couple more questions from our attendees. So I put that here. So basically, what he's asking for, can you say more about the difference between experimentation and validation? Chaos engineering is often compared to system resilience testing, platform testing, disaster recovery test. And I can't see the real difference there, as tools like Litmus are used as quality gates for the release. So it is still validation of deployed services in practice.
Okay, I'm not sure if you can answer every piece of that question, because there are multiple questions within one question. So I can take it offline with the person who has posted that question. But maybe from my experience, Litmus Chaos or Gremlin or whatever for that matter, chaos engineering is a term that is used to improve, understand the weakness of the system. Again, I'm repeating whatever I've told already. Since the chaos experiments help you in understanding the resiliency of the system, that is one of the reasons why people talk about resiliency testing. But if you listen to Adrian Cockcroft's sessions, they talk about chaos engineering used for security testing also. So if you are in the security world, if you've been practicing the red teaming or tabletop testing, which pretty much try to find the security weaknesses in your system by tapping into specific scenarios, then that is categorized as chaos as well. So if you want to perform experiments that can bring out the security weaknesses, then that is one case as well. So verification versus validation, experimentation versus testing. I might have to take that offline and then answer the question. It will take no longer than a minute to answer that.
Oh, no problem, Srina. So that's all with the questions. It was wonderful having you here in the second edition of Azure Community Conference. and nice talking to you. Hope
Thank you,
you
Amal.
will be back again next year.
Of course.
All right. So we are right on time. And thanks again, Sriram. So
Thank you.
now we have our next speaker online. Her name is Purnima, and she's going to take you through how you can use Azure Static Web Apps and what all the features and all other configuration things, and how you can deploy front and full stack apps into Azure using this offering. Purnima, all yours.
Thank you, Amal. Okay, yeah, there we go. Hello, thank you for having me as a speaker at the Azure Community Conference 2021. Really pleased and excited to be a part of the conference. And thank you all for attending my session as well. So today I'm going to be talking about Azure Static Web Apps, which is one of the hosting options from Azure. A little bit about myself. Before we start off, I'm Purnima Nair, and I'm joining you from Berkshire in UK. I'm a freelance .NET developer. I'm a Microsoft MVP for developer technologies, and I do a lot of work with Umbraco CMS, which is a .NET-based open source CMS, and I've been their MVP for the past 3 years. Known work me, I am a mother to a 7-year-old girl. I spend a lot of time reading, mainly fiction, and I'm also a student of Carnatic music. And those who don't know what Carnatic music is, it is a stream of Indian classical music prevalent towards the south of India. Before we start off with Azure Static Web Apps, let's talk about modern web app development. And what are the patterns in modern web app development? So these days, what we come across a lot is static frontends and serverless APIs, which are then used to communicate or heavy lift what is happening behind the scenes. Another pattern is static site generators like ViewPress or Hugo or Gatsby.js. And to add more flavor to all this, we have powerful browsers, which can do a lot of heavy lifting than they could do before. To the extent that we have .NET on the browser with Blazor WebAssembly. So it's a really exciting time as far as web developers are concerned. Now, if we consider a traditional ASP.NET MVC app, it is doing two different things at one time. It's acting as a file server, rendering static content, and it's also having an API behind the scenes, which does a lot of heavy lifting. And Azure Static Web Apps says, hey, hold on, let us rethink this. There is an API and there is static content. Let us rethink, let us kind of split the effort here and see what we can do about it. And that's exactly what Static Web Apps does. It's a hosting option for full stack apps. What it is a turnkey service which has two parts, a static frontend and an optional serverless API backend. So there are two different things which forms the part of the same package. So the first one is the app, which is your static frontend. And you can have an API, which is totally optional. But regardless of what API you have or not, it should be powered by an Azure function. So that's all part of the same app for you. And what we get is a clear separation of concerns with the fact that you have your API, which does the heavy lifting, and it is scalable on demand. And we have static assets powered or served from a static front-end app, which is distributed globally using a CDN. So each part of the package is optimized for what it should be ideally doing. And what are the ideal candidates for static web apps? Any technology which doesn't have server-side rendering, like Blazor WebAssembly, Angular, Vue, React, the JavaScript libraries, and any static site generators, they all are really good candidates for static web apps. And static web apps was, I think, announced last year as a public preview at Build and then went into general availability earlier this year in May. Now, you would be thinking, why Azure Static Web Apps? What are the advantages? Why can't I use, say, something like Azure Storage for serving my files up? Well, what we get is first-class GitHub and Azure DevOps integrations. We get globally distributed static content, which means that there is a CDN in place. You don't have to worry about having a CDN installed. It's all done for you. And this also means that you get optimal performance for your app, given that every user, when they browse through the app, gets served from a point closer to the user. You also get free SSL certificates and the ability to have custom domains, that's including Apex domains. And towards the more heavy lifting part of things, you have managed authentication provider integrations. You can have customizable authorization role definitions. You can have routing rules, and we have integrated API support, all of which we will cover through in a bit more detail throughout my talk. Now, what Azure Static Web App is for developers. I'm a developer, so I like to have a look at what it can offer for me as well. So Microsoft sees Azure Static Web Apps as a complete solution, not just for hosting, but it also starts like end to end from all the way from your local development environment to the hosting environment. And what developers get is a workflow tailored to their daily workflow. In simple terms, you check in code and the platform deploys it for you. Let's see how. So at this point of time, the integrations are quite opinionated. Azure Static Web Apps considers or wants you to have the repo on GitHub or Azure DevOps. So when a Azure Static Web App resource is created, it kind of it has to be tied up with a repo, and it monitors a repo branch of your choice. Say, for example, main. Whenever I make a change to the main repo, push my changes in, it spins up an Azure, it spins up an GitHub Actions deploy or Azure DevOps pipelines and deploys it all the way to the environment that is in the portal, to the cloud. And both the static content as well as the API, which is the part of the package, gets deployed. So that's to your live environment. If you have a pull request opened against the branch it monitors, it then triggers a deploy and creates a staging environment for you. And when you close that pull request, it deploys again to the production environment. But what it also does is it takes care of the staging environment and retires it for you as well. So there is constant management of the environment that is also done for you by this workflow, which is quite neat, I would say. So what you get is staging environments, as I said. And if you're thinking about the build process that's needed to happen before everything can get into your environment, like Node.js or Angular, Vue, React, the front-end asset building, that's all taken care of you as well. There's a long list of frameworks and libraries and static site generators that are supported by Azure Static Web Apps. And that includes Blazor WebAssembly, which I'll be basing my demo on today. So this is a hosting option. So we need to talk about hosting plans. We have a free plan, which is ideal for personal or hobby projects. And we have a standard plan, which is aimed at production apps. While most of the things that we get are free, are available on the free plan as well, there are subtle differences, and we need to go through that. We have a bigger app size in the production plan. I think it's 500 MB versus 250 MB on the free plan. We get more staging environments on the production plan, that is 10 versus 3 again. With the free plan, you can only have the Azure function, that is the part of the package. But with the production plan, you have the ability to bring in your own Azure function. So if you are thinking that, hey, the app, the checking in of code and deploying it into production, which includes both the API and Azure function, is quite risky for you, then you can always think of the production plan and manage the Azure function deployment from yourself. So at that point, deploying the Azure function becomes your own responsibility, and all the code checking does is deploys your front-end code, that is the app for you. Again, if you want custom authentication providers like Google or Apple or any other third-party authentication provider, you need to stick to the production plan. Now, what are the tools available for us to help us get started with Azure Static Web Apps? First of all, we have GitHub starter templates. So these are template repos on GitHub, which proves the starting point for a variety of front-end builds like Blazor, Angular, Vue, and so on. So I've got a little sneak peek of what it is over here. So if you go to static web dev on GitHub, you get a lot of repositories. So there is a lot of starter repositories for a wide variety of front-end frameworks. And there's also this repo called Awesome Azure Static Web Apps, which is a fantastic list of resources that you can use as well to improve your knowledge. Next, we have a Visual Studio Code extension for Azure Static Web Apps. This is in preview. And what you can do with this is create and manage a static web app all the way from local to production using VS Code. So, and the third one at the moment is Azure Static Web Apps CLI tool. It is termed as the complete local development tool, and it helps you emulate the cloud environment locally so that you can test your authentication, authorization, routing redirects, etc. At the heart of this tool is a reverse proxy. And what this reverse proxy does is it routes the request to the appropriate part of the app. Sorry, I jumped a slide there. So there are three parts to the static web app. There is the static content server, then you have the authentication and authorization emulator, and the functions core runtime. So your app listens on port 4280, and whenever request comes in, depending upon the path of the request, it routes it to the correct part of the app. So if the request comes on /.auth, that this is the tool understands, the reverse proxy understands that it needs to be forwarded to the auth emulator server, and that's where it gets forwarded to. Anything that comes in on /API, it's forwarded to the local API function, and any other request is served from the static asset server. So let's have a quick demo of all this. First, let us start off with the static web app VS Code extension and try and deploy all the way up to a cloud environment. So the way to start it is you go into the template repo of your choice. I'm choosing Blazor as the starter. And then from the template repo here, use this template to start a repo. So my repository name, let's term it azconf demo. I'm going to keep this private because at one point it'll add certain tokens for me and I don't want it to be public anymore. So let's create this repository, and I have this now in my GitHub account. So that's all spinned up. Now let's check it out. Has it not refreshed for me? My repo, sorry, azconf. Okay, I see what I'm doing wrong. I don't know why it is not recognizing it. Okay, let me quickly check it out using Git-Kraken then. There we go. Clone the repo. I'm going to open this folder now. Okay, so this is what the repo looks like. There's an API folder which contains my Azure static, the Azure function. The client folder is the static app, the front-end app. And there are a few things that we need to go through here. In the API, there's a local settings example JSON, and it's got a few core settings. And I need to make sure that the course is enabled for my Azure function. So I need to rename it to local settings JSON. And that's all documented here in the template repo itself for you. And my client app is a Blazor WebAssembly-based app, .NET 5-based, and it has got a static web app config JSON, which is about the configuration, which we'll see later. It's got a few pages. It's got a few shared components. And in my API folder, I've got the weather forecast function. And this API is .NET Core 3.1 based. So I've got the extension installed, the Azure Static Web App extension. What I can do is I can create a static web app here. I need to commit it quickly. I'm going to stick with the commit message. So now it has started the work for me. So I'm going to create a static web app called AZConf demo. I'm going to base it on West Europe. So now it is asking me to choose my build preset. So this is where it understands which or what process it needs to take to form the front-end assets for me. And I'm choosing Blazor. Now it is asking me for the folder which contains my front-end app. In this case, it's the client folder. It's now asking me, saying, where is your front-end assets? With Blazor, it is all in www root, which is what I'm sticking to now. And it has started creating a static web app AZConf demo. As you can see, it is done a git pull as well. I'll explain why. If I go into my repo now and refresh, what I can see is it has added in an action for me. It's a GitHub action. This is quite an important file, and this is done by the platform for you. It has got two jobs, the build and deploy job, which deploys it all the way, and something which runs on the close pull request job. And the branch it monitors is the main, and it also does a bit of work when any pull request is opened, synchronized, reopened, or closed. And it also has a few little configurations which are important. There's the app location, which is the location of the front-end app. In this case, it's client. There's also the API location, which is the API. And the output location is where my front-end assets reside. With Blazor, it is www root. So that is the action. So it must be working, and it must be deploying the resource for me. And once it deploys the resource, it also deploys the code for me. But I can have a look at it from here. It's already saying main waiting for deployment. So if I go into the site, it should be still working towards it for me. And as you can see, it just gives me a funny name in itself. So let's have a look at the Azure portal while we wait for it and see what is in the blades. So that is the Azure Static Web App resource in my portal. As you can see, there's a URL, and it also says which branch it is monitoring from here, which is the source. If you have any configuration, that is for your function. If you have a database connection, you can manage it from here. You can enable application insights for your logs. You can have custom domains if you want. This is where the function is. There's only one function, and there's not much I can do with it because it's a standard, it's a free app that I'm using. Now, this is quite an interesting screen because it tells me what my production environment and what my staging environments is. I don't have a staging environment at the moment, so there are no staging environments. This is for role management, so you can invite users, more on that later. And this tells me what my hosting plan is currently mine is free, and the next level is standard, and there is a few differences which is described as well here. So I don't think the deployment is complete yet, but that's okay. Let's have a look at the static web app CLI tool and try and run this locally while we wait for the deployment. So let me start a terminal. So static web app CLI tool, it's a bunch of command lines, commands that you get. So what you can do is you can run your app, your function, as well as your authorization emulator, all at the same time using a single command. And then you can test your environment locally before you deploy it, because testing is always important. I'm just going to take you through it very briefly, but if you go into the GitHub repo behind the scenes, that is the static web app CLI, you have all the documentation that you need to get you started, and that's in pretty detail as well. So let's see whether I can get this running. So the command is SWA start, and Blazor runs on port 5000, so HTTP localhost 5000. And then I need to specify my app location using this command. Note that I'm working from the root of my repo. The app location is the client folder. Now for the API location, it is API. And then I can say run. And then I need to build my front end because it's Blazor based. So I can say .NET Watch run. And this should run everything for me. That's my Azure function, my front-end app, everything. You can, by all means, do everything that you need by running it separately, but then the test will not be proper. Let me see whether that's picked it up. I think the build failed for some reason. Did it? Oh, I made a typo. There we go. So if you go through the logs here, it is building my Blazor app. It is building my API. It is starting my Blazor app. And it is also starting my function local tool. And finally, the Azure Statics emulator has started at HTTP localhost 4280. That is the port for the emulator. So if I follow the link, it should work for me. Now let us see what the difference is between the emulator version and the non-emulator version. It should all work, but with the emulated version, you can actually see where it is all coming from. So if I go into the network tab, if I go into the weather forecast, you can actually see whether this is where this is coming from. It's quite subtle on my local environment because I don't have much options here, but when it actually gets to the live environment, you can see where I'm coming from. Because the /API, where the API resides, CORS no longer becomes a problem when it gets to the live environment, because the /API acts as a reverse proxy, and you get served your API from the same domain as your static web app. So let's go and see whether my static web apps have now deployed. Cool. I think that's deployed. So if I go into fetch data, the weather forecast, now you can see that instead of a separate domain, it is getting served from the same domain. So you don't have to worry about CORS when you get to the environment. And the path is fixed to API weather forecast. So that is a little bit of demo for you. Let's move on and talk about further things. Let's talk about the integrated API support that we have. APIs are completely optional with Azure Static Web Apps. So you can have a front end calling into a completely third-party API, which is of interest to me because I do a lot of work with Umbraco CMS, and Umbraco has a headless option as well, which means I can create a Blazor or Angular or a ViewPress-based app which seeks content from the headless CMS APIs. So you can have two configurations of API: managed, which is what we just saw, where the app and the API gets deployed as a part of your same package, or you can bring your own with your production app. With bring your own, you have much more options and flexibility. And the API route, which is fixed to /API, which is always served from the same origin, that's available for you even with your bring your own. So if you bring your own function, even there, the function will listen on /API/ the function name. So that's all taken care of for you. And as much as the app has access to the user authentication and the role-based authorization data, APIs have information about it as well. But there are certain catches when it comes to Azure Static Web Apps and the functions the API support. It's necessary to go to that. With managed functions, we get only Node.js 12, .NET Core 3.1, or Python 3.8 runtimes. If you have logs, if you want logs, they are available only if you add application insights. Sorry. You can secure the API using the routing rules. And regarding managed functions, they only support HTTP trigger. So these are all the catches with Azure Functions in Azure Static Web Apps. Most importantly, if you want a .NET 5 based Azure function, then you need to bring your own and you need to stick to a production app. We also need to talk about application configuration, and application configuration is managed using a JSON file called staticwebapp.config JSON file. It was previously called routes.json when the SWA platform was announced as public preview, but it's been renamed to static web app config JSON because the file is much more than just routes. And this file must be in the folder or subfolders of the app folder. So if you look at my repo here, you can find the static web app config JSON in the client folder at the root. That adds maximum visibility, I think, but it can be in its subfolders as well. What this file helps you control is routing, fallback rules, and a lot more. It's a very powerful file for what it can do. And this file also has a bit of overlap alongside the routing and the authentication and authorization. Now, for some examples of what you can do with this file, you can have redirects. So in my case, my counter is redirecting to /counter. You can have rewrites. You can have response headers. So you can have a header added to a particular route, or you can have a header added to the entire app or globally. You can also have navigation fallback. This is particularly important in terms of framework like Blazor, where you also have a client-side router. So every request that comes into Blazor is handled via a client-side router. And that client-side router resides in the index.html file in the www root. So if I go here, index.html, it has got an app component, and inside the app component, which is here, is the router. So it's important for Blazor to understand, for any Blazor app to have all the requests hitting index.html. And from there on, the client router takes care of routing your request to the correct place in the app. If this is not enabled, if the navigation fallback is not enabled in static web app JSON, what it tries to do is it tries to serve up a static file of the same name. So if you have a /fetch data, it'll try and kind of serve you as something of fetch data, something with the name of fetch data. So this navigation fallback helps you prevent that and make sure that the client-side router is what is getting targeted. You can exclude paths as well from navigation fallback, like images and CSS. You can also have response overrides. You can have allowed IP ranges as well, so that you can secure down your app as well, especially when it comes to staging environments. Talking about security, you have access to a series of pre-configured providers like Azure AD, GitHub, and Twitter. And once logged in, users belong to the role authenticated. By default, they are all anonymous. You can create custom roles if needed, and that's all done from the portal itself. So if you go to role management and click on invite, I can choose my authentication provider. I can put a name in for my role as well. At this point of time, if you look at the authentication providers, there are just few, and that's for the free app. If you want to bring in your own custom authentication provider, that's only available for the standard plan. And all the authentication providers that you choose to bring in should have OpenID Connect support as well. Authorized rules, all users gain access to the restricted routes, and that's again controlled by static web app config JSON. So if I have a quick example of that, what you can do is routes, and then you can tie down your route that is example using allowed roles. And you can put in, say, admin. So if you have an admin role in your app, only the admin would be able to access the route/example. And all the authorization related APIs resides in the system folder /.auth. Now, where do you have the information about the user? That's in client principal data. And to get that information, you can make a GET request to /auth/me, which gives you information about the current logged in user in the app. And if you want that information in the API as well, you can use a request header called XMS client principal, which gives you the current logged in user information. So that's getting started about the Azure Static Web Apps. Now let's start a little bit of a detour and apply some of the learnings from here to our next section of the talk, which is how we can now extend that API that we just saw into a GraphQL API and deploy that. Now, what is GraphQL? It is a query language for APIs, which is supported by a runtime for fulfilling those queries. So GraphQL is a query language, and it acts on your existing data, which could be a database, a REST API, or even a GraphQL API. In its simplest terms, what GraphQL is all about is specifying types and asking for information of fields on those types. So there are types and there are fields with GraphQL, and you ask for fields on types. That is GraphQL is all about. GraphQL is about exact fetching as well, which is the very reason it came into existence in 2012, 2013, with Facebook introducing us to the world of GraphQL. And what you get with GraphQL is a query. What you can do is write a query, which is JSON-ish, and what you get back is JSON data. But the most important thing is the query that I write and the data that I get back, the JSON, are mirror images. So as a developer, I'm in control of what I want to ask for, and I know what the shape of the data is going to be like as well. This is what GraphQL is all about. Taking the query, parsing it, executing it, and giving the data that you want, the shape that you asked for. Some of the features of GraphQL, it's strongly typed. It is something called a schema at the heart of it, which is strongly typed. GraphQL is a specification. So it's not exactly an implementation. It's a contract or a blueprint, which is kind of confirmed to by the various implementations across various different programming languages. So any programming language that you take, it might have an implementation of GraphQL. And using the implementation, we create the APIs. GraphQL has this wonderful feature called introspection. Using which it can query itself, which means that it is given rise to many testing tools and self-documenting tools, which means your API will never be out of date as far as the API documentation is concerned, which is a fantastic feature in itself. With GraphQL, it is hierarchical because what it tries to do is it visualizes your data, your objects as a a graph, and it helps you extract parts of the graph. And if you have hierarchy in your data, GraphQL respects that hierarchy. What you get back from GraphQL is a JSON response that mirrors the query, and it is an application layer. It has got nothing to do with where your data resides. As I said, it can be a GraphQL API in itself. So one of the most common use cases of GraphQL APIs is you have multiple APIs and you want to pool the data using a single kind of gateway, and that's one of the most common use cases of GraphQL, aggregating data from multiple sources. It can be any database, it can be even a REST API, but GraphQL is an application layer which kind of peeks on your data and then works with it. GraphQL is version free, so we have no nightmares that comes with REST versioning. Because the client is in control of what it needs to ask, till a field is kind of completely gotten rid of by the API developer, and that at that point is when the versioning or the the relationship between the client and the API breaks. But as far as an API is concerned, and if you add a field, as long as the client is not using it, that field is kind of non-existent for the client. So which means that the client and the API can kind of build and iterate and develop at their own paces. So it's loose coupling. It's pure loose coupling that we are aiming for with GraphQL. And finally, transport layer agnostic. GraphQL over HTTP is the most common way of using GraphQL, but GraphQL is transport layer agnostic. It's important to talk about GraphQL schema when we talk about GraphQL, because any implementation of GraphQL that is out there helps you implement a schema. A schema is made up of object types, which is a representation of your objects. So today, my API is based on books and authors. It's a very simple API. And so if you consider your book object, it might have an ID, it might have a title. Every book might have an author. So that makes up an object type. And in my case, the author is an object in itself. So the author field in my object type, that is book, might be a complex field as well. So you can build up relationship between your objects. The next one is queries, which is operation type, and that's the root operation type for reading data in GraphQL. Then you have mutations, which is the root operation for changing data, that is insert, update, or delete. And then you have a completely different paradigm called subscriptions with GraphQL. These are for pushed updates. So say every time a book is added to my repository, or book is changed, or book is deleted, I want real-time subscriptions sent out to my clients. That is what subscription stands for. So instead of clients polling it, it is the server pushing it to the various different clients that are subscribed to it. At the very least, every GraphQL schema will have object types and queries, and that's what I'm going to stick to today. I'm not talking about mutations and subscriptions, because that would mean complete blowing of my scope of talk here. And all these four makes up what is known as types in GraphQL. So be it object types, queries, mutations, or subscriptions, what you have is types. These are all types for you. And types are made up of fields. Each field has a name, a scalar or complex type, which is the underlying data type of the field, and resolvers, which tells it how to resolve the field to a concrete data. So if you imagine my book object type, it might have an ID, a title, and an author type as the fields. If you look at the query type, it will have fields to read information about books, say a list of books. It can have a field to read a particular book or information about a particular book by its ID or so. And talking about implementations in .NET, I'm going to stick to Hot Chocolate, which is an open source GraphQL server for .NET. This is one of the more popular implementations of GraphQL in .NET. There is another one as well called GraphQL for .NET, which is equally popular and has been around for some time. So what I have here is a repo which I have put together. This is not something that I based off the template because I just wanted to see what the differences are. I just created a solution with an API and a Blazor app, and I made some subtle changes to it. The first thing I had to do is in my local settings JSON, I had to have the course headers. In my Blazor app, I needed to add the static web app config JSON, and I also had to put in the base address of my local host Azure function. So this is my local setup of my GitHub repo, and this should work. And in my API function, I have these 3 packages installed. Hot Chocolate ASP.NET Core, which is the engine for GraphQL. There's Azure Functions extension so that I can inject any dependencies into the Azure Functions. And I have also got a package called Azure Functions Proxy, GraphQL Azure Functions Proxy. So what this package does is it acts as a proxy and brings in Hot Chocolate HTTP middleware into Azure Functions so that the environment and the pipeline for Azure Functions is not disrupted. But in turn, we have this proxy which is brought in by this package, and that helps you process the HTTP context, which contains the GraphQL query, and then passes it on to the Hot Chocolate execution engine from where it executes. So every time a query comes in, this proxy takes place and then forwards the request on the Hot Chocolate execution engine, which then has knowledge of the schema that we have written. So it parses my GraphQL query against the schema, validates it, and executes it, and gets me the results back. We also have IDEs with GraphQL, and these IDEs is a lot more than a testing tool. We get things like syntax highlighting. So if I'm doing wrong things with my query, it highlights me. It has IntelliSense, so it's like a Visual Studio Code or Visual Studio in itself for GraphQL APIs. You have real-time error highlighting, you have schema introspection, and up-to-date documentation, and much more with any IDEs. There are lots of IDEs available for you, starting from Graphical, which was the first one to come out. There's GraphQL Playground, Altair, Voyager. Most of these are browser-based. Insomnia is a desktop-based IDE. Banana Cake Pop is also a desktop-based application to test your GraphQL query and understand more about your APIs, but it also has a browser-based version, I think, with version 12 of Hot Chocolate. We also need a GraphQL client to consume the GraphQL API, and in my demo, I'm using Strawberry Shake, which is again from the house of Hot Chocolate. And what it helps me do is generate a strongly typed C# client from my GraphQL queries. This particular tool is a lot more than just client generation, but I'm using it for generating my strongly typed C# client, keeping it very simple. The setup notes are here. It's on my blog. What I've also done is in my resources, which is again a bit.ly link, which I will share after my session. It collates all of these resources together for you as well, so you won't be losing out. So let's have a look at my demo, which is the last one for the day. So let's start off with the API. I've got all my packages right in my API. So as I said before, with any GraphQL API, we are implementing a schema. And for that, we need to have objects. So my objects for the day are books, which has got 3 fields, and an author, which has got 2 fields. Now I need to make these GraphQL types. And to make these GraphQL types out of these POCOs, what I need to do is create a class which inherits from object type, which comes from Hot Chocolate types. And then I give it the type T, that is book. And then I can start overriding data for each field. This method of creating GraphQL types is called, I think, code-based. And when I do my talks, I stick to this particular pattern of GraphQL type creation, because then my attendees would be able to understand that these are GraphQL types and these are fields in GraphQL types. And for every field in my book object, I am creating a descriptor. And for each field, I'm giving it a name. So I'm overriding the name here. If you look at my book class, it's got the capitals or the sentence casing, I think. But in my GraphQL query, I want to override the names, make it all lowercase, which is what I'm doing here. And for each field, I am giving it a type. And I'm also giving it a description. This description is super helpful. And this entire class is super helpful because what GraphQL does by nature is it queries this and gets information about this and presents it to you as readable documentation, which is so easy to understand and use for developers. Similarly, I've got a type for author as well. Now I can start thinking about my queries. So I have a class called query, to which I'm injecting a repository. In the repository, I have two methods, one for getting a particular book by ID, and the second one to get a list of books. And all this is acting upon a list of books in memory. And in my query class, I inject my repository, and then using these methods, I seek out to my service method. Now I need to make a query type out of this class, which is again done by inheriting from object type, overriding the fields. So for each field, I'm saying where to get the data from, what's the name of the field, and what's the type that it returns. So for get books, so as I said, in operation types like query types, what you still have is field. So we have fields for getting books, getting a particular book by its ID. We can probably include getting a particular author information or getting a list of author information and so on. So whatever you see, even in your operation type, is still field. So you have the name and the type. For getting a book by its particular ID, I also need an argument, which is coming in from my request header using the argument method. So that's all the object types defined. Now, in my startup class, I need to initialize the Azure Functions Executor proxy using the add Azure Functions GraphQL. I am registering it to my services. I am adding a scoped book repository service. I am finally adding my GraphQL server, and I'm also adding my query type. Once the query type is registered, it goes ahead and understands all the related types as well that it is working on, like book type and author type. And finally, my function, I need to inject the executor proxy, the GraphQL Azure Functions Executor proxy here. And that has an execute functions query async, which kind of then forwards the request onto the hot chocolate HTTP middleware engine and then runs it for you. So let's start this now. Got banana cake pop. Before I do anything, I need to stop this because port 7070 is not available for me at the moment. So let's have a look at banana cake pop first. So that's my GraphQL endpoint with Azure Functions. It is listening on API GraphQL. If I look at the schema here, it has picked up whatever I have in my query type, which is get books. If I click on it, it tells me it is returning me a list of books. So if you have something inside the square brackets, that is list in GraphQL schema. And if I click on book, I can then understand what the book type is all about. The author is again a complex type, so I can understand more about the authors as well. This kind of schema introspection and understanding about the schema and the API is extremely useful when you have a large API. This is a much smaller API, but imagine an API with thousands of fields and query types. This can be incredibly useful. Let's run some queries now. So that's my APN endpoint. And as you can see, it is a post. With GraphQL, everything happens over an HTTP post. Even reading data happens over HTTP post. And as you can see, what I've done here is I have started off with the query keyword, given it a name, a name of your choice for the operation. And then I start off with my field, get books. And for that operation, when I'm saying that when you get me the list of books, get me the ID, get me the title. And for the author, which is a complex field, get me just the name of the author. The author actually has an ID field as well, but I'm not bothered about the ID field. But this is what I have to do. I have to specify what exactly I want. If I take all these out and say, bring me everything, it won't do that because GraphQL is all about exact fetching. So if I put that back in and then try and run my query, it should bring me a list of books. And as you can see, the data is very similar or a mirror image of my query. Now, if I want to run my get book, that is get a book by a particular ID, I need variables passed in. So I can specify a variable here using the pattern here, which is a variable name preceded by a $sign. That is the way to introduce variables. And I'm saying the variable is of type int, and it is non-nullable, which is what is marked by the exclamation mark. And in the get book, I am setting the value of the ID argument to the variable, saying get me the ID and the title. And then I can pass in the variable as a dictionary, JSON. And let me now go ahead and get the data for book with ID 2. It is getting me the information I need. So this is GraphQL API for you. And if I go into my Blazor, there's a fair amount of setup that is needed, which is all put into my blog post. And I have my query here. What happens is for every query that I have in my Strawberry Shake client, it generates an operation service for me. And the operation service will have an execute async method, which brings the data back from the API completely deserialized so that I don't need to worry about writing another 1,000 POCOs to kind of line it all up. And in my fetch data, what I'm doing is injecting my client and then using the operation service in the execute async method, I'm getting the books and displaying that. So let's go have a look at my fetch data. It is bringing back the data for me. So I can try and deploy this as well into Azure Static Web Apps environment. So let's see. I think we are doing okay for time. Let's create an Azure Static Web App using the portal quickly. A resource group. Say static web apps. azconf demo GraphQL. I'm using free plan West Europe. I'm going to sign in with GitHub so that I can pick up my repo from here. I already have this in my GitHub repo, so it should get picked up. So I'm going to say master. Build preset is again Blazor. The app location is different in my case. So I think that's the name of the folder. The API is in itself. The output location is www.root. I'm going to review and create. What it then does is if I go to my GitHub portal and look for the repo, it should have the actions introduced. So this action file has got my secret token. So I'm not going to share this repo with you, but I've put together this code into a separate repo, and I've put that in my resources as well. So this should get everything deployed for you. That's the resource deployed. I don't know whether the code has been deployed yet, but while we wait for the code to be deployed, I can take any questions if there are any.
Hey Purnima, there is one question from Chetan. He's asking how to use JSON from static web apps.
So I'm assuming that Chetan is asking me how you can actually have a front-end app with JSON and Ajax. It is like exactly like how you would build any other static front-end app using these technologies. All you would have to do is choose the build preset properly when you do that, and if you have any the front-end task runners that you need to build your CSS and JavaScript, you need to stick to that. And there is a way to add that into your build pipelines as well. That is in the Microsoft official documentations for you as well. So I can direct you to that point if you want. I'm not a front-end expert by any means. I just have basic knowledge. I'm more of a backender. But if I go to Azure Static Web Apps documentation, if I go here, concepts, where did I see it? Build configuration. So that's the build configuration, and there is information about reports, and there is something that there we go, configure front-end frameworks and libraries. So that's all available here as documentations for you.
And there is a follow-up to that, how the backend connection is established in a static web.
Okay, so the web app itself, the front-end static app, doesn't have any kind of straightforward connection to your backend. It is all done via the API. And for the API, what you can do is in the configuration section, if you have any databases or even third-party APIs, which your APIs would connect to, that can be from here. And if you want your app itself to talk to a completely third-party service, I'm sorry, I missed that point there in my demo. In the program.cs, what I have in my Blazor app is this. There is a base address which I can provide. In this case, it's the local Azure function that I'm using, or when it gets to the production environment is the base address, the host environment. But this can be in a completely external third-party service as well. So where I can say, this is something like, say, HTTP API.something.com. It would be different from a technology to technology basis, but this is again completely possible. As I said, the managed API part is completely optional. You can connect your app to your third-party service, which is one of the reasons why I looked at static web apps, because I'm more familiar with that, because I bring in APIs from the Umbraco headless world into my static web apps, and that's been a point of interest for me. Does that answer your question, Chetan?
I hope so. Okay, that's pretty much the questions we had.
I'll post a link out to my resources in my Twitter feed so that you can have a look at the demo, any documentation, and whatever I could find in my prep as well. So that is it. Thank you for having me as a speaker, and thank you to the sponsors, the learning partners, and the communities, and a final thank you to the organizers as well for putting together such a fantastic conference. Enjoy the rest of the day.
Yeah, thanks, Purnima. It was very wonderful having you as part of our second edition of Azure Community Conference. Hope we will have host you again next year. Thank you.
Fantastic. See you then. Bye.
All right. All right. So moving on to the next session, we have Abhi joined the stream for the last session on track 9 in this year. And
Hey, how's it going?
hey, yeah, good. We will be taking you through how you can democratize ETL on Azure Cloud. And without wasting any more time, I'm handing it back to Abhi to take you through.
Cool. Is this good?
Yeah, it's coming.
Ooh. Can we? There we go. Okay, cool. Awesome. So, just as a heads up, I am really happy to be here. Thank you so much to the ASCONF team for setting this all up. It's been a pretty great process, and it is 4:30 in the morning here, so get hope so hang in there with me. I'm still waking up, but we will get started. So first things first. My title of the talk is called "Democratizing ETL on Azure Cloud." Now, there's a lot of words here. Maybe it sounds a bit buzzwordy, but I kind of want to unpack this entire statement. This is a concept of basically making ETL and data integration available to everyone and available to everyone's data sources and data destinations. This basically means that if you want to move data from one place to another, you shouldn't have to essentially go through any closed source means, and you shouldn't be limited in your desire to do so. But before we jump into that, I'll give a quick heads up about who I am. I am a developer advocate at Airbyte, so I essentially run a lot of our community operations. Don't really need to go into much there, but that's pretty much what I do. If you want to say hi to me, come join the Airbyte Slack, the Airbyte community Slack. We have a lot of people. If you want to talk data integration, if you want to talk data engineering, it's a pretty good place to do so. To give an agenda about what the talk's going to look like today, the first thing that we're going to do is we're going to jump into the difference between ETL and ELT with a quick primer for maybe those who aren't as caught up on the topic. It sometimes can be a bit of a siloed thing, so I don't just want to assume that everyone is caught up on that. We're then going to go into closed source ELT versus open source ELT. This is a important distinction that I want to make, and an important distinction that I think will allow us to accomplish the title of our talk, which is the democratizing ETL on Azure Cloud. And then I'll basically say like why open source. I'll make the argument for why open source ELT is perhaps the superior method forward. And then we'll go into the Airbyte architecture. We'll give like a quick overview of Airbyte. And then I will talk about developing what is called developing connectors, or developing the ability to move data from your specified data source into your specified destination. So I'll talk about building connectors. I'll talk about how you can create them yourself, and then I will finish off with a demo of deploying Airbyte on Azure. And we will go ahead and get started with the first topic, which is ELT versus ETL. And just to give a quick primer, ETL or ELT refers to extracting your data, transforming it, and then loading it. Where Airbyte is concerned is essentially just doing this one thing. We are an open source data integration platform, and we essentially allow you to perform the extracting, your loading, and the transformation. And so, why is this an important concept? We need to start from the beginning. About like 20, even like when you look back like 20 years ago, you've always needed to move data from one place to another. In order to enable any sort of business intelligence, we always have had to need to like basically pull our data from maybe a production environment to what people would consider a data science or analytics environment. This is a need that has existed for a while, and especially with the explosion of data, I hate saying like the big data, but it's kind of true. Like ever since the explosion of big data, this has been something that everyone is very, very concerned with, because there's so much valuable insights in marketing data, in our customer success data, maybe, or in financial data. There's lots of information to be extracted, and we can't be running analytics jobs in the same place that we run in the same place that we're running our normal production jobs, because analytics jobs in nature are going to be more bulky. So we wanted to create an environment that enables analytics. So what ended up happening is that we created ETL, and one of the biggest, and essentially ETL was created to enable speedy business intelligence operations after transformation. Um, the reason that the transformations kind of went in the middle is because once the person on the other side has received the data, so we extract the data from wherever that is, maybe a database, maybe an HTTP API, maybe another data, maybe a data warehouse. So we'll move that data to somewhere. Usually the destination is going to be a data lake, data warehouse, or maybe back in the day just a standard database. And we're going to be performing transformations in flight. Because your data is already structured on landing, anyone who's dealing with it in the destination doesn't necessarily need to worry about, I guess, cleaning the data up or transforming it. This can be really useful, especially for compliance. It's important to acknowledge that, because like if the data has already been transformed, there's no, maybe like you wanted to sanitize data in flight, maybe you wanted to mask private data in flight, and that's something that's really, and so any data that you'd be working with at the destination would already be sanitized. This is kind of an advantage for ETL over that. So basically, companies regulated by GDPR, HIPAA, CCPA, like they need to mask or encrypt these fields. So that's probably the main argument for ETL, but it kind of comes into a lot of problems. Let's just say that you want to change any of your transformations. This involves a data engineer going into your pipeline, and it involves bringing the data engineer into the conversation and saying, and for like a data analyst or a data scientist may need to like have that conversation with the data engineer, like, all right, can we bring down this pipeline? Can we change this transformation? And then that necessitates a rerunning of the of the replication, and necessitates like essentially a lot of friction. So this kind of very naturally leads into my next point, which is the lack of autonomy that this creates. So data scientists and analysts in this paradigm are not empowered. They are essentially beholden to, I guess, pinging the data engineer on Slack. So it's really important for, I think, in the current era, for data analysts and data scientists to be empowered and not be essentially asking the data engineers for basically to go like manage and tend to a pipeline. So, and usually these systems need to be maintained in-house. So that's another really important thing to consider, is that these are all often I think the amount of times that I've heard people are running ETL or ELT through like Python scripts, it's like it's a fairly lightweight way to do so, but no matter what, when you're going to change something, you are going to be modifying something that's, I guess, fairly complex and opaque to maybe a classic consumer of the data. So about really like a few years ago, we changed to a different paradigm, and that's the extract, load, and transform paradigm, where you're doing all of the transformation at the end. And the primary advantage of ELT over ETL is really around flexibility. And essentially all of the problems that I just mentioned are non-existent with the ELT paradigm. you really don't have to waste time re-ingesting data. And honestly, dealing with new information is not really a big deal. You can empower all of your data analysts and data scientists to perform transformations in essentially the new age, the new era data warehouses. So if like you want your data scientists or data analysts to be empowered, all you have to do is say, hey, here's all the data. Now you can perform any transformations, maybe in like Snowflake or Redshift, or and so like it's what ends up happening is that you are essentially empowering your analysts. You're empowering them to basically uh, do whatever they whatever they want to do with the data instead of needing to go through a data engineer. One of the next important things is that you make post-processing really easy. So let's just say that there are data type conversions during transformation. Immediately, if there's any issues, you're going to have to rerun your replication, and you're going to essentially be roadblocked until that replication stream is fixed. So if you have all of your data available at the destination, issues during transformation aren't really going to affect you. You can just kind of take the raw data again and then start processing. So you can always revert back to an original state. So now let's move on to closed source versus open source. Now, this is something that I think a lot of people don't know, but in the marketing landscape alone, so just the marketing domain, there are 8,000, at least 8,000 marketing integrations. So this is what we refer to as the long tail of connectors. With 8,000 integrations, it is not profitable for closed source ELT or ETL offerings to work. So, like if you think about like some of like the big names that have come up, like Fivetran or like Stitch Data, like these companies are mostly focusing on profitable connectors. So they're focusing on profitable data sources. Like, what do most people want to move their data from? What do most people like? What are most people like struggling with? But the problem is that there's so many different tools and there's so many different marketing tools that it's actually very difficult to cover some of the more niche marketing integrations without, I guess, doing it at a loss. So, for example, but one of the for example, if you are a company that has adopted maybe a up and coming marketing solution, or maybe like or maybe kind of you're like being an early adopter at a startup, you're not going to get support for an integration from one of these platforms. Additionally, there's issues around data privacy whenever you have a closed source ETL or ELT replication tool. You're going to be sending data outside of your VPC. And for some people who manage financial data, this can be a complete non-starter. So it's really important to, I guess, be able to self-host. It's really important to be able to come in, take something off the shelf and say, okay, I want to be able to modify this and change this for my needs. And honestly, it when you look at it, open source ELT like really addresses and solves a lot of these things. One of the most important things that it solves is the right to customize. So having the access and being able to edit your code is honestly a huge privilege that is really valuable. So let's just say like you want to move data from a Salesforce connector and it's missing some data that you need. With open source, all you have to do is really just submit a code change. There's been lots of times where like we have contributors in our community that will say, okay, hey, we need a new endpoint covered, or the API has been updated. Let's go in and let's change this, and they are empowered to do that without having to wait on like a support ticket. Something that's also really important is addressing this long tail. This is something that's really empowered by open source, because if we make it easy to develop connectors for data sources and data destinations, and we make it, and we put the power in the users hands, then we can naturally address this, because people will be incentivized to create integrations for the data sources and the data destinations that they're using. You don't need to go to any of these proprietary ETL providers you don't have to convince them that your connector is worth building. You can likely build it a lot faster than you can probably convince someone to create one of these things. Additionally, there's broader integrations with data tools and workflows. Open source products have to support like a wide variety of stacks and workflows for orchestrations. So you're going to find out of the box support for a lot of like random parts of your data stack that maybe that you wouldn't have had like these natural niceties with a closed source solution. Kind of going on, autonomy with debugging is extremely important, because as I mentioned before, if you want to change something or if you experience any issues, you don't have to wait for a customer support team. So this kind of works for both things, for like adding features and for debugging something. So, I mean, most cases we have like, we have a pretty strong response time on our Slack, but if you need that, people and community members who often are very familiar with these connectors, and they're very familiar with what kind of errors show up in the logs, like they're able to kind of like fix things themselves instead of again like going through the support process. And finally, we get out of the box security and privacy compliance. So we can essentially address any of the security needs, and data doesn't necessarily need to leave your VPC by deploying deploying your open source code to your infrastructure. So as long as everything stays within your infrastructure, you're never going to have issues with like with any sorts of compliance, especially with sensitive data or PII. So I've been using this word a lot, and I want to just make sure very clear that we have the same understanding on what this means. And in the Airbyte world, we use this term of a connector, and a connector is essentially a tool or a containerized piece of software that allows you to move either move data from a data source or move data into a data destination. So if we think about our Salesforce example again, if we wanted to move data from Salesforce, we need a containerized piece of software that can basically talk to the Salesforce API, discover the API, and tell us exactly what inputs the Salesforce API has, and it can tell us exactly what the schema of the Salesforce API looks like. It's really important that this is a consistent process, and it's really important that these connectors are consistently created. We want to make sure that a source and a destination are speaking the same language, because if you're trying to generalize moving data from one place to another, there's a lot of implicit and inherent conversions that you're going to be making. A lot of times APIs or databases or data warehouses will have a lack of support for a data type moving in for like a data type in the destination. So there has to be an understanding of like what will convert to what, or like what will the schema look like when you like put it into the destination. So a connector is essentially a containerized way for us to consistently speak this language between source and destination. And so to develop a connector or to create a connector for a data source is to essentially adhere by this protocol to bring into existence essentially an understanding, so that Airbyte can start moving data from this data source to any of its data destinations. It's really important to understand that these can be written in any languages. So currently, we mostly have connectors in Python and Java, but in theory, these connectors can be written in any languages. They just kind of need to be containerized. They just need to kind of fulfill some basic functions. And if they do that, there's kind of no more requirements outside of that. So once they fulfill these requirements, once you create like a binary that fulfills these requirements, it really doesn't matter what language it came from. So I don't want to go too deep into this, but I think the most important part that I want to describe is that the way that Airbyte works is that we expose a UI. Most operations are done through a UI. We set up connections. So we set up our data source in the UI, we set up our data destination in the UI, and then we can set up connections between any of our sources and any of our destinations in the UI. And the way that this happens is it goes through our temporal service. So for those unfamiliar with temporal is a microservice orchestration platform that's that we've baked into our product that allows us to essentially do retries really well and parallelize our workers. So now I kind of just want to focus very specifically on the Airbyte workers. So whenever you request moving data from a source to a destination, we spin up a worker to handle this connection, and so this is passed off to the scheduler, which hands it off to temporal, which hands this job off to an Airbyte worker. And I want to basically focus on that very specifically. So as I mentioned, a source connector and a destination connector and the worker, these are all containerized entities. The important thing is that a source connector will essentially speak the language of the API. It'll bring down the API. It'll tell us what information is available to pull. So if you think about maybe like Google Analytics, if you have a Google Analytics source connector, it'll basically tell you, okay, you can pull this information about your websites. You can pull your website traffic data. You can pull like your bounce rate, or for example, with the example that we're going to use later on, an exchange rates API. If you want to find information about a currency exchange, you want to this source connector is responsible for telling you what information can I receive about a currency? What is all of the information available that I can receive? And so it discovers the structure, it discovers the data types, and then it reads it in as a message stream. And this message stream is handed off to the worker, and the worker essentially is what's responsible for this translation. So I remember when I was talking about we need to make sure that a source connector and a destination connector are speaking the same language. So the source connector is speaking the protocol, saying, here's all of the information. I've displayed all of this information in a consistent way. And then the worker will come in, recognizing this, saying, okay, now I can hand this off to a destination. So the destination connector, because the source connector has displayed this information, the schema, it has displayed the data in a consistent way, it can now interpret this, and they can now make the conversions accurately, and it can now bring the data in. So now you understand why it's really important to create a system where all of these individual parts are essentially independent, and you can plug and play. So when we think about, I guess, moving into the next section, because of the framework, because we're able to make source connectors and destination connectors, these containerized, simple, very, very simple entities, we can make the creation of them fairly simple. So if you want to create your own data source or data destination or data destination, all all you have to do is fulfill some simple requirements. And when we kind of pull this back to democratizing this for Azure, we want to think about, like, you want to, if you can deploy Airbyte on an Azure VM, like, you should be able to move data from anywhere to anywhere without any other issues. Like, it should, the power should be in your hands with an open source ELT or ETL framework to essentially move data from anywhere and anywhere, and you should be able to create. You should have the power to create these if they're not instantly available with the catalog of connectors that currently exists. So this is very much a community effort. This is very much a something that everyone's working together on to fill out the, essentially, to fill out the capabilities of these connectors and to fill out the basically the different the variety of the connectors available, because we've learned that it's essentially impossible to do this on your own. It's impossible to do it profitably on your own. So we realize it's really just a community effort that we have to tap into. And so when we think about developing good connectors, there's some reasons why it's not profitable for closed source for closed source for closed source technologies to do this, or it's not really reasonable to do it without a specific protocol or a specific development framework. There's a lot of stuff that goes into it, because open source by itself can't solve this issue. It needs to be solved with a development kit. The barrier to entry for creating a connector is very, very high. Let's consider an example for a connector that pulls data from a very simple REST API. The very first thing, there's authentication. Authentication is not built equal among all products. Some authentication is a simple user and password. Some is an API key. And then others can be as complicated as implementing an entire OAuth flow. And this could involve securely storing and managing these credentials. Additionally, and this is something we're going to get into, but we don't want to be forced to pull all of the data every single time we want to replicate data from one place to another. We want to be able to incrementally add new data. So there's this concept of a sync mode. We want to be able to have the option or the flexibility to either pull all the data down every single time if we're okay incurring the expense of that operation, or if we can't incur that expense and we can't take that time, we want the option to only pull the new data, so we don't have to pull the same data over and over again. But this actually requires unique. This is actually a unique thing that needs to be defined per connector, because in order to figure out what data you've already replicated, you need to essentially track it through something called a cursor field. You need to be looking at either looking at it through a timestamp or something similar to that. You need to be identifying which timestamp you're going to be using and which one is going to be accurate for each connector. Additionally, we're going to have to be handling rate limiting and intermittent retry errors. So we can't be confusing those with real errors that can't be retried. Additionally, we're then going to be transforming this data into a format suitable for consumers, and we have to also be logging everything. We can't leave anything to chance. We need, because there's so many different places that connectors can fail. There's so many different like unique elements to each API or to each database or to each data warehouse that we need to be logging in everywhere possible, and we need to be exposing these logs so that people can take advantage of the aforementioned benefits of open source. Like if we can't empower our users to know what's going on with to know what's going on with their data integration platform, they can't self-serve. They can't go and just submit a PR to our repo. We have to empower them to have the ability to know what's going on. We need to tell them, okay, this is exactly what the issue is, and this is probably the path you need to in order to solve it. And overall, it kind of takes a while to build, and maybe not a long time, but for many it takes at least a few days to build a source connector. And of course, it needs to be testable. You need to have unit tests. You need to have integration tests. You need to test that it complies with the protocol, and that you can deploy it, that you can Dockerize it, you can containerize this piece of software. Which, yes, it is just kind of writing a Docker file, but wouldn't it be simpler if all of this was kind of like generated for you? You didn't have to kind of go into this blind. You can come in with the safety net of a framework, the safety net of essentially these tests being written for you, the protocol being a lot of the protocol being adhered for you. So a lot of this, essentially 80% of the code, 75% of the code is essentially boilerplate, incidental, and can be automated. So I guess that's exactly what we did. We created this thing called the Airbyte CDK, and this allows you to create connectors for your data sources and destinations. So there's a lot of repeated logic that this handles for you. And the first thing it does is that all you have to do is essentially run a generate.sh script, and it creates a package. It creates all of the directory structure for you. It then sets up a Docker file for you in a release pipeline. You can then choose what kind of data source or data destination you're going to be working with, whether that's an API, a database, data warehouse, and then we can build bake in normalization. We can bake in transformation, and then for the main functions that each connector needs to complete in order to speak the language. Remember when I was talking about speaking the language of the source to destination? We need to be adhering to a protocol. And how do we enforce that? And we can actually enforce that through code. We can enforce that through unit tests, through integration tests. And that is essentially what the CDK does. So we're gonna now dive into the CDK. We're gonna dive into what does it look like to build a connector. And that starts with the Airbyte protocol. So the Airbyte protocol for a source. So for this example, we're going to be walking through building essentially a data source connector. And there's 4 things that a source needs to be able to fulfill. I keep talking about speaking the same language, and the reason I keep harping on this is that you need to be able to very, very clearly expose what data is able to be retrieved from a source. But additionally, you need to define inputs that need to go into the source. So remember earlier when I was talking about you need to be able to define authentication. You need to be able to include inputs for API keys for these source connectors to even work, to even access your data. You need to define these inputs. For some simple connectors, you need to be defining analytics windows. So these are inputs that a connector needs to define. So this, and then you need to be able to. So this is encapsulated through the spec function that you can simply run by running Python main.py.spec. So we're going to be going, just as a heads up, we're going to be going through the Python CDK. There is one that exists for JavaScript, and as I mentioned, connectors can be written in any language. So, but for this one, we're going to be going through the Python example. I'm going to try to stay high level for those that aren't familiar with Python, and if you're kind of interested, or if I skip too quickly through some of the code, a full version is available in our documentation. So Don't worry if you don't catch all the information now. So like I mentioned, just moving back, the spec is what captures what are my inputs, and then we need to check that all of the inputs are valid. Can we connect to this source given the inputs that we're given? Like, so we need to guarantee a connection based off of the inputs, and then we want to discover the data. We want to, like, what data is available. So this is again when I'm talking about what can the data provide. This is in the discover stage. This tells us this is the data that's available, and this is what it looks like, and these are the data types that are available. These are the data types, and remember, again, we need the data types so that we can perform conversions if a destination doesn't support it, and that's going to be really important in the translation. And then finally, I guess most simply, we need to read data from the source API. So we're going to start off with spec. So don't worry too much about reading through every one of these things. This is essentially all you need to implement the spec function. You need a simple JSON file. So for our example, we're going to be walking through developing a source connector for the exchange rates API. And in order to and currently actually in existence, there is actually there is a API key required, but we're going to be moving through this as if there wasn't. So we're going to define two inputs. There's the start date and the base. So if you look into the properties, we have start date and base, and so what we're gonna do is we're defining the inputs for what is required in order to fetch data from this connector. We need to select a currency base, so we're looking for information about a specific currency, and then we need to select a start date. So when do we want to fetch data starting from? So if we want to fetch data starting from March, or want to fetch data starting from 2 years ago, we need to be able to input this. So any type of, and so if we were trying to implement authentication or authorization, we would also need to place it in here. We would need to basically have, like, okay, you need to input an API key. Do you have an API key that's valid? So, and the spec function so when we think about how the CDK can help us and how the CDK is empowering us, the spec function is automatically filled out. Is automatically functioned the moment that you create this JSON file. So then we need to check our connections, and this is done, and essentially, this is what verifies that our input supplied can be used to connect to the underlying data source. So you'll notice that that we have enabled in the CDK what is an abstract source. So this abstract source is what enables us to help people create sources, basically any data source. So all you have to do to create a data source is you have to implement an abstract source. And so within the abstract source class, we have a function that needs to be implemented, which is the check connection function. And since this is where where auth would be implemented, but since we're not worrying about auth this time, we're just going to be worrying about input currencies. So it's like we want to make sure that we have input validation. This is where you can perform any input validation. So in our example, we can just say, okay, let's only accept US dollars and rupees. So we can say we only accept USD and INR, and then we can just say if they're not in there, it's invalid. And so the way that this is exposed through the UI is that there'll be a button that says check connection, and this will actually trigger that function. And then it will, in this exact language, it'll basically spit out in the UI this specific error. So each one of these functions is implementing a specific functionality in the UI. Next, we're going to be discovering the data that we're going to be essentially discovering the data that's available to us. So each endpoint, so when we think about an API, each endpoint essentially needs to be defined. If we want to define clearly all of the available information, we have to do that on an endpoint by endpoint basis. So with the exchange rates API, there's only really one endpoint. So we can just focus on implementing the exchange rates stream. So each of these endpoints generally will map to a stream. And in the same way that an abstract source, we have to implement the abstract source in order to get a fully fledged source connector, we need to implement an HTTP stream in order to get a fully fledged support for an endpoint. And this will be essentially implementing some very basic functions. The path function essentially will tell us like what is the path to the endpoint. Parse response will just be, are we going to be doing any funky operations when parsing the JSON? So usually these aren't too complicated. And then we're just going to have to put all of our possible streams, all of the streams that we support, back in our source. So if you remember, I'm just going to quickly move back to this. So if you'll remember here, we're creating a class. We're creating this tutorial class. We're creating the exchange rates class, and then in this class, we're going to be defining a method called streams, and then we put all of these streams that we create into this method. Now, what does this do? This allows the UI to know all of the endpoints, all of the streams that are available. And then finally, to finish off the discover stage, this functionality, where again, I'm going to reiterate, the discover stage is for the connector to show all of the available information and in what structure and in what schemas all of the available information are available in. So what we need to do is we need to essentially declare the stream as with what properties can be retrieved. So these are so the discover method returns what's called in essentially this JSON file, or an airbyte catalog as we call it. We need to essentially for each stream, we essentially just need to create one of these. And as you can see, like we have defined the two currencies that we've found valid. So essentially if you go look in properties, you'll see the Indian rupee and the US dollar will be defined here. So this is again fairly straightforward. And then finally, we have to worry about reading our data. So this is going to be the final thing that we have to implement. And with that simple amount of code, we'll be able to read data from a source. And admittedly, this is a very simple source, but that's why it's a relatively small amount of code. But even as this generalizes into larger sources with more data, a lot of this framework is just the same. It's just about repeating this process. And so, as I mentioned, we'll be defining this path variable, this path function, and we're just going to be doing the /latest. So here we're going to be returning latest, which will append to that URL base. So if you look at the URL base at the very start of the function, we're appending latest to that to make sure that that's the endpoint that we're hitting. And then we're simply just returning, we're just returning the JSON with the parse response function, and we just we return and we have one final function which is called request params. This is just all of the parameters that the data source will need from us. And in this case, we just need to tell the data source what currency base we need. And finally, we will need a list in JSON of all of the streams that we support. So if we go through this, the name, we have the name of the stream. We have supported sync modes. So if you remember earlier, I said there's a difference between a full refresh, essentially where we pull the data, all of the data every single time we replicate, or if we want to do an incremental refresh. So if we want to pull data, only the new data. So that is defined. So that is, that is defined in this JSON file. So so if we look back, there's one JSON file associated with spec, there's one JSON file associated with discover, and now we are on this JSON file, which is associated with read. So these 3 JSON files and then the associated code is essentially all you need in order to create a source connector. And we'll see here with the properties, we're clearly defining the inputs that need to be placed in for the connector, which is the currency base. And we have the supported sync modes full refresh, because in this connector we have not gone through supporting incremental sync. And I'm just to in the sake of time, I want to start the demo of deploying Airbyte onto a Azure VM. So essentially, what we're going to do is we're going to go into an Azure VM, and we're going to go through how all of this looks in the UI. So now if I just going to change my share. Cool. Let's see. Cool. So here I've just here I think this is, I don't know how to put this. There's a bit of technical difficulty. If someone could help me figure out how to bring the new screen that I've shared into. There we go. Okay, so here's my here's my Cloud Shell. We're going to be, so essentially I've just spun up a VM of in the Cloud Shell, and I'm going to just connect to it. Let's see. Oh, I've actually already connected to it. So essentially what I've done is in this VM, I'm going to just be I'm just going to be creating a Airbyte folder. So we're just going to make the Airbyte folder, and then what we're going to do is we're going to pull, all we're going to do is we're going to pull one Docker Compose file from down from the repository. So we're just going to run this. So we've got the .env file and the Docker Compose file, and then we're going to do Docker Compose up, and that's about as easy as it is to deploy Airbyte. If you go to our documentation, it's pretty much this easy to deploy Airbyte on an Azure VM. You just need to essentially make sure you have a VM with the right permissions, SSH in there, and then just run get this file and then run Docker Compose up. The really powerful part of Airbyte is because all of our software is essentially containerized. You can pretty much run everything through Docker. This also does extend to Kubernetes. If you have a Kubernetes deployment, you can run Airbyte in in Kubernetes, and you can deploy over all of our containers and orchestrate them through Kubernetes. So now we're just going to be pulling this, and so what we're going to do after this is I'm going to go into my terminal, and then I'm going to just forward the port from. I'm just going to port forward so that I can access the Airbyte UI and locally. So now that we're complete, I'm going to now just very quickly in my terminal, I'm going to run. I guess I'm going to share that. I'm just going to switch. I'm going to switch sources again really quick. Sorry about that. So let's just share my full screen now. Let's share my entire screen. Then so all we're gonna do is in the terminal. I'm just going to essentially start up this port forward right here, and then after I've started up that port forward, I should just be able to go to localhost. So now we are connected to the Airbyte instance on our Azure VM. Just gonna put my name in here, and we can get started. So this is what the Airbyte UI looks like, but what I want to really dive into is I want to show you what each of those functions that we just created looks like in the Airbyte UI. So if you were to create a connector and you added it to the UI, and all you need to do this, by the way, is essentially just make sure that you build the Docker image, and then you make sure that your VM has access to this Docker image, and then the Airbyte UI can essentially check all of the images that you have access to and immediately pull it in. And so what we're going to do is we're going to set up essentially the connector that we just kind of mocked going through. And so here is where we have the spec. So remember the spec function where we're defining all the inputs. We have the start date. If you remember the start date and the base, these were the two inputs that were important. Again, we didn't talk about the access key, but I wanted to keep it pretty straightforward. So let's just say we wanted to pull date from March, and unfortunately we can't. Europe is the only one supported, so we're just going to go through that. I'm just going to paste my access key in there, and so this is essentially what is defined by that spec function. So when you're creating a connector, when you're creating something for your data source, this is what it's going to look like in the UI, and then this setup source button that directly maps to the check connection function that we created. This is the check function. So this is going to test the connection. This is going to make sure, okay, can we read data? So it's going to go talk to the endpoint, make sure that your access key is valid, make sure that your base is valid, make sure that your start date's okay. So cool. it's validated that we can pull data from there. So now all we need to do is add a new destination. So again, all the connection tests are passed, and we're just going to replicate data locally. So let's just say local JSON and JSON data. And in the same way, you have to implement this check function for destinations. So now we're going through the destination check. So if you were implementing a destination, you were creating a destination connector, you would be implementing that functionality there as well. And now here is the discover section. So remember the discover function that we're talking about implementing. We want to know what is all of the data that we can get from a data source, and what does the schema look like? This is essentially where that is borne out into in the UI. And here we can just select a manual sync frequency. We can set it to go like at any interval, and this is what, as I mentioned before, this is where the full refresh versus incremental differentiation is really important. And then we can go ahead and just set up the connection. We can launch it, sync now, and if this all goes well, we can just wait for it to succeed. There it is. There's succeeded. So, and we can just go to /tmp, terabyte local, JSON data, and there it is. It's not really human readable, but this is all. So we've just synced data from the exchange rates API to this VM, and this can be done with any data source or any data destination. And it's, as I mentioned, creating a connector and creating a source for any of the data sources that you need is fairly straightforward, and is just implementing those 4 things as I showed in the UI. And I guess I want to give some time for questions. I guess thank you so much for hanging there with me. I hope that was valuable. If there's any questions, I'd love to take them.
So, no, Abhi, there is no question so far.
Cool. All right. So yeah, that's about all I had. If there's no questions, or if there's any follow-ups, just you can go over to the Airbyte Slack community, and we essentially take questions all the time in either requests and feedback, or in Endeavor, any of the channels that have questions. If you want to just learn more, if you want to talk to other data engineers, talk about ETL, you can just head over to that community.
Yeah, that was a great session, Abhi. Thank you.
I appreciate that. Yeah.